Good morning, everyone. Welcome to 2-week Atal FTP on agricultural PV systems and electrical vehicles, pioneering sustainable energy and transportation solutions. So far, we have completed the 4 days. In the 4 days, we have completed the eight theoretical sessions and the eight article discussions. Welcome to the fifth day Atal FTP. Today we have the Dr. Ramesh sir with us to share the knowledge. All of you try to interact with the sir. Sir has a the good publications in the electrical vehicles and electrical power systems. Dear participants, those who are near to the Guntur, you can utilize the bus facility also. All the bus are starts at 8 p.m. Make use of this facility also. It is my great honor and pleasure to introduce our resource person, the Dr.T. Ramesh Garu, who is a distinguished academician and expert in the field of electrical engineering, and he published many papers. He is not only a good academician, he is more than that, he is a good human being. Dr. Ramesh Garu presently working as a head of the department of Triple department in NIT AP. In addition to the academic achievements, the Ramesh sir has actively involved in various the funded projects. He guided many BTech and MTech and PhD students. Uh, Today, the sir will share the many things related to the electrical vehicles. Let let me invite Dr. Rajni Madam and Dr. T. Ramesh Garu. I would like to, Madam, share a few words about the SAR.
Good morning, dear participants. Today's resource person is Dr. T. Ramesh sir. He's a very good academician and researcher, and he is a HOD of Triple in NIT. So he is a guide, PhD guide for me, and he will give very good guidance, and he has a very good knowledge in PV systems as well as EVs. So utilize this opportunity and grab some knowledge from him. Thank you, sir.
Thank you, ma'am, and
Sir,
thank you,
I
sir,
request
for the.
you to start the session.
Thank,
Today's session give some introduction to the session and start the session, sir.
sure.
Thank you for carrying from third floor university, sir. Please try to share the knowledge to the participants. Sir, most of the participants are doing research work in field of electrical vehicles. Dear participants, try to interact with the sir. Sir will give many directions to you. Definitely at the end of the sessions, definitely we feel that we will get some knowledge. Definitely because sir published the many papers related to electrical vehicles. Sir is got many funding projects. And also sir established many laboratories in the NIT. Try to utilize the knowledge of Dr. Ramesh Garu. Thank you, sir. Thank you for listening.
Thank you, sir. Thank you so much. ఇది వాయిస్ అడుగుతుంది గట్టిగా అంటే వీళ్ళ కోసమా. Okay, good morning, one and all. First of all, I would like to thank Vignan Lara Management and Department of Electrical Engineering for inviting me as one of the resource person in this FDP. So, I'll try to cover the topic solar powered AC drive for agriculture and EV application. So majorly I focus on the EV application side. So I'll little bit touch about why the solar power is essential for the drive applications and the agriculture also. So let's start the session. And these are the contents I'll try to cover in this session. then really why the world is moving towards to the EV. Instead of IC based engines, why the EV is much important, we will discuss. Then in the EV there is a drive, the motor we are using in place of IC based engine. So what are the types of drives are available in the literature, and which one is the best for the EV applications we will see, and then what are the different types of control methods available to control the drive also we will discuss. Then we will also see the hardware implementation in the laboratory with the support of SEB. We have at the same time there are faculty members who are working with the MTech, and they are motivation of doing the higher studies like PhDs. So for them also I'll give certain guidelines how to approach for the higher studies. Okay, so though we need to have some certain background work before attending the interview. And then, so let's see one by one. As we all know, being electrical engineering student, we are and faculties, we all know the importance of the solar power. So as of now, we are relying on the thermal, hydro, and the nuclear. But solar also is one of the major thing, and the government of India is really working hard towards this. So we all know the renewable power generation from the PV system in various ways. So the majority ways is the panels are mounted on the ground, and that is the major way we are generating the power of renewable energy. And the second one, we are utilizing the rooftops. In our institute, NIT Andhra Pradesh, we have 1 megawatt power we are generating from the means capacity of the panels we have installed at NIT Andhra Pradesh. So 1 megawatt contained in the rooftops. Okay, so this is the one way we are generating the power, and then recently people are very thin plates are coming in the solar panel. So that sorry, that can be installed in vehicle. For example, one vehicle with one charging time it may travel, for example, 100 kilometers. If solar panel is mounted on the vehicle, then there is a chance to go another 30 to 40 kilometers while running. It can be charged. So that is the third way, that is vehicle integrated PV system. And then the I think as of now many resource person has discussed the fourth one, that is one of the topic of your MPP is agri photovoltaic. Okay, so this is also majorly increasing nowadays. So means we can generate the power, at the same time we can do the agriculture. So if you see this slide, in a day, 200 million work hours are wasted doing by women for carrying the water for their family purpose. So for them, being researchers or engineers, we can support them means in passing the waters. Okay, so they are traveling a lot to carry the water. We are seeing in the newspapers. Okay, for them, so we can do something like one of the application we can do solar water pumping system for their household application purpose, and the government of India is working towards that. So in many states like Rajasthan, Maharashtra, so in such states they are already given the some they have started some pilot project and installed. I'll show you the slides. So here in this water pumping system, we are using the drives, the BLDC motor especially. So from morning to evening, the radiations are not exact same. So we can operate the BLDC motor based on the energy available from the solar. We can control the speed of the BLDC motor such that we can operate the from morning to evening time. So that control we can make. So in the solar water pumping system, majorly people are using BLDC motors. So this is the we have developed one setup in the at NIT Andhra Pradesh. So here you can see this image. This is the solar tree. So why we have done the solar tree instead of the land mounted? I'll tell you the little bit later on. So here majorly we focus to provide one solution for the water pump. Though it is available in the literature and many people have done, so we are also parallelly doing. So how best we can provide a solution for the water pumping system. So in the laboratory we have done this setup. So here, this is the 960-watt solar panel we have mounted on a tree in a small space. Okay, so you can see this only one pole is consuming hardly 2 by 2 feet. Okay, this is not much space it is consuming. But if you mount a solar panel, each panel size may be 4 by 6 feet. So that produces the rating is 335 wattage. So for to get the 960, at least we need to connect in a three. Okay, so three panels we need to connect in the land. So it consumes more space, at least 10 feet by 15 feet minimum. But if you go towards the solar tree, so we can install a 960-watt capacity solar panel on by using the solar tree. So this is the beauty of the solar tree. So the government of India is also working on solar tree also. The especially CSIR is working on the solar tree. Okay, so here we are utilizing the boost converter to boost the voltage, and then inverter as the supply for the drive is we are providing the AC, the BLDC. And these are the applications where we are utilizing this water pumping system. So drip irrigation we are using, and these are the applications we are using for the water pumping system. And these are the certain advantages of why we need to go for the water pumping system, as this is a jet construction, and then highly reliable, and no maintenance is required. So this is required less maintenance, and the most important is eco-friendly. Okay, so these are the certain advantages why we need to go for the solar water pumping system, especially the certain states like Rajasthan and Maharashtra. There, the availability of the power is less compared to our states and the water resources. So for us, the plenty of water is available, but certain states it is very difficult to get the water. So for them, this project is really helpful. And what are the different applications are utilizing this solar water pumping system? So for irrigation, for the domestic water and fish farming and swimming pool, etc., etc. Anywhere we can install this solar water pumping system. And as I said, the government of India, not only government of India, certain other countries also installing the water pumping system by using the solar. You can see the image. These are the pilot project initiated by the governments. So this is the first one. Coimbatore, the India has installed the water pumping system for the, and it is the beneficiary of the 400 school children. And one more is they have installed for the household purpose. So this is the place in the India, Mahuda. So that is for the household purpose, and this is the Senegal. 300 villages are getting water from the water pumping system. Okay, so these are the certain example. So huge manner countries are using the water pump, solar water pumping systems. And then there are certain ways to generate, means parallelly agriculture at the same time the power generation is happening in the same time. So these are the different countries are doing in different ways. So here see this example, in this example to generate maybe a 5 kilowatt or a 10 kilowatt power, they are wasting this much land. Okay, so in near future, the scarcity of the land may occur, especially in cities, major cities. Okay, so instead of installing the on ground, so we need to see the alternate. So the alternate is the solar tree. So instead of mounting on the ground or in the rooftop, so it is better to install in a solar tree manner, because in a small space we can construct. This is the 11.5 kilowatt they have installed in a small space. Okay, so this is the recently implemented by the CSIR with the support of CVRI. And so, as we know, the government of India is taking the challenge to increase the solar power. As of December 2023, we have achieved 135 gigawatt, though we have planned for 150 gigawatt, but we could not achieve that one. But government of India is strongly going forward, and they have kept the target 170 gigawatt power generation from the renewable sources like solar. Uh, we hope it may achieve that goal of 170 gigawatt power. And so there, in addition to the ground mounted, so better to go for the solar tree panels such that initial cost will be high as the number of leaves, the mechanical support required for the solar tree is high. But at the same time, we need to see in the cities majorly there are parking places are required. So in the parking places, we can connect the solar tree so that vehicle can be parked under the solar tree. We can utilize the ground portion for the farming purpose. Okay, or we can maintain the ground. Okay, such good thing can be done for the by using the solar tree. And in the highways, for generating the power, we can utilize this solar tree. Okay, so much space is not required. So in the highways also, we can utilize the solar tree concept instead of mounting in the ground. And these are the certain example you can see the foreign countries how they are going solar tree manner instead of flat mounted on ground. So you can see this is connected in the highway. It is in India only, and so some other countries also made a solar tree. So by taking this example, NIT Andhra Pradesh has made one solar tree of 960 watt, and we have succeeded in that. Okay, so now the government of India through CSIR they are installing the solar tree in farming field also. You can see this is also around 5 kilowatt solar tree, and you can see the small space they have consumed for installing this 5 kilowatt solar tree. And the under the solar tree they are utilizing for the agriculture purpose. So there is no wastage of land while going for this. Of course, the initial cost will be high while going for the solar tree. And this is the there is a track record. The huge solar tree installed by the government of India through CSIR, and in this solar tree we have a Guinness Book record also. Okay, so this is installed in the Ludhiana, and these are the certain examples of solar tree. And for the statistics, how the government of India is working for the renewable energy. So this is the data I have taken from the source. That source also I have given. So this is the power generated up to October 2024. And which are the major states majorly focusing on the renewable energy side? So as Rajasthan is first, Rajasthan, Gujarat, Tamil Nadu, Karnataka, of course other states are also there, but these are the major states are capturing the portion. And the government of India is really encouraging the people. Recently, we heard Surya Ghar Mukti Bijli Yojana. Okay, because of this scheme, people are coming forward to install the solar panels in the rooftop. Okay, so maybe all we know this, and many people are coming forward to install that one because 80,000 to 1 lakh rupees maybe they are getting. I think 80,000 rupees seems. So based on the KVA rating, we are getting 80,000 to 1.5 seems. Okay, exact figure I don't know, but minimum 80,000 I can sure. So there are different schemes they are initiating to encourage the to generate the power through renewable energy sources. And in what, as I have taken one example of water pumping system, so there are different drives are available. As we being electrical engineering, we know all these drives. So DC drive and the induction AC drives are induction motor drive, PMSM motor drive, and BLDC and then switcher reluctance. So which one is the best for the water pumping applications? So I can say as the water pumping applications, we require the small load at the same time high speed. Okay, means when the sun rays is good, then we need to operate the motor in a high speed. When the sun rays are less, then we need to operate in the low speed. So in that applications, the BLDC motors works properly as compared to this induction and the PMSM. As we know, why people are not using DC motor, so we all know the high maintenance is required for the DC motor. 95 to 98% of the industries as of now So maybe 1 or 2% industry still may be using DC motor, but 98% of the industries are utilizing AC because they want to remove the means they need to reduce the maintenance part as this DC motor require commutators at the presses. And then why means the BLDC motor is suitable for the low power rating applications only. Why? Because what is the input of BLDC motor? There AC only. Okay, but what is the sine wave? Whether we are getting the pure sine wave for the input of the BLDC motor, we are getting a triggering because the electronic commutator we are using to get the AC supply for the BLDC motor. But in case of the induction motor and the PI conversion motor, the input supply itself pure sinusoidal wave. So for the high power application, it will not get means the input is not pure sinusoidal. So we cannot utilize the BLDC motor for the drive application, especially more than 3 wheeler. The 3 wheeler up to 3 wheeler, the power rating is less. We can go up to 10 kVA. Okay, 10 kilowatt. We can of a 10 kilowatt vehicle we can go for the BLDC. If you want to operate a vehicle more than the 10 kilowatt, like now all the four wheelers, minimum of 50 HP, minimum of 70 HP or 80 HP. Even Tata Tiago is 50 HP. So Tata Tiago is operating with the motor rating is 50 HP. So in that 50 HP, okay. So 50 HP motor means the BLDC motor will not operate at that means will not give a proper output. That's why the industries means especially electric vehicle application, people are using either induction motor or the PMSM. Or certain companies are using still SRM, but major portion captured by the induction motor and then PMSM motor. Okay, because of the reason is that it's physical construction itself. So inputs is trapezoidal wave we are getting to the BLDC, which will not give the high efficiency. Okay, and this is the laboratory setup we have implemented in the lab. One of the PhD scholar is working. So here, as Rajni worked on the different partial shading conditions. So here she has implemented different partial shading conditions. Means we how best we can extract the maximum power from a solar panel. And then the same work another student has implemented in terms of the hardware. Okay, so they are still working on it. And in addition to that, recently in the department we have procured one electric vehicle, four-wheeler, and here certain modification we have done. So here, earlier initially we have purchased with the BLDC motor, but we want to go for the high rating. So how can we modify for the high rating? Then here, as the BLDC motor, if you want to implement more than 10 kilowatt, then there is a drawback with the BLDC motor. That is, as I said, it's physical construction itself. So we have replaced with the PMSM motor first. Then we have replaced with the induction motor also. Okay, which is giving best and uh, with the PMSM motor because of this battery size available here. So we are traveling around 45 kilometer for full charge. So now we have replaced the means we have mounted one solar panel of 335 wattage and this is parallelly charging the battery. Then because of this 335 wattage solar panel, we can travel more 30 to 40 kilometers. Okay, while driving. Okay, so together we can approximately we can travel the 80 kilometer with the solar panel mounting on the electric vehicle. So this is the one advantage where the charging stations are not available in your traveling route. This is the application majorly support to travel more distance. And these are the certain companies who are installing the thin flame solar sheet on the vehicle to charge the batteries while running. And the future will be definitely the future electric vehicles are come up with the solar panel for sure. And this is the Tesla one company, this logo seems Mercedes only. So this is the one example I have taken. And this is the drive application. We are majorly focusing one of the channels is working. So based on the solar power, can we operate the AC drives in a proper way by utilizing the control technique, different control techniques. So this is the solar powered AC drive for EV applications. We are working on it. And here we have connected the induction motor and the PMSM motor. And then why EVs are important? So as we all know, this is the carbon footprint released by the different ways. Like the transportation is capturing 34%, and then electric power generation, maybe thermal and other sources, they are releasing the carbon footprints are 38%, and then industries are releasing 70.8, and the residential and commercial like that. So there are different portions. So now the transportation itself capturing a 34% of carbon footprint. Now somehow if can we able to reduce this percentage? So by converting the IC based engine into the electric vehicle, then we can somehow reduce this percentage. Then we can support to the gain towards the greener. Okay. So these are the how the electric vehicles are inspired. Basically, our children are playing with these toys. How these toys are operating with the support of the batteries and which is connected to the DC motor. Okay, so from this concept, the electric vehicle has been inspired and electric vehicles are generated. Now, so why EVs are more preferred? You might be heard in the newspaper through the newspapers. Last 2 weeks back, our capital city means the Indian capital city, New Delhi, has closed 2 weeks classes. I mean 2 weeks schools. School has been shut down for the 2 weeks and there are number of flights are diverted. So what is the reason? Because of the pollution. Okay, so this is the our situation. So how can we come off out of that situation? So we need to support in some manner. So that manner by turning the IC based engine into the ABC. So we have read in the newspapers that by the usage of odd and even rule, the government of Delhi has succeeded a little bit reduction of the carbon footprints in the Delhi. Okay, so why this is possible? Because they have controlled the means by implementing the odd and even rule, they have reduced the number of vehicles running in the city. Thereby, the pollution has been reduced. Okay, so what I point is that instead of using the IC based engine, if we prefer for the EV, then this portion can be reduced. So you can see this is the IQ Air Study 2020. You see the IQ Air Study 2024. The capital city New Delhi places the top. As of today, also placing the top position. Okay, so this is the situation in certain cities. Not only the Delhi, you can see the second slide in very soon other states also means Bangalore and the Mumbai also coming next to the Delhi. Okay, so we need to reduce this pollution somehow. We cannot shut down the industries as it is required for the growth of the country. So we need to see the alternate. So alternate is that is instead of going for the IC based engine vehicles, we need to go for the electric. And thus, I strongly being electrical engineer, I can say that future will be electric. So, because of the pollution, you can see the number of death rates happening in various countries. So, India is placing the top position as of now. 2.5 million people have been dead because of the pollution as of now, and the second place is China. So, why these two countries are placing top as our population is more as compared to the other countries? Of course, pollution rate may be high, but population also we need to see. Okay, so that's why that is placing a huge range. And see the two images here. So this is the images during the winter season, and this is the image after rainfall. In during the winter season only after the rainfall. We have heard recently the government of Delhi has planned for the the artificial rain happens, then they can reduces the pollution in the city. Okay, but that was not implemented. It causes the different problems. So that was not implemented. Somehow the pollution was reduced in the Delhi because of the environmental support. So this is the during the winter with pollution, and this is after rainfall. And what are the ways we can support to the environment for reduction of the carbon footprint? So that is one way is by using the advanced internal combustion engines, we can reduce up to 15%. By utilizing the natural gas and biofuel vehicles, we can go between 10 to 30%. And if you use the hybrid, that is fuel plus electric, then we can support with the 30 to 40% reduction of the pollution. And then fully electric, then there is a chance to 50 to 100. Why I am not saying 100%? Because we are not charging the electric vehicle through the solar power generated. The electric vehicle being charged through the power generated from the thermal. Okay, so if we charge our electric vehicle through the support of the thermal, then what is the green here? Here we are not burning the fuel, but we are burning the coal for the generating the power. So we need to see the alternate. So charging station, the number of charging stations has been created at the, throughout the highways. Okay, so those charging infrastructure should be created with the solar instead of taking the power from the grid. Then we can go for towards 100%. And then last one is the hydrogen. So fuel cell batteries are coming. Then because of that, we can go for between 50 to 100. So these are the statistics to reduce the pollution. And then, as I said, the future will be the electric. Okay, so why electric? See, one example, lifetime fuel consumption. Imagine 30,000 liters has been burned. So, what is the cost of 30,000 per liter? 100 rupees. Now it is 115 rupees. Of course, in few states, especially in Andhra Pradesh, around 110 rupees. So they are spending 30 lakhs rupees. For the same duration, if it is an electric vehicle, then they consume 70 megawatt hour. So the cost of that one is 4.2 lakhs. So the difference between this fuel price and then electric price you can see. So the payback period you can get easily, quickly back compared to the IC based engine. But here, at what situation we will get the payback period quickly? A person is traveling utilizing a vehicle 5 kilometer in a day. A person utilizing the electric vehicle 60 to 70 kilometer in a day. Who will get the more benefit and who will get the payback period is less? That is the person who is utilizing the more than 50 kilometers, 40 to in between 40 to 60 kilometers. Okay, for them basically electric vehicle is really useful. The person who is utilizing the vehicle for only 5 kilometers traveling, then for them the electric vehicles are not suitable because the payback the amount they are spending for the electric vehicle is more. Okay, so if a person is traveling as average in a day 40 to 50 kilometer, 100% for them electric vehicle is best. I can say one example. My friend Dr. JAYABABU, of my colleague at NIT Andhra Pradesh, he is traveling from Tadapur to Tadipalligudem. So distance between Tadapur and Tadipalligudem around 20 kilometers. On average, he is traveling 40 to 45 kilometers per a day. Okay, so he's earlier he used to spend 400 rupees for petrol, but now he is charging 9 unit. For 9 unit, he will charge fully. So in the 9 unit, he can travel around 120 to 130 kilometers. So he is charging at home only. So what is the economic price? 2.3 to 2.5 to 3 rupees maximum we are paying if it is not commercial. Then hardly he is paying less than 50 rupees. So see the difference between the petrol and the electric. So the person who is traveling more than 40 kilometers, for them the EV will be the best. And then rising fuel prices as we are experiencing, and then the another advantage we will get from the EV is we can reduce the carbon footprint. And then then history of the electric vehicle has been started long back. So basically, it is started in the 1837. The person Robert Davidson has started the career, and he has created one electric time car. And then after 40 years of his invention, so the inventor Thomas Parker has created has manufactured automobile in the London. Then the first electric car was invented by the USA. That is invented by William Morrison. And why the major factor that attract EVs? So what are the major factor really attract the EV? The first one is the being electrical engineers, we always see the reliability. So reliability and the flexibility. So here in the electric cars, the number of parts is required less. Only motor, battery, and then converters is and charging ports. So these are the parts required for the electric vehicle. So these parts really require maintenance. Okay, so the maintenance required for the electric vehicle is less, so obviously reliability increases. And then the flexibility, as the new models are coming day by day. In the Tata itself, Tata Nexon is there, Tata Tiago is there. Okay, so in the different Tata Tiago is giving around 160 kilometers, and the Tata Nexon is giving between 350 to 400 kilometers in one charge. Okay, so middle aged people can travel through EV by Tata Tiago, and little higher means the Tata Nexon is coming between 14 lakhs to 18 lakhs. Another no, Tata Punch also released recently. Okay, EV Tata Punch EV also is available. The cost is around 14 lakhs. So different models are coming from the OEMs. OEMs means Tata and Mahindra, etc., etc. in our country. And then growing infrastructure. So anything the people will attract when there is a facility is there. If see student, why the student join in particular like Vigyan? Because here faculties are good, facilities are good, laboratories are good, and placement is good. So student will attract to join this college because of these facilities. Similarly, why a customer turn towards to the EV? One person traveling a longer, see, we are not purchasing vehicle for traveling only 50 kilometers. Sometimes there is a requirement of travel 200 kilometers also. So during that time, we cannot ask someone to give me a vehicle to travel this tour. Okay, so there need to be infrastructure creation should be there. Means the charging IC based vehicle, we are filling that fuel in between. Means there are 70,000 of fuel stations are available in our country. Imagine 70,000. So, in a similar manner, we need to create the infrastructure of charging stations, electric charging stations. So, thanks to the India government, I am not fan of the India government, but thanks to the India government, they are really looking towards the enhancing the highways, and then they are creating the electric charging infrastructure towards the highway. In between Tadepalligodam and Vijayawada, we can find two charging stations, electric charging stations. The travel between Tadepalligodam and Vijayawada is 100 kilometers. It may 2 hours traveling. In between, you can stop for the half an hour. You can charge 1 unit or 2 units based on the charging capability. Okay, so then we can safely go back home because the round trip is 200 kilometers. Tata Tiago is giving 140 kilometers for one time charge. Okay, so in between you can charge, then safely you can reach home. Okay, so we need to have a charging infrastructure. So this is the government is really concerned, and in recent budget also they have allocated 1,000 crore for the creating charging infrastructures and then affordability. So the common man always think about the price. Okay, so the Tata Tiago price. Why I am always mentioning Tata? Because I am big fan of the Tata, and the Tata is a pride of India. And because of the Tata Tiago, the cost is around 9 to 10 lakhs. My dad purchased 1 year back, that is 9 lakh. In the because government incentives, the government is giving 1 lakh rupee incentive for the four wheeler. Then he got 1 lakh around, and he has purchased the Tata Tiago in 9 lakhs. I have purchased the Tata Altroz, because I am staying in the Tadepalli itself. So for me, the EV is not mandatory because I rarely travel to home. My traveling distance daily 5 kilometers or 3 kilometers. So for me, it will be waste. So I have purchased the Tata Altroz by spending a 11 lakh rupee. Okay, so it means the point is that affordability. So people think EV, okay, it will maybe the cost is high if we go for the EV. It is not that. So it is cost. There are different vehicles are available in the affordability price, and there are different models also available, and which attracts the public. And then of course we can enhance the public health by going the EV. And I have taken one example of two-wheeler. This is the data of the long back data. So now we will not get the petrol vehicle or the petrol two-wheeler in 60,000. Okay, it is the long data. So at least we need to spend 1 lakh rupee to get the two-wheeler. Okay, this is the long data I have taken for the comparison purpose. And here the lithium ion battery two-wheeler is 87, and then lead acid 35,000, and then petrol is 60,000 for the example purpose. And imagine in a day a person traveling 50 kilometers per a day. Then the price also you see the petrol price is 60 rupees. It means almost 5 to 6 years back. Now it is almost double. Okay, so petrol price I have taken 60 rupees only. So if you consider today's rate, then it will be again increases. So in a 5 years period, how much they are spending by using the petrol vehicle, and how much they are spending for the electric vehicle like lithium ion, lead acid. So you can see the figure by using the electric 1,13,000, and by using the petrol 1,75,000. So see the difference. Okay, so the payback period you will get quicker when you are traveling more using the EV, and we can support towards the environmental growth. And these are the EV sales in entire world. So the percentage of EVs, like EV means not only two-wheeler, three-wheelers, the four-wheeler, buses, trucks, heavy-duty trucks. Okay, so in the different manners, the people are means manufacturer OEMs are making manufacturing of those heavy trucks also, and people are purchasing it for better utilization. And why people are really purchasing these things? Because of government incentives, that is government policy support. So we have our policy support. Why the Tesla is not entering into India? Why Tesla unable to enter into the India? Maybe Indian people can't afford that much. No, see, don't underestimate the people of the India. There are in Vijayawada, if Tesla vehicle comes, then it will find hundreds of vehicles in the Vijayawada. Maybe he asked for more incentives from government. Production linked incentives. You might be heard this word. Means start production and sell here and import from here. Then what is the advantage we will get? We will get the advantage of not only export, first employment. See, if one company started, not only the employee will get the salary, surrounding people through the traveling, through the sideway roadways people. So if one company 5,000 employees is there, then more 10,000 people will rely on that company in addition to that 5,000 employee. Okay, so in other different ways like vegetable markets and shopping malls, etc., etc., etc. Okay, that is one way. And the second way is, of course, when Tesla is coming to the India, then our export will also help. Okay, so these are the government initiatives. So thanks to means they are still on that rule. So because of this rule only, he unable to enter into the India. He is saying that I'll manufacture in the China and I'll pay the duty charges more, but I want to sell the vehicle here. But who is paying that duty charges? Obviously, customers. He is not paying from his pocket, right? But what we want from the manufacturing here. Okay, so So because of that reason only, he unable to enter, even though after several meeting with the Prime Minister of India in USA and other time also. Okay, he's a smart fellow, and of course we all know. And so his tasks are not happening in India. So here the second one is the improvement in the battery technology, and then more charging infrastructure is created in by the government. And then the final one is the exciting models attract the people. So because of this reason, EV sales are increasing day by day rapidly. And you can see the statistics, the passenger EV sales by 2020. While the China is capturing one point, means the top position. See, Europe country is placing the top, but Europe is not the single country. It's multiple branches. Okay, but China is a single country, and you can see the portion 1.33 million vehicles are being sold by 2020. So still, as of today, also China is dominating in the EV sector because they have started manufacturing in early 2010 before itself. But unfortunately, government of India also started their EV initiative in the 2010 itself, but due to the politicians political affairs, it could not materialize. So so China still dominate the EV market, and you can see the global stock of electric vehicles stood at 17.7 million by the year of 2021, and then you can see the 6.5 million electric cars were sold by the year of 2021. So the majority portion happening in the China. And you can see the who are the early adapters. The China is the early adapter of EV vehicle, and these are the countries started later on by testing, means whether it is more feasible or not. USA, we always say USA is the advanced country, but USA also started late compared to the China, and see their percentage it is 4.6 only. And then the heavy users are the Switzerland, Germany, Netherlands, and this Switzerland we have seen in the newspaper. They have constructed a separate line for the charging means the wireless charging. Okay, there is a one road they have in three ways. One way is dedicated for the wireless charging purpose. So person need not to wait at some place to charge the vehicle. So in that way, the countries are thinking. So one dedicated line has they have installed for wireless charging purpose. Okay, so this is the way EV vehicles are dominating, and then earlier governments are pushing the public to purchase the EV vehicles, but now people have got the awareness and they are purchasing a lot of electric vehicles. See how much government is spending. This is 30 USD billion dollars. But how much consumers are spending? $250 billion dollars. It means earlier government used to push the public to towards the electric vehicles. Now public got the awareness and they are purchasing a lot. And this is the sales up to 2022. And this is a projected period up to the 2023, and it is reaches around 15 millions. And EV vehicles basically not only cars, means two-wheeler, three-wheeler, and four-wheeler. Of course, trucks also is there. So basically, SUVs in the China, especially, the people are purchasing SUVs. So the sales of the in the car, SUVs sales are more in especially China, and if the bigger vehicle is there, then we need to have a bigger battery. Then our mineral will be being utilized quickly. So because of this heavy vehicles, so cost of the lithium ion batteries also increasing, and because manufacturing is reducing and utilization is more, so maybe very soon we may get the reduction. And electric means transportation means not only cars and the two-wheeler and three-wheeler, now buses also there. In every state in the Vijayawada also we can find the electric buses which are traveling in the roads, and the trucks also we can find the electric. And this is a portion of the medium duty trucks or step vans, which are sold in the 2019 to 2022, you can see how it is increasing from 2019 to 2022. So day by day it is increasing. People are purchasing the electric vehicles.
Sir, one doubt, sir.
Huh?
If you install the bus, how much capacity motor is required?
So for the buses, definitely 200 HP capacity is required. Minimum.
So for that, what is the rating of batteries required for?
Then we need to calculate P is equal to V into I. So based on that only we need to calculate. Okay, 200 means definitely we need to go at least 70% efficiency, then 1.5 times of the power rating.
But size will be increases, sir. The
Of
power.
course, that's why the battery technology is increased a lot compared to the earlier. Now lithium-ion batteries are coming, so which are the size is very small as compared to the earlier. So this is the beauty of the lithium-ion batteries. So now the in the Telangana, Amara Raja 1 giga college has been started. Okay, so they are working hardly to reduce the in the electric vehicle the weight of the battery is more. So to get the advantage, we need to decrease the weight of the vehicle. Okay, so to decrease the weight, we need to work on the means battery technology also. Okay, so still it is under research only. So more technology needs to be advanced. So definitely in near future, compared to earlier, now see the battery size. Now the battery size are keeps on reducing because the technology is keeps on growing. Okay.
Sir, India is based mostly agriculture based country. Many farmers use tractors actually. We are having two-wheelers, cars, maybe trucks, buses. But why not tractors are not
Yeah.
very popular?
I'll tell you the one example. One EC student passed out from the Vellore Institute, VIT, and recently he has posted one clip on the YouTube. He has developed one EV tractor, wireless means autonomous tractor, which is charging from the solar and which runs on the battery and simultaneously charge from the solar. At the same time, he has implemented the autonomous driverless tractor. Okay, so near future, see, we have started from one point. Definitely, it will turn to the tractors also. Okay, but it will take some time. Okay, so definitely near future tractors also will be run with the EVs. Okay, so the means why as of now why the cost will be high. Why means see to cultivate 1 acres of land we need to spend 5 liters or 6 liters of petrol. Means that much power is required. That much power is required for a vehicle. So if we are using battery, then it will drain quickly. So we need to have a little bit bigger means size of the battery, rating of the battery is more to convert into the tractor side. So it will take some time. Okay. And so these are the trucks. As the trucks are not means while digging, it will take huge power.
Yes.
Okay, so the cultivators while digging, na, it will take the huge amount of power from the vehicle. So that power comes from the sources that petrol or the battery only. Okay, so because of that reason only, people are maybe I have not seen the literature or in the website. Maybe available as of date, maybe are available, but we have not seen it. Okay, so see, this is the where medium duty trucks are happening, and then this is the heavy duty trucks of electric. And see, India's standing position in EV compared to the other countries. See, by the year of 2019, now scenario is completely different. So this is the 0.07 percentage of vehicles which are utilized. It means very small portion, less than 40,000. Okay, so less than 40,000 vehicles are being utilized in EV as of 2019. And then there are people are attracted by the government incentives and the policies. So these are the countries have EV policies. Different countries have different rules. The United States have Inflation Reduction Act, and our country having production linked attracting the OEMs. Okay, and then these are the China. Of course, China is still dominating, and these are the countries having the. And see, as I said earlier, the government of India has started its strategy long back of towards EV in the 2010. So the Indian government has announced its strategy to give 950 billion dollars. Sorry, this is INR. Sorry, this is 950 billion rupees to the OEMs who are manufacturing the EVs. But unfortunately, it was scrapped in the 2012. So because of this reason, see, if OEMs are not getting any benefit, why they will spend more to manufacture the EVs? Initial investment will be more. Okay, so the OEMs have scrapped the manufacturing the EVs, and in the 2012 it was scrapped. Otherwise, we will be the second from the China or equal to the China. It could it could have in the implementation way from 2010. So here again, the government of India has restarted the mission. That is, the Indian government has established the National Electric Mobility Mission Plan 2020 in the by the year of 2020 in the 2030. Then in the 2015 we heard the scheme phase one, faster adoption and manufacturing electric vehicles. So that is the phase one scheme. It was launched in the 2015, and this is a 4-year plan. And the government of India has announced the 900 crores to give as in terms of incentives to the public or OEMs who are purchasing, means who are selling the electric vehicles, maybe two-wheeler, three-wheeler, four-wheeler. The two-wheeler, kilowatt, 1 kVA, they are giving 5,000 rupees, maximum 10,000 rupees they are giving, right? So 2 kilowatt, they are giving maximum 10,000 rupees. So when they have implemented this same scheme, the person means the OEM will get the maximum 10,000 rupees irrespective of the battery technology, whether it is a lithium ion battery or it is a lead acid battery. It should be electric in whatever the manner. So they have started in the FAMO scheme. And the second thing is irrespective of the starting speed. See, when we increase the accelerator, the vehicle need to pick up a 60 kilometer per hour within 10 seconds or 15 seconds. Okay, there are certain criteria to means the vehicle will be placed in the FAME 1 scheme, but in the FAME 1 there is no conditions. Any vehicle it should be electric. They have been given the 10,000 rupees of maximum, and then three-wheeler they have given 50,000 rupees. Four-wheeler they have given 1 lakh rupees. So likewise, they have started this FAME 1 scheme, and they have spent around 900 crores. And then by the year of 2019, it was completed, and the government of India has announced the FAME 2 scheme. And in that FAME 2 scheme, to encourage the OEMs and public more, they have allocated huge budget of 10,000 crore. So here they have allocated 100 billion. So 10,000 crores they have allocated in the FAME 2 scheme. In the out of 10,000 crores, 3,000 crores has been allocated only for the e-buses. So through the buses, number of public means public awareness comes more, because while on the road, if electric vehicles are going, then hundreds of means major people will see. So more awareness comes when the budget is allocated for the buses. In that way, they have allocated 3,000 crores for the buses. Because of that reason only, many government have purchased e-buses. And then around 1,000 crores, they have spent for the creating a charging infrastructure. So likewise, they have distributed that 10,000 crores in different ways. For the two-wheelers, they have given 1,000, like three-wheeler. They have distributed that much 10,000 crores in different ways to spend it. And now, in 2014, the government of India has announced the another scheme, because the FAME 2 scheme was over, and now recently the government of India has announced this scheme. Maybe you might be heard about this. That is PM E-Drive scheme. in the PM E-Drive scheme, they have spent, they are going to spend 10,900 crores. Earlier, they have increased the 900 crores here compared to the FAME 2 scheme. And they have kept the target only 2 years, up by year of March 2026 only. Earlier, it was 4 years. Now it is only 2 years. Okay, so they want to spend this much amount in terms of in this amount they have categorized the where they want to spend. So these are the vehicles they want to means these are the things like two-wheelers and trucks, buses, charging infrastructure. You can get the idea how much they have spent. So this is the data I have taken from the Government of India PM website only. Ministry of the Heavy Industries, I have taken this data. And you can see e-buses, they have means they are targeted to create the EV buses 14,000 and they are planning to give the 4,391 crores in terms of incentives to the state governments. And likewise, e-two-wheeler, that is 1,700 crores. Likewise, they have distributed this 10,900 crores in different ways. Okay, so hope this will be completed before March itself. Hope so. And in addition to the Government of India policy, every state has its own policy to increase the EVs in states. So the best government in terms of EV is Delhi government. So recently Delhi government has ordered 2026 buses, e-buses, and which are planned to run on roads by 2025. 2026 buses they have ordered. Ashok Leyland only they have ordered these buses. And because of these buses, how much carbon footprint they are going to reduce? That is 14.5 lakhs tons of carbon dioxide they are going to reduce in next 12 years. Okay, so each government is working hard towards to the increase the EVs in their states. So likewise, other states also attracting, means creating policies to attract the public. So this is Maharashtra and Uttar Pradesh. So each government is working towards that, and these are the policies. And then the policy implementation is catching up with targets. Of course, people will attract because of, see, if I am getting 1 lakh rupee, definitely I will turn to the EV instead of the petrol vehicle. Okay, so this is one of the advantage. See, many people, whether it is utilization or not, when we go to the shopping mall, if there is a 50% off, whether it is really needed or not, we think later on, but we will first purchase it. Okay, in future maybe it will utilize. So that is the mindset we will have definitely, and this implementation means this policy will be capture the people, and day by day it is increasing, and electric vehicle market in India. So thanks to this fellow, Honorable Transport, this Highways Minister Nitin Gadkari ji, and always we will see his faces in the newspaper in launching of EVs. So like fuel cell EVs or electric vehicles. Okay, recently he has launched the hydrogen fuel vehicle, the car. Okay, so that is that photo you can see here. So that Mirai is giving 650 kilometer in one charge. Okay, so these are the government initiatives, and they are working hard to increase the electric vehicle, especially this fellow. And see, I am again once again saying this is online, so I am not fan of the Indian government. I am only the fan of their policies. Okay, because people may make their controversies in other ways. Okay, I'm not commenting any government or any politicians here. Only saying the statistics of country. And EV sales, day by day, EV sales are being increased. You can see the living here, and from 2015 to 2019, and you can see the sales of the different vehicles, four-wheeler, two-wheeler, and three-wheeler from 2020 to 2021. It is increased doubles the types of the 2020, and now of course the same legacy is continuing. And charging infrastructure also increasing day by day, and this is electric car sales up to 2022, and this is the charging stations in the entire world, and then up to 2022. And you can see the sales between the 2023 to August 2024. So these are the electric vehicles, all the types of electric vehicles, starting from two-wheelers to the e-buses. Okay, in every month, August 2023 to August 2024, it keeps on increasing. Okay, so every month around 1,50,000, 1,40,000 vehicles are being sold by the different OEMs. So this is the beauty of EVs. Many people are purchasing EVs, and so this is the category wise I have given two wheeler and no flowchart, and then which are the OEMs are selling, manufacturing the EVs and selling. So the Tata Motor is placed in the top. It is 4,085 in the August, and July is 5,000. Okay, so likewise they are selling the EVs, and this is the e-buses sales. So again here Tata is placing top, and this is the e-rickshaw sales, and two-wheelers. And which are the states majorly purchasing the EVs? The Kerala is being placed top. So Kerala sales are 13.5, and then next Karnataka, Maharashtra, Telangana too. And battery supply chains are essential in transitions. And lithium-ion battery mineral prices are increasing, but maybe very soon it may decrease. Thereby, battery prices decreases. And this fellow has started one factory, that is Amar Raja's strategy to competitive lithium-ion cells manufacturing in India, 1 gigawatt carrier. They are going to spend 9,500 crore by the year of 2031, and they have already started the manufacturing. Current capacity is 1.5 gigawatt hour, and maybe it may change the future of our country. Not only this fellow, the Tata also started their manufacturing in Gujarat. Okay, so definitely in very soon we will catch the China. This is the growth rate of EV. So this is the growth will be there. 54% growth will be there by the year of 25, and these are the huge market in terms of electric motors, batteries, and the powertronics and the charging stations. And I can say confidently, the future for the electrical engineering student, if they concentrate in any of these areas, maybe in terms of the drives or in terms of the battery technology or in terms of the powertronics, then they can place in best companies. And please motivate the students, especially electrical student, to look these areas. So there are three major areas in electrical engineering. One is the EV, second one is the solar, and third one is the drone technology. These three are belongs to us, and they'll get the future in these three. So I don't know why the ACDC is being converted, or most of the branches we are seeing nowadays. So electrical and mechanical civil branches are being converted into the CSE already because of the chat GPT and AI. So there are number of layoffs are happening. So if they convert all these branches towards the those data sciences, machine learning, and then see in future, maybe not today, maybe after 50 years, there will be a lack of the electrical engineering students, engineers, electrical engineers. So government need to think in this aspect. So instead of reducing these branches strength, they could have given the CSE maybe 50 seats additional for the machine learning. So what strategy they have, I don't know. So ma'am.
For power system students, maybe M.Tech or PhD, so they want to shift to the electric side slowly. So which area do you suggest so that slowly we can move towards the electric?
See, now in the electric vehicle, we can give the charge, means we can generate the charge in the electric vehicle to grid to vehicle. So in this direction, they can see the they can learn in this area. Okay, very soon we can charge the grid from the vehicle. Certain countries are working already in this. Okay. So power system people can work in this direction.
So that they can come to EV sides too.
Yes.
Because they cannot work on power plant
Yes,
controls.
definitely. They will not may not work, but being electrical student, they can work in any area.
Yes, yes.
But as they're a specialist in power system, so how best they can transfer the power which is generated in the vehicle to the grid. So in that way, they can think about, and instead of taking the power from the grid, so they can go for the solar side, and they can charging stations. They can store the energy from the which is generated from the solar, and in that direction they can see. Okay.
One more question.
Uh,
Why these accidents are happening in showrooms, electrical vehicle showrooms, or owners of new vehicles? Because only because of batteries or any other
See, days are gone. In the maybe in the 2020 2021, we might have found many videos while going on the road. One EV vehicle has been burned. Okay, there are certain guidelines are there. See, one vehicle should not means the person need to have a certain knowledge. See, he should not give the accelerator rapidly, and each vehicle having certain limit. He should not go be 60 km per hour. But in a enthusiasm, he may go for increase the beyond the 60 km. So initial starting current is increases. Okay. So because of that, the sparking happens, and that battery may blow. And now technology has increased compared to 2020 2021. Have you seen the nowadays very less as compared to 2020 2021? Now growing up the electric two wheelers especially are, I've been see especially in the 2024. So whenever happens, it within a minutes it will circulate through WhatsApp or something. But in recent days, the this type of scenarios are we are seeing less. Because of the reason is the OEM has very cautious towards the this burning side. Okay, so now the electric vehicles are safer because of the technology improvement. So many people earlier, many people are having thought of, oh, vehicle, electric vehicles are like we are putting the bomb under us. Okay, so now that scenario is not there. Okay, and whether EV is right for me, and is charging an EV cheaper than the buying a gas? Of course, EV charging is less because the maximum 1 unit cost commercial is 9 rupees, maximum 9 rupees. We are not spending much more than that. So if you charge 9 units, you can travel around 140 kilometers. But to travel 140 kilometers with the petrol, we need to spend around 5 liters, 4 liters. That cost itself 500 rupees. But through the EV, it will maybe you can spend 100 rupees maximum. So that is the EV charging is best. And our electric vehicles are affordable? Yes, as I said, two examples. So electric vehicles are affordable nowadays, and in near future, definitely EV cost will reduce because the battery technology increases, size of the battery reduces, the weight of the vehicle also reduces. Thereby, electric vehicle cost also come down as when the manufacturer increases the production, ultimately the cost of the vehicle will get down. Initial cost will be high, but later on definitely it will reduce. And then how and when I charge the electric vehicle? Of course, in our home now means single phase charging itself we can charge safely in our home only. And what types of EVs are best? So it's up to us how much kilometer we are traveling. So whether we are traveling 300 kilometers, 400 kilometers frequently, or in a larger manner we are traveling. It depends upon the public. And yes, will the EV go enough miles between the fill up? Yes. Now, as I said, one example between the Tadakilgudam and Vijayawada, there are two charging stations are available. You can fill up in between. You can have a tea break for half an hour. You can charge 1 unit or 2 unit. And nowadays, the fast charging are available. Okay, charge the vehicle within 1 hour also. Okay, so the of course still more research are going on in the charging infrastructure side also, means charging of vehicle quickly. Okay, so very soon those things may come, and it makes the easy to charge. And should I buy new or used, or it is better to lease? I'll suggest, especially for the EV, purchase new one. Why? Because if you purchase after 3 years of vehicle purchase, then half of the battery may damage. So in the electric vehicle, more cost will belongs to the battery. So if you are spending 10 lakh rupee, 4 lakh rupees are only for the 3 to 4 lakh rupee portion for the battery. After 5 years, the battery is useless. So manufacturers are saying you can go up to 8 years, but we know the electrical engineers, we go for up to 70 or 80% efficiency. So it's again depends upon the how we are taking care of that vehicle. We are whether we are running that vehicle as per the conditions are mentioned.
One doubt, sir. Normally, EV vehicles are only scooters. Why not take over bikes?
Why not?
Bike.
Yamaha recently seems Yamaha has launched the bikes also. That's why I'm saying. See, we have started with one thing, and now it is implemented in all ways. Now in the scooter, I mean, not only scooters, two wheelers. I mean, not only scooters, scooty or something. Now the bikes also being implemented with the EVs.
We are not seeing that. Normally, we are seeing
That's
scooters.
it is there. Okay. And lower maintenance as only battery and the drive is there, so drives are required less maintenance. If it is the IC based vehicle, then we need to change the gear oil, we need to change the oil. Okay, so these are the things we need to take care, and lower emissions, of course. And key player of the EV market, these are the fellows of key players of Tesla, Audi, Jaguar, and etc. Mercedes, and these are the key players.
Sir, one doubt, sir. When we are charging, we are putting the plug here. So if there are many times we are using, definitely we get the sparks. Gaps will be there. So is there any preventive steps for that one? Up to now.
See, for our mobile also, in a day, number of times we are charging each yes. I am using this mobile almost 4 years as of now, and the same charger I am utilizing. So it depends upon how we are utilizing. See, if you remove the charging point in a irresponsible manner, so definitely it will create means it may damage. Okay, so it's again up to the person how he is taking care to handle. So see here Tesla and the BYD. You see the flow chart, and the BYD is crossing Tesla. So BYD is manufacturing are basically China head. So the BYD sales are more compared to the Tesla, because maybe price. The Tesla is not reducing their vehicle price. The BYD in our country also you can find the number of BYD vehicles. Okay, so BYD vehicle price is less as compared to the Tesla. So that is the reason why BYD crossed the Tesla. And these are the key players of our Indian, and electrical dilemma. Why this slide is importantly required, because the government is giving incentives towards the EVs. Then government need to think about the how to create the power. Okay, so they are keeps on increasing the OEMs and creating infrastructure, everything. But what about the power? From where that power will come? So, by this is statistics I have taken from the Ministry of the Power. So, by the year of 2019 and 20, we were generating 1,38,910 crore units. But how much we require generally? We require 1,39,766 crore units we require, but we are generating shortfall of this much. Already we were shortfall of 856 crore units. In addition to this shortfall, now government is initiating the electric vehicles. So electric vehicle being charged through
generate power from the thermal, hydro, nuclear, etc., etc. Okay, so if government goes in that way, then the whatever the advantage we are talking from the EV, that is we will not fulfill 100%. If EV being charged from the power generated from the thermal, here we are burning the petrol, there we are burning the coal. Then what is the use? The whether electric EVs are really green, the electric vehicles are really green when it being charged from the renewable sources. Okay, so government need to think in that direction. So wherever the charging stations are there, they must charge through the at least 50% to 60% they need to charge from the power generated from the renewable sources. Maybe hybrid, maybe solar and wind.
Small question. Yes, sir. Is there any scholars are working in battery disposal activities? Varieties or activities?
Yes, definitely. There are a few scholars are working. How best see um, solar panels. So they are while disposing after 20 years of their service, 20 to 25 years of service, solar panels are useless. But now, what solution they came up with? So they are separating the things like above the cells. They were having some thin film. They are dismantling it, and the whatever the flames are there, silicon flames, those things are there. They are separating and they are reutilizing in the manufacturing of the solar, while solar panels. In the similar way, now people have started working. In the people are saying that electric vehicles are best, but the batteries are the major cost for the electric vehicles. Then after years of after decades, there will be a dump of the batteries. How can we reutilize those batteries? So people have started the research. Okay, so it is going on.
Is there any problem in the huge volume of lithium disposal factories for the region?
See, see, 100%. No one gives the 100%. There will be a certain drawback will be there. Okay, so whether their future in the see earlier we don't know chat GPT and artificial intelligence. Now you just type your name, it will say your history. So that technology has enhanced. So in near future, definitely the how best we can utilize this lithium ion minerals usage minerals in other ways. Definitely, there's some solution will come up by the departments that metallurgical, chemical engineering, those departments they are working on it. See, whenever the government is initiating something, obviously bureaucrats think about these directions also. Okay, so the advanced countries like USA and China, they are utilizing it means they might have thought that thing also. Okay, so definitely this they might have taken in the priority. Maybe not today, but in near future it may come definitely. So, they need government need to think about the solar charging station infra grid based and different types of EVs available. So we have seen different types. That is battery EV. The battery being powered to the motors, and this is the battery EVs. And then hybrid. There are two ways of engines. One is the battery is being operated, and another one is the fuel IC based engine. The generator will be there. Diesel generator will be there to create the power, and then fuel cell EVs are there. So these are the different EVs are available in the market as of now, and each vehicle has its own advantage, its own disadvantage. Okay, 100% no one fulfill 100%. Like these battery EVs are having a drawback of the battery and battery manufacturing, and then at the same time fuel cell batteries are having its own drawback of hydrogen infrastructure creation. Okay, and then the types of EV electric vehicles are having the battery powered electric vehicles. In the battery powered, and then this is the hybrid. In the hybrid, again we have series and parallel, and the series and parallel, and then plug-in hybrid electric vehicles. So this is for literature purpose I have given. And what are the major portions are there in the battery electric vehicle? That is a battery. As I said, this is the major portion. Then the which convert the power converters are required to convert from DC to AC.
and then electric machine which operate on the inputs of our AC, and then load. And this is the how basically engine of electric vehicle. So this is how they will create. So this is the motor part, and this is the inverter, and this is the power drive body. And how the under portion of the vehicle look like. So this is the example I have taken Ford Focus.
Sir, normally the motor will fix in the back side, back side of the vehicle. So is there any problem unbalanced weighting that?
No, see, motor might be fixed in the back, but the what we call the wheels means
Gear mechanism.
propeller system will be there. That is connected in a balanced way only.
Our batteries are also there. Batteries are
Batteries are placed in the back itself. Means here they are placed in the back.
Normally in IC, the IC engine total will be in the front, right? So back will be propel will be there. So because of that, the weight balance will be affected. But if we will place the electrical weight, then definitely we should place the back side. So then the weight balancing is the problem.
See, in the electric vehicle, there are three engineers works. One is the mechanical person. He always see the how to make the balance. The electrical student work how best he can give the power. So while creating a design, they always thinks how to balance the vehicle. So in that aspect only they will design. Okay, so they will definitely balance the wheels. And this is the one example of Nissan Leaf. And as I said, the power motors they are using one 10 kilowatt AC PM is a motor being utilizing in this vehicle. So see the rating of the motor. So rating of the motor is 110 kilowatt, and the battery size they are utilizing 50 kilowatt hour battery they are utilizing in this vehicle. And the range of this vehicle is 226 kilometers. So the range of the vehicle gives based on the battery size. And these are the advantage of series hybrid vehicle. So in addition to the battery, there will be a small engine, IC engine also there, or IC generator to create the power. And this is that schematic diagram of the hybrid. And this is the design of Lotus 4 car. And the main portion of the EVs are belongs to drives and the battery charging and battery. And why electric motors are more advantage in vehicle application compared to the IC based engine? These are the various parts of the EVs: the motor, battery, and then onboard charger, electric power control unit. So we will majorly focus now from now onwards on motor drive side, and these are the main three parts we will cover. That is electric motor and the inverter. So this is the heart of the drive. And as we know how the industries are turned from DC to AC. So before 1990s, most of the industries were using DC. Why? Because the DC motor, we know the series and the separately excited DC motor. The DC motor speed can be controlled easy because the armature is splitted from the field. So by keeping the field constant, we can vary the armature current. Thereby, we can control the torque and we can control the speed of the drive easily. But whereas the AC motor, if we change something in the supply voltage, then the rotor speed ultimately changes. Why? Because the stator and rotor both are in coupled nature. Okay, whatever the flux is produced at the stator, the same flux being utilized for the rotor, which is passes through the air gap and etc. etc. So in the AC, it is in coupled nature. So the controlling of the AC motor is difficult without using any controller. So the DC motors are the best in terms of the controllability. So they are the best, but along with the best controlling, there are certain drawbacks of maintenance because of the brushless Because of this reason only, industries are turned towards to the AC. Sorry. So, how the industries are changed from DC to AC? So, this is the portion they have increased. So now, by the year of 2024, almost 95 to 99 percentage of industries are using AC only. So, if somewhere they required the DC, because of the reason is torque, the starting torque where it is required high. Okay, in that application only the DC is concerned, but even in the traction drives also nowadays people are means using AC only. Okay, so why the electric motors are best compared to the IC based engine? So being electrical engineers, we always talk about the reliability, efficiency, power density. Okay, so whether this IC based engine will give you this uh, characteristics better or machine. So if you see the reliability, so in terms of the reliability, the motors, induction motor, PMSM motors gives the best reliability compared to the IC based engine. Then efficiency, the induction motor gives the 80 to 85% efficiency. PMSM motor can give 90 to 95% efficiency. Okay, so and then noise and vibration. Of course, here the number of parts required for the EVs are less, only motor and then powertrain is converters. Then obviously noise will be less. Recently, I heard few people have complained like so we are not hearing the vehicle sound. So certain governments is thinking how we can avoid this problem. They are creating artificial noise. So while the vehicles are running, maybe see again noise sounds they are not going to increase what is there in the IC vehicle, but somehow to make the people cautious. Okay, sometimes EV scooters are going beside us, and when it is come to near us, we are feeling like uncomfortable. Okay, so EVs are not giving sound because the motors are operated smoothly. So this is the noise rate is less in the EV. And being electrical engineers, we all know these motors and how can we utilize the best and how can we get the best efficiency and reliability. So these are the different types of motors are available, and we were using PMSM motor and the induction motor, and we have worked on the induction motor, and now we are moving towards the PMSM motor. Why especially PMSM motor means basically in an electric vehicle, especially four wheeler and four wheeler and public transportation buses and heavy trucks which required high power density as compared to which is not being given by the induction motor, because the induction motor power density is less compared to the PMSM motor, because the PMSM motor being utilized permanent magnet material in the rotor.
But in the, when you use the permanent magnet, the life will be less, and flux is also constant. But if you use the induction motor, we can increase the magnetic flux by varying the current or voltage.
See, copper windings also gives up to certain age only. See, if you keeps on running the copper wires, then the resistance of the copper wires keeps on increases. Okay, so copper material keeps on degrading. Okay, of course, see, advantage is there, disadvantage is there.
From
So,
flux point of view.
flux point of view, we need to see. Definitely, induction motors are best. Okay, so application again. In what application we are utilizing? I'm not saying entirely all the OEMs are four wheelers are utilizing PMSM. No, only few. See, there are two types of students are there. One student he want to run a sports vehicle. Another student he want just for the daily purpose he want a passengers or something small way two wheeler. Okay, so it's again application. Okay, so in certain application, PMSM motor, the power density which is given by PMSM motor is best. So here, power density of different machines, the DC motor, induction motor, PMSM motor, and switch reluctance motor. So if you see the power density, the PMSM motor is giving best 5 out of 5, and then induction motor is 3.5 out of 5, and the DC motor is only 2.5. But in terms of the
the controllability, if you talk about the controllability, the DC motors are the best control in terms of, and the AC are little bit less compared to the DC, because the AC motors are in a coupled nature and the DC motors in a decoupled nature of field and armature. And if you talk about the reliability, induction motor gives the best reliability. As we are saying, this permanent magnet is being utilized, so their lifespan will be smaller. So in terms of the reliability, PMSM motor gives less as compared to the induction motor. And cost wise, the cost of the DC motor is little higher compared to the induction motor now, and PMSM motor cost will be higher compared to this. 3 means the cost is high because the rating is given less. So overall, if you see, the induction motor and the PMSM motors are the best for the electric vehicle applications. And these are the OEMs being utilized these electric machines in their EV applications. So induction motors utilized by these companies, Ford and GM EV, and the PMS motors being utilized by the Honda, Nissan, Toyota, and Switcher Electric is very less companies are using this SRM, and this is the company being utilized SRM. Still, there are certain companies are utilizing this DC series motors also, and this is the data I have taken long back. This is the Tata Nexon. They were utilizing the PMSM motor in their EV application. And this is the power rating of the motor, that is 129 HP. And the torque of the motor is 245 Newton meter. And in one charge, this vehicle can travel 312 kilometers. Of course, in their brochure they might have given 350, so always we go lesser efficiency on the paper, and the cost is given 14 lakhs at that time, but now it is almost 17 to 18 lakhs. Tata Punch now coming in the 14 lakhs, so this is the Tata Nexon is the higher version of the Tata Punch, so it is cost almost 18 lakhs as of now. And likewise, different companies are using different electrical machine in their EV applications. Okay, so you can see this is maximum kilometer is giving 490 kilometer, and this is Morris MG.
Sir, one doubt, sir. If you use the induction motor, but DC sub battery means DC supply. We want to convert DC to AC, means losses will increase, and convert it to ignition, losses will be increased.
Sir, days are gone. Thanks to the semiconductor devices and advanced power transistor converters, losses are means we are controlling the losses. Okay, so earlier we talk about these losses, but now these losses are minimal. Okay, technology is increased a lot, so we are reducing these losses. Okay, semiconductor devices we were using.
Apart from batteries, are they using supercapacitors or fuel cells?
Fuel cell just started. Super capacitors also they have started, but not came into the implementation. See, if it is 100% success in the research, and they will take one demo, then if it is implemented, then company will bring into the market. So which are under testing only. But fuel cell they are working huge. As I have shown the Morris, it is giving 650 kilometer in one charge. So people are working on the fuel cell.
Okay, a small doubt, sir. As per the EV industry, economic reports, whether the people are interested to buy hybrid electric vehicles or standalone electric vehicles, sir, as per the market, budget market, what
Budget
are the
market.
economic reports?
See, basically in that aspect, people are going battery electric vehicle only. They are going more because the cost of the hybrid little bit more compared to the EV, this battery. Okay, in that aspect, I think battery powered vehicle only people are going more. But these transport people, they are going with the hybrid.
is there any industry making hybrid electric vehicles in a two-wheeler two-wheeler configuration?
As of now, no. Means I didn't see as of now. But in the three wheeler and four wheeler, it is there. Four wheeler, 100% it is there. I have traveled. Okay. Kia also manufacturing a hybrid. Okay. I have seen that one in the four wheeler, but two wheeler I didn't see much. But our student in one expo, they have made it both EV and then this one. Okay, I see. So now, as EV motors are, means electric motors are being utilized in the electric vehicle, so we need to have a controlling mechanism for controlling the this electric motor. So we from now onwards we will see how best we can control this motors, AC motors. What are the control methods are required? We will see. Okay. Can we take some break?
Sure.
Thank you.
Sir, normally, to get the high starting torque, AC series motors are there.
AC series motor.
AC series motor. That is a DC series motor only, but it has additional winding. So because of that, we will see. Recently, I get that one, sir. So AC series motor same like DC. ఒక పర్సన్ 100 కిలోమీటర్స్ ట్రావెల్ చేసేవాడు తక్కువ కదా అవును అంతే కదా ఇప్పుడు మీరు గ్యాస్ వెహికల్స్ ఉన్నాయి కదా సిఎన్జి సిఎన్జి ఉన్నాయి కదా అవి కూడా అంతే కదా ఫస్ట్ సిఎన్జి రన్ అవుతాయి సిఎన్జి ఎప్పుడైతే 10% 50% రాగానే ఆటోమేటిక్గా అది మోడ్ అనేది చేంజ్ చేసుకుంటారు లేదంటే అది వెహికల్ ఆగిపోయి మళ్ళీ దాన్ని చేంజ్ చేసి ఆటోమేటిక్ production intensive PCI, production linked incentives, PLI, production linked incentives, PLI. He is ready to give the part, but he is not ready to manufacture. So because of that, he is being stopped.
చిన్న స్పీడ్ కాన్స్టెంట్ స్పీడ్ అలా ఏం చేశాను చిన్న స్పీడ్ కూడా అవసరం లేదు కంట్రోల్ అంటే ఏ స్పీడ్లో కాబట్టి ఆ స్పీడ్లో అవసరం గేమ్ అసలు ఈవీలో గేమ్ కలిసి లేదు అదే ఒక అడ్వాంటేజ్ ఈవీ పవర్ డెన్సిటీ అనేది ఆల్వేస్ కాన్స్టెంట్ అని మెయింటైన్ అంటే మనకి లో స్పీడ్ కావాలి లో స్పీడ్ అంటే ఐడియా స్పీడ్ ఇదే ఉండాలి అనేది లేదు ఎందుకంటే మనం అంత నాలుగు గేమ్ గేమ్ మెకానిజం వల్ల మన బేసిక్ ఎలక్ట్రికల్ పవర్ అండ్ స్పీడ్ టార్క్ అండ్ స్పీడ్ క్యారెక్టరిస్టిక్స్ ఉన్నాయి కదా టార్క్ అండ్ స్పీడ్ క్యారెక్టరిస్టిక్స్ లో కాన్స్టెంట్ టార్క్ రీజియన్ కాన్స్టెంట్ పవర్ రీజియన్ రెండు రీజియన్స్ ఉన్నాయి సో ఇనిషియల్ గా కాన్స్టెంట్ టార్క్ మెయింటైన్ చేస్తాం కాన్స్టెంట్ టార్క్ మెయింటైన్ చేస్తూ స్పీడ్ అనేది రైజ్ అవుతుంది స్పీడ్ అనేది సర్టెన్ లిమిట్ రేటెడ్ స్పీడ్ రాగానే ఏమవుతుందంటే మనం కాన్స్టెంట్ పవర్ రీజియన్ మోడ్ లో కాన్స్టెంట్ పవర్ మోడ్ లో ఉండి టార్క్ ని రిడ్యూస్ చేసుకుంటారు ఆ టార్క్ ని రిడ్యూస్ ఎలా చేసుకుంటారు కాబట్టి గేర్ చేంజ్ చేస్తాం ఓకేనా మనకి ఐసీ బేస్ లో 4 గేర్లు ఫస్ట్ గేర్ లో హై టార్క్ లో ఉంటుంది స్పీడ్ రైజ్ అవుతుంది అది స్పీడ్ కాస్త రాగానే ఏం చేస్తాం మనం గేర్ మార్చేస్తాం గేర్ మార్చగానే అయితే ఏమవుతుందంటే ఆ టార్క్ అనేది ఇలా తగ్గుతుంది కాస్త ఇలా వచ్చేసి ఇలా తగ్గుతుంది ఇంకో గేర్ చేంజ్ అవ్వగానే స్పీడ్ రైజ్ అవుతుంది గేర్ చేంజ్ అవ్వగానే టార్క్ కర్వ్ ఇలా వచ్చేస్తుంది అంటే టార్క్ కర్వ్ ఇలా వచ్చేసి ఇలా అవుతుంది కదా రిడ్యూస్ అవుతుంది సో అది గేర్ మెకానిజం బట్ అదే మన ఈవీస్ లో ఓన్లీ డ్రైవ్ మెకానిజమే ఉంటుంది తప్ప ఇది గేర్ చేంజింగ్ అనేది ఉండదు అది మెయింటైన్ అవుతాం మనకి ఇది ఉంది కాబట్టి కాబట్టి కోర్స్ అనేది బేసిక్ గా ఈ బ్యాటరీ అసెంబ్లీ బ్యాటరీ అసెంబ్లీ నంబర్ ఆఫ్ సెల్స్ ని ప్యాక్ గా అసెంబ్లీ చేస్తున్నాం ఇంటర్న్షిప్ చేసే కంపెనీ వాటిలో వెళ్తే బాగుంటుంది సో ఈ సో వాటికి వాళ్ళకి హెల్ప్ చేసింది ఇదే బ్యాటరీ అసెంబ్లీ ఎలా చేస్తారనే అంటే నేను ఒక అమ్మాయిని నెల్లూరు అంటే వాళ్ళ సీనియర్ చెప్పడం ఈ లెడ్ ప్రాక్టీస్ హ్యూమన్ కొంచెం చేసిన ఇంకా ఉండదు సార్ ఏమో ఎందుకు అట్లా మంచి అవుతుంది కదా బాగుంటుంది కదా అది సార్ లైఫ్ ప్రాబ్లం వస్తుంది సో అది కూడా ఒక ఇంకా సార్ ఇక్కడ ఏమవుతుందంటే ఇప్పుడు డైలీ వాటి ప్రాపర్ ఇది మీరు ఫారిన్ కంట్రీస్ ఈవెన్ చిన్న సైంటిస్ట్ అయినా సరే వాళ్ళు పేపర్ తీసుకోవాలి మాస్క్ తీసుకోవాలి గేర్ వేసుకోవాలి అన్నీ ఒక సర్టెన్ గైడ్లైన్స్ ఉంటాయి అన్నమాట అవన్నీ ఫాలో చేస్తే ఏ ఇండస్ట్రీ అయినా హార్మ్ఫుల్ కాదు ఎప్పుడు హార్మ్ఫుల్ ఇండస్ట్రీ స్టార్ట్ చేసి ఎంప్లాయీస్ ని ఇబ్బంది పెట్టడానికి ఈవెన్ పోర్చుగల్ వాళ్ళకి ప్రాపర్ ఇచ్చే పంపిస్తారు సో వాళ్ళు వాడకపోతే ఇబ్బంది పడతారు వాడితే మానే కొన్ని ప్రైవేట్ ఆర్గనైజేషన్స్ అవి కూడా చాలా కాస్ట్ అవుతుంది కదా అంటే ఆ పేపర్ ఇస్తున్నామని చెప్తారు
దానివల్ల కూడా మీకు అంటే అవి లైవ్ లో అంటే అది తయారు చేసేది కాబట్టి ఆ అమ్మాయి బాగా చేస్తుంది.
ఇంకా సార్ ఆబ్వియస్లీ ఎందుకంటే కెమికల్ ఇప్పుడు మీరు ఒక యాసిడ్ తీసుకుంటారు, యాసిడ్ జస్ట్ ఓపెన్ చేయండి, అందులో ఒక 5 నిమిషాలు ఉండండి, ఆ ఘాటుకి
ఈ యూస్లో లిథియం అయినా కదా సార్ రిడక్షన్ వాటర్
లేటెస్ట్ పోయింది. అదే టూ స్కీమ్ లో 2015 స్టార్ట్ చేసినప్పుడు, 2019 స్టార్ట్ చేసినప్పుడు గవర్నమెంట్ ఆఫ్ ఇండియా సర్టెన్ గైడ్లైన్స్ తీసుకొచ్చింది. ఏంటి యాసిడ్ రిమూవ్ ఫ్రమ్ ద టెల్ ఓన్లీ లిథియం అయన్ బ్యాటరీస్ మాత్రమే స్కీమ్ ఇన్సెంటివ్స్ ఇచ్చారు. ఓకేనా? ఆ లిథియం అయన్ బ్యాటరీస్ లో కూడా అన్ని కావాలి. ఇప్పుడు కానీ కొన్ని స్టాండర్డ్ పెట్టింది. ఏంటి స్టాండర్డ్? మినిమం ట్రావెలింగ్ ఒక ఛార్జ్ లో 60 కిలోమీటర్లు 70 కిలోమీటర్లు ప్రయాణం చేయాలి. లేదంటే లిథియం అయన్ బ్యాటరీ పెట్టేస్తే వాడు 10 కిలోమీటర్లకే మళ్ళీ ఛార్జింగ్ చేయాలి. దానివల్ల ఏమవుతుంది? నెంబర్ ఆఫ్ బ్యాటరీస్ అనేది ఇంక్రీజ్ అయిపోతా ఉంటాయి. అంటే క్వాలిటీ బ్యాటరీకి నాన్ క్వాలిటీ బ్యాటరీకి తేడా. లిథియం అయన్ లో కూడా నాన్ క్వాలిటీ బ్యాటరీస్ ఉంటాయి కదా. వాడు బేబీ లిథియం అయన్ చెప్తాడు, బట్ స్క్రాప్డ్ లిథియం మినరల్స్ తీసుకొచ్చి దాన్ని తయారు చేస్తారు.
సో దాన్ని కంట్రోల్ చేయడానికి ఇది ఫిక్స్ ద సబ్స్టాండర్డ్.
దాన్ని ఫిక్స్ చేయడానికి ఏం చేశారంటే ఈ ఒక ఛార్జ్ లో మినిమం 70 కిలోమీటర్లు రన్ చేయాలి వెహికల్ అనే కండిషన్ పెట్టారు. అండ్ ఒక 10 to 15 సెకండ్స్ లో వెహికల్ 70 కిలోమీటర్ల స్పీడ్ అచీవ్ చేయాలి. ఇలాంటి కొన్ని కండిషన్స్ పెట్టారు సార్.
Now we will start the section, sir. Now we will start the section, sir.
Okay, participants. Now we will see the how best we can control the induction motor drive, AC drives basically. So speed control of the AC drives, part 2 we will see. So here there are different types of control methods are available in the literature. So the first method is a scalar control method. So in the scalar control method, we can control the frequency and the magnitude of a vector. It may be a voltage, current, and the flux. But we cannot control their instantaneous position. So this is the drawback of the scalar control method. So to control their instantaneous position, so we have a method of vector control method. In the vector control method, not only the frequency and the magnitude of a vector, we can also control their instantaneous position. So because of the reason, so vector control is more popular as compared to the scalar control method. So here, as I said, the DC motors are the best in terms of the speed controlling methods. So here we can control the DC motor speed in a better manner as compared to the AC. The main reason behind that, here we can give the different supply, that VDC. It drives the current of armature, and here we can provide the different VDC, and it drives the current of IF. So here we can control the armature current independently from the field current. So the torque is directly proportional to IA and the IF. By maintaining the field current constant, we can change the armature current, thereby we can control the torque directly. Because of this reason, the DC motors are the best in controllability method. So here the field current is orthogonal to the armature current, which decoupled both armature current and the field current. So this is the beauty of the DC motors. But the drawback of the DC motor is that it requires the commutators and then brushes, which always require maintenance. So here we know the DC motor torque equation is torque is directly proportional to field flux and then armature current, that is field current and then armature current. So somehow if we can bring the AC motor's torque equation in similar manner to the DC motor, then we can operate AC motors similar to the DC motors.
As we know the torque equation of a induction machine, so this is the torque equation of a induction machine. This is the seventh order equation. So this is the seventh order equation and it is a very complex compared to this equation. Okay, so the conversion of this machine makes easy because the mathematical equation you can see T is directly proportional to IA and IA. It's physical nature. So here this, if somehow if we can convert this torque equation in terms of the DC, similar to the DC, we can convert in terms of some constant psi s multiplied with is, or torque is directly proportional to some constant psi r multiplied with is. So this can be made by using the vector control concept. So because of this vector control concept, we can convert the torque equation of a induction machine or the AC machine similar to the DC motor equation. Thereby, we can achieve the whatever the advantage we were getting from the DC motor, the same advantage means we can control the AC motor similar to the DC motor. So this is the beauty of the vector control concept, and most of the industries are now using this vector control concept. And this induction motor being controlled similar to the DC motor by using the vector control method. Okay, so this decoupled both torque component and then flux component. IDS is the flux component and then IQS is the torque component.
Sir, one doubt, sir. Normally, the flux is produced because of the reactor. But we are when we see the Bela diagram of the induction motor, the IDS control the psi r means the flux linkages. Psi r means flux linkage.
Means here
Direct
here we have represented stator flux linkage with the stator current or the rotor flux linkage with respect to the stator current. Okay.
So my doubt is IDS is the direct axis.
That is, we have converted by using the transformation, Clark transformation. We have converted. That is, IS is equal to IDS plus J IQS. Okay, we have converted that one. So here you can see that is IS and this is a vector component we have mentioned. We can convert it by using the Clark transformation. So somehow we can, if we bring the torque equation in this manner, means similar to the torque equation of the DC motor, then we can operate the induction motor similar to the DC motor. And in that way, the vector control being the concept being came into the implementation. So now, so in vector control, there are different types of controllers are available. So the first one is the basically vector control, also called as a field oriented control method. In the field oriented control method, again it is subclassified into indirect field oriented control method and direct field oriented control method. Why these two types are coming? Because how we are controlling the orientation angle, based on the orientation angle, whether we are controlling the estimating the orientation angle directly, or whether this orientation angle is being estimated indirect manner like using the slip speed. So that we will see in the next slide. So this is the one method we were having in the literature. Then after couple of years, after one decade or something, the another method was introduced, that is direct torque and flux control. So why people are going for the direct torque control method when they were having already field oriented control method? So here you may not understand much. So we will I'll show you the diagrams in the upcoming slides. There are certain drawbacks in the field oriented control method. Majorly, it has parameter dependency, that is stator resistance, rotor resistance parameter dependency. If you operate machine entire day, then the stator resistance keeps on increases. Thereby, the performance of the drive keeps on degraded. So that is the drawback of the field-oriented control method. And another drawback is that there are number of complex parameters are available in the FOC, which degrade the this method. Okay, so that is the drawback of the field rate control method, and thereby the transient condition is not giving proper output. So to avoid these drawbacks, people have implemented direct torque control concept in the mid of 1980s. So in the direct torque control method, the name itself saying we are controlling the torque directly. We are not controlling indirect manner. We are controlling the torque directly by utilizing a small concept. But after the couple of years, the direct torque control method with space vector modulation has been implemented. So why people are going for the direct torque control method with space vector modulation? Because the reason is that the direct torque control method is utilizing the hysteresis controllers in their implementation. Because of this hysteresis controllers, it is providing the variable switching frequency. Because of the variable switching frequency, it produces the high torque ripple notches in the torque. So basically, we need to operate a machine in a smoother manner. So to operate a machine in a smoother manner, we need to reduce the torque notches. Means ripple of the torque should be as less as possible. So majorly all these controllers are work to reduce towards the torque ripple majorly. So to reduce the torque ripple, people are going for the direct torque control method with space vector modulation technique. So further, in the current years, people are majorly working on the technique of model predictive controllers. So model predictive controllers are advanced controller as compared to these two methods. And now people are majorly focusing on the everywhere they are talking about predictive controllers. So now in the model predictive controllers also again there are some classifications. So the first one is the model predictive current controllers. So in this method, we will get the good dynamics, but as we are controlling the currents, so we will not control the torque not be controlled directly. Somehow in direct manner, indirect manner, the torque is controlled. Then another method we have model predictive torque control. So in the name itself we have controlling the torque. So we can control the torque directly, but we were getting the poor dynamic performance. Means the transient conditions are poor in case of the MPDC method. So here to avoid this problem, there is another literature that is model predictive torque and flux control method. So here we were getting the both, we are controlling the torque directly at the same time getting a good dynamics. But the problem is that in this method, the weighting factors is being added. So because of this weighting factor, we need to give this parameters value. So it is a drawback of this method. Then to utilize these three methods in a best manner by avoiding these weighting factors, one of the scholar has implemented modified model predictive torque control where we can get not only good dynamic performance, also we can control the torque directly and not require any weighting factors. So on this concept, we have one itinerary transaction industrial applications and which is published in 2024. So this is the method is giving best. Okay, so these are the different types of control algorithms are available to control the AC motors, especially induction motor and the PMS motor in a better manner. And in addition to the control methods, we were having the different topologies of inverters. So basically, people are going for the these topologies to reduce us the switching losses. Not only the switching losses, to reduce the harmonic contents, the current harmonics and the voltage harmonic contents. As we all know, this why people are going for the multi-level inverter concept. And in the multi-level, again, there are different types of multi-level inverters are available, which is the neutral clamp type and the cascade bridge type, and third one is the fly. So in the literature, we were utilizing, we will find majorly, especially towards the drive application, we will see the neutral point clamped methods we will see. Why? Because and only small literature we will see on the H-bridge type, that is cascaded H-bridge type. So why people are utilizing less portion of the cascaded H-bridge? Because the cascaded each bridge required the isolated DC supply, which makes the circuit more complex and it increases the cost of the implementation. So people are majorly focusing on the neutral point clamped type inverter. Then how long we can go? Means up to what level we can utilize this neutral point clamped for the drive applications. So we have tested up to 5 level, but we have not gone beyond the 5 level because we found the difficulty to implement the 5 level inverter by using the neutral point conflict inverter up to 5 level we can implement it, but we have gone beyond the 5 level because there are certain drawbacks to go beyond 5 level because we cannot balance the capacitor voltages if you go beyond the 5 level. Up to 5 level, we could able to balance the capacitor voltage. In case of the cascade bridge, you can go 5 level, 7 level, 9 level because each edge bridge having its individual DC, isolated DC and only one capacitor is connected across it. So unbalancing will not occur in case of edge bridge, but in neutral point it is arise. I'll show you the diagram. And coming to flying capacitor, so in the drive applications, I didn't find a single paper on the flying capacitor type because the balancing of the capacitor voltage is huge. Means it is very difficult. That's why people are not going. That is there for one type of applications only, wherever the is required. But for the drive, I didn't see the flying capacitor type. And in addition to that, here the PMSM motor speed is measured by using the encoder or tacho generator. If any of these controllers, maybe FOC, DTC and model PT, all these controllers are required a feedback of speed position. Means what is the position of the rotor? They need a feedback. So that feedback we can get from the encoder or by using a tacho generator. But the utilization of the speed encoder creates a problem if some obstacle comes between the rotor shaft and then the speed sensor, then it will give the improper output. Okay, because of this improper output, this controller means the error speed being compared with the measure, the reference speed being compared with the this measured speed, the error between these two will be keeps on increases because this sensor is not giving a appropriate uh, measuring data. So because of this, we will not get the proper output. So that is one drawback. And in economic point of view, so while implementing this method, we need to purchase the encoder, which takes around 2000 rupees for purchasing this encoder. So the implementation cost again increases. Okay. And third point is, suppose you have a smaller space, there we need to accommodate all these methods. Like in electric vehicle, we need to place. We are talking about. We need to reduce the size of the drive. So here, if you place the sensor, speed sensor, it takes some space. So not only increases the cost, it also occupies some space. Okay, so to avoid these drawbacks, people are estimating the speed instead of measuring. Okay, so by estimating the speed, we can accurately control the speed of the drive. So you can find lots of research papers on the estimations. So the same diagram I have shown here, but here I have shown different kind of motors like AC induction motor, PMSM motor, and wheel-less motor, etc., etc. Okay, so this is the schematic diagram. In one shot, I am representing what are the different types of control methods are available and what are the types of inverters we have utilized. At the same time, what are the speed estimation methods we have utilized, implemented in the laboratory. Those things are presented in one view. So here the field oriented control method
of AC motors, I can say, that is induction or PMSM motor. So by utilizing this field oriented control method, we can control the induction motor and PMSM motor speed similar to the DC motor, and these are the advantage we will get while using the field oriented control method. The first advantage we will get, that is high torque and the low starting current, and efficiency also we will get good efficiency as compared to the DC, and then reduce torque and low audible noise. So how we are implementing this vector control concept? Basically, we were measuring the current quantities by using the current sensors. So here we will have a motor, that is motor. Then motor terminal we have IA, IB, and IC. By using two current sensors, we can measure the IA and IB. So as we know, the balancing current IA plus IB plus IC is equal to 0, then we can also calculate the third current without using another current sensor. So here these three stationary quantities, current quantities are being converted into the IDS, the direct axis current, and quadrature axis current in orthogonal nature by utilizing the coordinate transformation, which converts the stationary quantities into the stationary two quantities, which are in a stationary manner. So this stationary manner can be converted into the rotating manner by utilizing the path transformation. That path transformation transfer the stationary quantities IDS and IQS into the rotating reference manner. So this is the control logic we were utilizing, that is a vector control for controlling the AC motor similar to the DC motors. And this is that schematic diagram of indirect field oriented control method. Why the name is indirect field oriented control method? Basically, we need to estimate this orientation angle theta. So how we are estimating this orientation angle theta? Whether we are calculating or estimating this theta direct manner. Direct manner means here we have a stator terminal, means the induction motor terminals. That terminal currents we are measuring by using current sensors. So here IAS, IPS, ICS we can measure. That being utilized while calculating the theta. So that is one way. In that way, if you are calculating this theta, then that method is called as a direct field oriented control method. But in this method, we are not calculating this theta by only utilizing this current quantities and the voltage quantities of measured signal. We are also utilizing the slip speed. So that is being calculated here by using the equation. So the theta is calculated indirectly by utilizing the slip speed. So because of this nature only, the name is coming indirect field oriented control. So the orientation angle is calculated indirectly with the support of omega slip. And here this is the rotating part and this is the stationary part. By using the inverse path transformation, we are converting the rotating reference quantities into the stationary frames. And again we are using the inverse clock transformation to convert two phase quantities into the three phase quantities which are being given to the PWM signals. And this is the how the two phase quantities are converted into the three phase and three phase to two phase stationary quantities by using the clock transformation. And this is to convert two phase quantities into the two stationary into the rotation and rotation into the stationary by using the path transformation and then inverse path transformation. And this is the direct field oriented direct rotor flux orientation control. So here why we are calling it as direct, because we are not utilizing any slip speed terminals here. Here the theta is being calculated by using the measured quantities of voltage and then current. Then we have psi ds. We are calculating the psi ds is equal to IDS plus J IQS. We can easily calculate this IDS and IQS using the mathematical equations, and then we can estimate the theta. So this theta being estimated by using the measured quantities in a direct manner. So that is why the name itself direct rotor flux orientation. And so here we are utilizing the voltage sensor and the current sensor. Thereby we are getting the VDS and IQS quantities. Instead of utilizing the voltage and current sensor, there is another way, that is by placing two flux sensors in orthogonal nature, 90 degrees to each other. One is measure the psi s and another is measure the psi qs. These two gives the data, and we can also estimate the theta. But which method is feasible and not harmful? The first method is best because we are measuring the current quantities outside the terminal. These terminals are not rotating in the nature, which are in the stationary only. Okay, so we can, by connecting the current sensor in series and then voltage sensor here in between the lines, we can measure the voltage and current quantities. But here we are placing two flux sensor inside the machine. When the machine runs, then it vibrate a little, and while vibration, somehow it mechanical supports being loose, and there is a chance of falling this flux sensor on the rotor, thereby damaging the this machine. So because this is the one of the drawback to avoid this usage of measuring the fluxes instead of the voltage and current sensors. And this method lately finding the limitation. And if you want to operate a machine in a wide speed range, we will take the support of the field weakening. By weakening the flux, we can increase the speed. Okay, so and this is the schematic diagram of the field oriented control. In the one go, I have given both the things. So, what is the drawback of this method? Why people have gone for the advanced control method like direct current control method? So, the first drawback is here we require while calculating the slip calculation, we require a parameter of RS. That is resistance parameters we require. Stator resistance parameters are required. So while operating the machine entire day, there is a chance of increasing the stator resistance because of winding will heat up. When the heating is keeps on increases, the stator resistance keeps on increases. So this method, while calculating the omega SR, we require that parameters. So this will give the improper output as this quantities keeps on increases. So this method is parameter dependency, and second, these are the, basically we will call it as a cascaded PI controller. Means one PI controller we are utilizing to control the torque quantities, another PI controller we are utilizing the controlling the flux quantities, that is IDS and the IQS, and then we will get the output of VDS and VQS. So here these two current controllers we will call it as a cascaded PI controller. Cascaded controller, basically we are using controller as PI, that's why I am calling it as a PI controller. We can also use fuzzy logic or automation technique, any neutral network controller also. But the PA is the in general nature we always use PI. These are the best for the controlling purpose, and this is the PA controller I am talking always. But basically which are controllers. So we are using PA, that's why I'm calling them cascaded blocks PA controller. And one more outer loop, we were having the speed controller. So here from the motor, by using the encoder, we are measuring the actual speed, and we were giving the reference speed. The reference speed is compared with the actual speed. The error speed is fed to the one speed controller. Again, we are using the PI controller for the speed controller. That's why I'm talking about the PI speed controller. So this is the outer speed controller, PI controller, and this is the inner PI controller. So when we are using this many PI controller, KPK values we need to tune in a proper manner. If you don't tune KPK values in a proper way, what happens? We will not get the proper output. Means the settling times keeps on increases, or the error set means error, steady state error keeps on increases if you don't tune
integral value in a proper manner. So here this is the means the ultimately there are number of PI controllers are increasing. In addition to that one, here we require a clock transformation to convert to the three-phase quantities to two-phase quantities, and then Park transformation to convert stationary quantities into the rotating quantities, and then inverse Park transformation and PWM modulator. So all together, in addition, and this slip calculation also. So this diagram makes a complexity. Okay, so because of this circuit behavior means the number of parts, people have gone for the direct or control method. There we required only less parts. I'll show you the diagram. And why majorly we are focusing the permanent magnet motor research instead of the induction motor because of this reason. So nowadays people are going for the PMSM motor, concentrating for the PMSM motor compared to the induction motor because it's high power density. You can see the value of the power density. And what are the other features of the PMSM motor while they are utilizing in the battery electric vehicle and the hybrid electric vehicle? So these are the advantage which gives high efficiency and good dynamic performance and high power density. In addition to that, reliability and maintenance free, all these things. And permanent magnets also applies for the EV drives, that is high torque density, high efficiency, and similar. So here we have simulated for the field oriented control method to justify how best while going for the direct torque control method. So for that we have taken the mathematical equation to model the PMSM motor, and this is the torque equation. T is equal to some constant, and this is the equation. Basically, in the constructional manner, the PMSM motor classified into two types. One is the interior type, one more is the surface mounted. It is purely based on the how they are constructing. Okay, so based on the construction, this torque equation it changes. So this is the torque equation, general torque equation I have given. This torque equation is belongs to the surface mounted PMSM motor. If you want to implement the interior type, then here LD is not equal to LQ. Okay, so sorry, surface. This is the equation of the IPMSM. If you are implementing the surface model, this fellow will be 0. You will have psi f into IQ only, because in the surface model, LD is equal to LQ is equal to LS. So torque equation changes for that one also. And we have simulated in the MATLAB by using MATLAB simulate, and we have got the result. And you can see here the settling time. We have given the reference speed of 200 rpm, and it took the 0.5 second to settle the speed. Okay, so not only 0.5, it's around 0.6 second it took to settle the reference speed. Okay, so the steady state results we were getting good, but the transient results we were finding takes the little more time. So we were concentrating to increase the dynamic performance also. So for that reason, we have gone and also parameter dependency that method. So we have implemented direct or control method. Basically, this method was implemented by this fellow Takahashi in the mid of 1980s. And see this diagram. So the number of number of blocks available in this diagram is less as compared to the previous diagram. So here we don't have any Park transformation, inverse Park transformation, or any PWM modulators are not required at all. And here we don't have any inner PI control, inner current controls are not required. Okay, so this is the beauty of the direct torque control method. And here the name itself saying that direct, we are controlling the torque directly. We are controlling the torque directly. How we are controlling the torque? Here we are creating a lookup table. So that lookup table is created based on the input receiving from the flux hysteresis controller and the torque hysteresis controller. So in the torque hysteresis controller, we were having three points. One is
plus 1 0 and the minus 1, that is positive 0 and negative. So based on the input receiving from flux hysteresis controller and torque hysteresis controller, we were creating the lookup table here. So that lookup table, in a one sampling time, this lookup table will give us a output as particular voltage vector. Suppose imagine this lookup table will give as a V1. V1 is equal to 1 0 0. It means the first leg of the upper switch, the second leg of the lower switch, third leg of the lower switch will be on. So here we don't require any PWM modulators. So directly the lookup table itself gives the output. So the controlling is easy and the torque we can control directly, and the number of parts are less in this method. And as we don't require any slip speed here, and this method is less parameter dependency. And how we are implementing this direct arc control, by the way. So as we know this equation, the state of flux linkage is equal to integral of the difference between the voltage and then the winding drop. So here this direct arc control concept we can understand from this equation. So imagine for a smaller interval of time, imagine that the winding resistance drop is 0. When the winding resistance drop is 0, this equation we can convert it to simplify as Vs is equal to d by dt of psi s. Or we can also write it as a change in psi s is equal to Vs into change in time. Okay, remember this equation. So now this is the equation we will utilize for implementing this direct arc control, and I'll explain with the support of this phasor diagram. And we know the torque equation, that is T is equal to some constant multiplied with psi r, psi s and psi gamma. This gamma gives the angle between the psi s and the psi r. So imagine that this is the constant for a smaller, imagine this is a constant. If gamma is being changed, then the torque is directly proportional to sine gamma. If gamma is varied, then torque also varied. So here in this method, we are controlling the state of flux by utilizing the voltage vector Vs. Okay, so how we are controlling that one, we will see. So now we know the equation, change in psi s is equal to Vs change in time. Here we are utilizing the two-level inverter. When we are utilizing the two-level inverter, there are 8 voltage vectors are available in its space diagram. So 6 are active, 2 are null vectors. So here we will have a 6 vectors, that is this is the x-axis v1, and this will be the in 60 degrees v2, and this will be v3, v4, v5 and v6. See, these are the active vectors. Now depends upon the selection of the voltage vector how the torque and flux are controlled. So that we'll see from this diagram. So now, so for a smaller interval of time, imagine for a small interval of time, we have selected a voltage vector, particularly this green line. This is belongs to V3. So before selection of the Vs, the stator flux linkage position is, this is the stator flux linkage position, and the rotor flux always behind the stator flux. The angle between the stator flux and the rotor flux will be gamma. Now, in a smaller interval of time, we have selected a voltage vector V3. When the V3 is being selected, the stator flux is moving from this point to this point. When the stator flux is moving to this point, what about the rotor flux? Rotor flux takes little bit time, because whenever we are changing the supply voltage, then the revolving magnetic field of the stator changes quickly, then passes the air gap, then cuts the armature rotor conductor, then EMF induces, then rotating magnetic field produces. So it will take some time. It is not that time, but it will, because of the its rotor larger time constant, it takes some time. So I'm imagining that for we are applying the smaller interval of time. In that time, we are applying the voltage vector V3, and I'm assuming that the psi r is in the remain same position. When
The psi r is in the remain same position. Now the psi s is changing from this point to this point. The angle between psi s and psi r earlier will be gamma. Now the angle is increased. So when the angle is increased, then the torque is directly proportional to sin gamma. So the point is, whenever we are selecting a particular voltage vector, we are controlling the torque directly. So that's why this name coming direct torque control method. So here we are also controlling the flux by selecting the voltage vector directly. That's why we can call it as a direct torque and flux control method. Then now whether torque is increased or decreased. So it depends upon the sector position and then the voltage vector which we are selecting. That we will see. So now here, as I said, two-level inverter we were utilizing, and there are 6 active vectors and 2 null vectors. Based on the selection of the voltage vector, these switching positions are changing. We can see that in the animation. So now, how we are selecting the means how we are creating this lookup table based on the input receiving from the flux histories and the torque histories controller. So here in its space vector diagram, so here there are 6 sectors are possible. Each sector is displaced by 60 degrees. So now in each sector, by selecting the voltage vector, the flux is influenced or torque is influenced. Influence means whether the flux is increasing or torque is increasing in a particular voltage vector applied. We will see. So imagine that in a smaller interval of time, we have applied a voltage vector V2 in the sector 1. So this will not remain same for the other sector. It depends upon the phasor diagram whether these flux quantities and torque quantities are varying or decreasing. It depends upon the voltage vector where we are selecting, whether it's sector 1 or sector 2 or sector 3. So carefully listen here, please. So for a smaller interval of time, we have selected a voltage vector V2. So this is the point voltage vector V2. So the initial magnitude of the psi s, this is the origin, this is the initial magnitude. The radial quantity of the V2, this yellow line shows the radial quantity of the V2, and this yellow line of vertical line gives the tangent component of the V2. So remember this radial component and tangent component. Now we have applied a V2 in a smaller interval time. As we assume that the road because of the rotor large time constant, the psi r remains same. And when we apply voltage vector V2, the psi s is changing from this point to this point. Now, what is the angle between psi r and psi s? The angle is increased, thereby torque increases. Then what about the flux? So now we will see the flux. This is the initial magnitude of the flux. When we selected the voltage vector V2, what is the radial component? This is the radial component. So the magnitude of the flux is increased. This is the initial position. This is the value is increased from this point to that point. So this is psi s plus change in psi s. So whenever we are selecting voltage vector V2 in the sector 1, both torque and flux increases. Whether this is the same case arriving while selecting vector V3, we'll see. So when vector V3 is selected for a smaller interval of time, you can see the angle between psi s and psi r is increased because earlier angle is this is the psi s psi r. So this is the earlier angle. After V3 selection, the angle is increased. Then what about the flux while selecting the V3? So the flux is reducing. Why it is reducing? Because the initial magnitude of the flux before selection of V3, this is the initial magnitude. Now see the x-axis line, so the yellow line, so which is coming backward. So this is the current magnitude of the flux. So whenever we are selecting voltage vector V3 in the sector 1, then flux quantity is reducing. So likewise, we can create a lookup table in different voltage vector selection in the sector 1. So here
both the quantities is reduces when we are selecting the V5. Similarly, when we are selecting a V6, torque reduces, flux increases. So likewise, we create a lookup table in entire space diagram in 6 sectors based on the input receiving from the flux hysteresis controller and then torque hysteresis controller. And in its space vector trajectory, you can see based on that the switching logic is working. So here we were utilizing the AC drive. So initially we have implemented induction motor. Now we are implementing PMSM also. And this is a simulation diagram. For the viewer purpose, we have given the simulation diagram. So here the PMSM motor can implement in two ways. One is this PMSM motor block is already available in the Simlink library. Directly you just type in the PMSM, then you can utilize direct model. And the second way is we can design ourselves by utilizing using mathematical equations. So we are following the second method. Instead of utilizing the existing one, we are creating ourselves by using the mathematical one. Why we need to go for this method instead of existing one? Because we don't know what is happening inside. Here we can only give the power rating and the voltage quantity ratings, but we don't know what is happening inside. We cannot unable to open it inside. But here we can see each and everything because we are implementing with mathematical equation. So these are the mathematical equation which we are using, and this is torque equation, and this is that simulation model. We have model, and these are the equations we utilize for the electrical port modeling. That is IDS, IQS, and then torque, and this is for the mechanical part of the for getting the speed, and then this is adaptive model for estimating the torque, flux, and then angle. uh, this equation, you can see this diagram being implemented by using these mathematical equations only. And here the reference speed is compared with the actual speed. The error speed is fed to the speed controller. So now here the speed controller we are using as PI1. So PI controllers are using as a speed controller. And when we are using the PI controller, then we need to tune the KPK values properly. So there are different methods are available in the literature. The first method is Ziegler-Nicholas method. The second method is root-locus method. So another way, generally majority of the people follows that is heat and trial. So there initially they vary the this KP value. Then when the speed reaches to the reference speed, they try to reduce the error by varying the KI. So this is a general method they, many people use to follow. But there we will not get the proper output. Okay, so what we have done that we have taken the mathematical equation and the closed loop transfer function we have taken, and we found the KPK values by using the root locus method. And by using the root locus method, we found the KPK values are KP is 1.75 and the K time constant is 0.5, 0.0593. Whether here the PA control having one drawback, like what is that drawback? See here, for example, the reference speed we have given initially 200 RPM. Later we will change it to 600 RPM. Then what happens? This KPK values we have tuned at particular speed of 1200 RPM. When we are changing into the 600 RPM, these KPK values also need to be changed again. But we are not changing it. But this speed being changed by using the step function. We can change the speed easily by using the step function. But these KPK values are not tuned in an online manner. Okay, so this is the drawback of our. Here we are applying the load on the machine. Maybe initially 20% load we have kept, and then we are increasing to 80%. Then at that time also these KPK values are not remain same. This value need to be changed, but this is not changing tuning online. So this is the drawback of the KPK values.
to get to find the transfer functional, to find the KPK values. I'll show the in the upcoming slides. Okay. So so here we have tuned the KPK values by using the root locus method using the closed loop transfer function only. And this is the KPK values. And how we have created this logic? Here there are six voltage vectors are available. Those eight voltage vectors are given from starting from V1 to V8, and based on the input receiving from the flux hysteresis controller and the torque hysteresis controller, we were having a V1 to V8. So this will give us the, suppose V1 it will give, V1 means 1 0 0. So the switches will be turned accordingly. Here we don't require any PWM controllers. And this is the two level inverter, and this is the result of direct arc control method. And here you can see the transient response. The speed of 2000 rpm is reached within 0.3 second. Earlier it was 0.6 second nearly. So the transient response is good while using the direct arc control method. And but the drawback of this direct arc control method, you see the notches of the torque ripple and the current ripples also you can see. So it gives a huge notches. So it creates the vibration in the vehicle. So we need to have a smoother operation, for which direct which this torque should be, ripple content should be reduced. So for which we have implemented the DTC with space vector modulation. And what is the reason behind that? Here we were using the flux and torque hysteresis controller. Because of that flux and hysteresis controller and torque hysteresis controller, the switching pulses you can see, this pulse, green, blue and red one. So these magnitudes are not remain same, which are varying. So which increases the switching frequency. But we need to have a same magnitude throughout the process. So the space vector modulation is promises the constant switching frequency, and which tries to reduces the torque ripple. So this is the diagram of the DTC with space vector modulation. So here, if you observe this diagram carefully, so this is the diagram of combination of two things. One is, this is a portion of direct arc control method, and this is the portion of the field oriented control method. There we had cascaded controller, and then PWM modulator, and then inverse torque transformation. So the ultimate the point is that by using the DTC space vector modulation, whatever the advantage available in the FOC and the DTC, definitely we will get it that. At the same time, whatever the drawbacks are available in the field oriented control method, there we need a slip speed to calculate the orientation angle theta, which is not required here. So means here means thereby the parameter dependency can be avoided. So whatever the drawbacks are there in the FOC can be reduced by using the DTC with space vector modulation. At the same time, whatever the drawbacks are there in the direct arc control method, their flux hysteresis and torque hysteresis controllers are we are using. Those are removed by using the PA, I mean speed controller. There we can use as PA. So this is the beauty of the DTC with space vector modulation. And how we are implementing the space vector modulation. So basically, the space vector modulation we are using to provide the switching pulses to the inverter. Okay, so to create this means to generate these switching pulses, we need to first initially identify. We need to identify where this V reference is fallen. There are 6 sectors in its space vector diagram. So in which sector the V reference has been fallen. So to identify those means to identify this V reference, we need to estimate the three nearest voltage vectors. For example, V reference is fallen in the sector 1. Which are the nearest voltage vectors of this V reference? V2 is the near one, V1 is the near one, V0 is the near one. V3 is far away, V6 is the far away. So we need to identify the nearest voltage vectors, two active and one null vector. Thereby we can realize the V reference fallen in the particular sector. So there is a certain procedure to realize where the V reference is fallen. So that procedure is we need to calculate the dwell time initially. So to select the nearest three voltage vector, the following parameter need to be identified. So first parameter is dwell time calculation. Dwell time calculation purpose. Initially, we need to identify the sector number. There are 6 sectors. In which sector the V reference might be fallen? That we need to identify initially. After identifying the sector number, the second procedure we need to, in second point we need to identify that in each sector there is a possibility of the number of regions. How we will get the number of region? The number of region we will get from the equation n minus 1 square. If it is a two level inverter, 2 minus 1 square. It means in each sector we will have a one triangular region. So the second point we need to identify the region. Then once you identify the region, suppose this is the that region we identified. V reference has fallen in the sector 1. When it is falling in the sector 1, what is the nearest one? V2 is the near, V1 is near, V0 is the near. Thereby we can identify the magnitude of the V1, V2 and the V0. So here only region next we need to identify. Once you identify the region, then the dwell time can be calculated. Thereby we can generate the switching pulses by using the dwell times. So we will see that procedure now. So initial point is first we need to identify the in which sector V reference might be fallen. So imagine that the V reference has been fallen in the sector 1. After identifying the sector number, our second job means how we will identify sector. So by using this mathematical equation. So KV is equal to fixed of theta by 60 plus 1. So why we are using the fixed term here? The fixed term we are using to avoid the non-integer value. What is that not mean? See, here sector 1, sector 2, sector 3, sector 4. All the integer values we have. We don't have any sector of 1.5, 1.8. So to avoid the non-integer value, we are using the fixed term. This is a MATLAB arithmetic function which avoid the non-integer value. So from this equation we will get the directly whether it is falling in the sector 1 or sector 6. So this now imagine that this equation is giving us sector 1. Then after identifying the sector, then what is our next point? Region. So in each sector there is a multiple regions are possible based on the level of the inverter we are applying. N minus 1 square. N indicates the level of the inverter. So here only one region exists in its sector 1. So no need to identify the region as only one region is available. Now you carefully observe. So when V reference is fallen in the sector 1, what are the nearest voltage vector? V1, V2 and then V0. So the V reference is fallen in the sector 1 for a sampling period of Ts. The total sampling time we know that Ts is the total sampling period. Now in this total sampling period V reference is fallen in this sector. So what is the time magnitude means how much time this V1 being on. So here the duration of the T1 the V1 will be on, duration of T2 the V2 will be on, for the duration of T0 the V0 will be on. So likewise the total sampling time is equal to T1 plus T2 plus T0. So that is this total sampling time will be given. So as per by using the mode cycling balancing equation, this V reference, this V reference has been applied for the duration of Ts. So V reference Ts is equal to this is the voltage vector V1 plus
duration of the time T1 and plus this is the voltage vector V2 applied and V2 plus T2 plus V0 T0 that is being given by the volt second balancing equation. So now here we have a vector V1, V2 and then V3. Then what is the magnitude of the V1? So V1 we can write it as a, this is the maximum quantity of the V1 will be given a 2 by 3 VDC. This is the maximum magnitude of this vector is 2 by 3 VDC. So here V1 is equal to, this is a vector, right? So 2 by 3 VDC e power j x axis, so 0. Then if you write in terms of the complex, then 2 by 3 VDC cos 0 plus j sin 0. As cos 0 is equal to 1, then V1 we can get it as a 2 by 3 VDC. Similarly, what about the V2? V2 is equal to 2 by 3 VDC e power j 60 as V2 is phase displaced from the V1 is 60 degrees. So we can also calculate the V2, similarly V0. At the same time, what is V reference? V reference is equal to V reference of e power j theta. So that will be given V reference. Now substitute this equation number 3 into the equation number 1, wherever the points are there, V1, V2 and V0, and separate its real and imaginary quantities. When you separate real and imaginary quantities, this is the real one and this is the imaginary one. So what is our aim here? We need to identify the dwell times. Thereby we can generate the switching pulses. So here in this equation we have a dwell time unknown quantities of T1 and T2, where in this equation we have dwell time of only T2. So here there are two unknown, here only one unknown. So now simplify this equation number 5, thereby you can get the dwell time T2. Once you know the T2, substitute this T2 into the equation number 4, thereby we can identify the dwell times T1. So once you know the T1 and T2, can't we find the T0 because the total sampling time is equal to T1 plus T2 plus T0. We can easily calculate the T0, that is equal to Ts minus T1 minus T2. So thereby we can calculate the T1, T2 and T0. So now these dwell times are calculated in the sector 1. So by using this dwell time, we can generate the switching pulses in the sector 1 that is being fed to the inverter. Now point is, this V reference may be fallen in the sector 2 and sector 3 also. So do we need to do the mathematical equation for each one? So need not to do all this mathematical equation programming. Just write a command with T1 is equal to, wherever the theta you identify, this theta being replaced with the theta dash is equal to theta minus of k minus 1 of 5 by 3. So this will give us the dwell times wherever the V reference is fallen in any of the sector accordingly, because this theta is replaced with the theta dash. So while implementing the SVM, space vector modulation, certain conditions we need to obey. What are those conditions? Basically, the first condition is that whenever the V reference is moving from sector 1 to sector 2, so whenever it is moving from sector 1 to sector 2, transition in a switch, it means this is two level inverter. So the switching transition on and off should not happen frequently. It means the transition in a switch should be 1 or 0. Then we will get the proper switching pulses. So that is condition 1. The second condition is that whenever the V reference is fall in sector 1, all the three legs of the inverter should on. Means sometimes there is a, due to the error, only two legs will be on, third one will be not on. So the second condition we need to obey that, means all the switches means all the three legs should be on at a time. By obeying that one, we can generate a beautiful pulses in the 6 sectors. So these are the pulses that are being generated in sector 1 to sector 6. And in addition to that, here we are needed of controller, flux controller, torque controller, and the speed controller.
and this controller being implemented by using the PI controller. So as we are using the PI controller, so we need to tune the KPK values. So these KPK values we have tuned by using the root locus method. So here, this is the diagram of here you can see. So this is the portion we have taken. The reference speed is compared with the actual speed. So this is that portion. So here we were having, this is that portion. So this portion can be implemented in a closed loop manner, and we will get the closed loop transfer function. GS is equal, this is the closed loop. So we have calculated this transfer function, and this transfer function, from this transfer function we achieve the KPK value. So this is that closed loop. So you are asking, this is the how we have implemented. So this is the closed loop PI controller. So this is that transfer function. So this is the two pages of transfer function, means we need to calculate mathematically. So ultimately we will get the finally this is that closed loop, and by using the transfer function only we achieve that one. And similarly, for the flux controller, so this is the closed loop of flux controller, and this is the transfer function we have, and we identified the KPK for flux also, and then torque also we have identified, and these are the gain values we found after calculating the gains, and this is the simulation diagram which we implemented in the MATLAB sibling, and these are the ratings of the motor. So here we are in a very cautious manner we have taken the parameters. See, whenever you are having intention of implementing the hardware, so better implement the simulation with the parameters of the hardware, that is motor parameters. Or initially, if you are purchasing the motor later on, at least after purchasing of the motor, implement the simulation with the concerned motor parameters, because sometimes what happens, I have seen that while doing the papers review, people are giving the simulation result with other motor and comparing the simulation result with the experimental result of different parameters. When the motor ratings are changes, the RS, LS, LM, LS, LR, these values changes. Okay, so you implement the simulation again after purchasing of the motor, and many people forget to ask the vendor to provide these parameters. Okay, so this parameter, to identify this parameter in the laboratory, little bit difficult, though we can get the approximate value, but we will not get the accurate one. Why? Because we are purchasing the machine with the load. Okay, when we are purchasing machine with the load, we are either block rotor test or open circuit test we are applying to identify the parameters. But this motor also is connected to this motor, so we cannot achieve accurate parameters. So when the motor, AC induction motor or PMSA motor ideally there, then that time we need to apply the block rotor test and the open circuit test, then only their parameter will get. After coupling we will not get accurate one. So ask the vendor before assembling the, means making the setup of coupled one, you ask the vendor to give this parameter carefully. Okay, so these parameters are essential for implementing the simulation, and while implementing hardware also accurate parameter values are essential, otherwise we will not get the proper output. See the stator resistance value for the PMSA motor 0.09. So in the decimal value, see 0.09 resistance is there in the winding. So if somehow if you write 0.9, your performance result means you will get the huge notches. Okay, so we need to have these parameters carefully from the vendor. And we have implemented this DTC SVM, and you can see the transient response of the DTC SVM. The speed is reaches to reference speed of 15 RPM, maybe within 0.15. Earlier DTC
it is overlooked and then it is settled nearly here. But still compared to the DTC, it is better, and the top peoples also better as compared to the DTC. This is under loading condition, and here in addition to the top people, we have also seen the current THD, line current THD is 10.74 and the voltage THD is 44.36. But what IEEE standard is saying, we need to maintain the current THD less than 5%. But it is little bit difficult for the drive application to get the THD less than 5% with the only two level inverters, because lots of parameters are involved for achieving this one. So two level inverter we could not able to achieve that one, but to achieve that one and further you can see the current result here. There are little bit notches are there, so and you can see the voltage result, line voltage, which is not a sinusoidal one. Okay, this is the one of the reason why these harmonics are keeps on increasing. So to achieve the sinusoidal one and to reduce the ripple content, we have gone for the three level inverter. So next we have implemented the three level inverter to reduce those effects. And this is the advantage with the DTC SVM, whatever the drawbacks available in these two methods, which are eliminated by using this method. And this is the three level inverter. Why we are going for the three level inverter? Because of the reason is to further reduce the ripple content in the torque and to reduce the current THD and the voltage THD. So this is the diagram, DTC space vector modulation. Now changes comes in these two blocks only. So here we will implement the three level space vector modulation, and here the schematic diagram of the three level inverter. Uh, Always we are saying the diode clamped one. Okay, we are not implementing the H bridge. I'll tell you the reason little bit later, as we have implemented, but in terms of the cost effective, it is not advisable to go for H bridge. So as we all know the why we are going for the multi-level inverters, that is converters. So the one reason is we will get the lower distortion and losses will be less, and we can get the low THD and etc. For good power quality. So these are the certain reasons. And in the literature there are different types of inverters are available topologies, that is flying capacitors, neutral point clamped, and cascaded H bridge. For the drive application, we found the NPC is suitable up to 5 level. If you want to go for beyond 5 level, then maybe cascaded H bridge will be the best among these two only. So flying capacitor is not suitable for the drive application, as number of capacitors involved, and balancing up this capacitor is very difficult task. So this is not advisable for the drive application. And as this is the schematic diagram of the three level diode clamped inverter. So here in each means in its schematic diagram, how many semiconductor devices are required? As the name says, three level inverter. So here we will have a three pole voltages. So the pole voltages is equal to zero point 0.5 VDC, 0 minus zero point 0.5 VDC. So these three pole voltages will be there based on the name exist. And now here in this diagram, how many semiconductor devices will be there in the entire diagram, and how many semiconductor devices will be there for each leg, how many diodes will be there in the clamping diodes are there for the each leg will be given based on the formula. This is the simple formula which will implemented for any level. Okay, for example, you can see here how many semiconductor devices will be there in a particular level, which will give 6 of n minus 1. So this is a 3 level, 3 minus 1 2. So 2 multiplied with 6, there are 12 semiconductor devices will be there. So each leg having 4. So 4 multiplied with 3, 12 semiconductor devices are there. Similarly, in each leg, how many devices will be there will be given based on this formula. And clamping diodes also. So this is the those formula we have utilized
to identify number of devices. And as name suggests, three four voltages will be there, and each leg having four switches. So there are four switching states. So here we can implement different methods, PWMs, sinusoidal PWM or space vector modulation PWM. As space vector modulation gives the best compared to sinusoidal one. So we follow the same for the 3 level also. So here we are implementing now space vector modulation for generating the pulses. So what is the procedure involved for implementing the SPM? That is, first we need to determine the dwell types. For determining the dwell types, we need to identify the sector initial. So first we need to identify the sector. Once you identify the sector, our next job is to identify the region number. So in earlier case, we identified only one region exists. But in the current three-level inverter, you see how many regions are there? N minus 1 square. So 3 minus 1, 2. 2 power 2, 4. So in each sector, there are 4 regions. Region 1, region 2, region 3, region 4. So there is a necessity to identify the region also in this three-level inverter. Earlier we don't require that one, but here it is required. So first point, we need to identify the sector. After identifying the sector, we need to identify the region where V reference has been fallen. Once you identify the region, then suppose the variable is falling in this particular region. So what is the nearest voltage vector for this region? This fellow is near, this fellow is the near, and this fellow is the near. Thereby we can find the magnitude of these vectors, this vector, and we calculate the dwell times. So here major task is we need to identify the region number carefully. So sector number will be given by this mathematical equation, simple mathematical equation, and imagine that the V reference is fallen in the sector 1. Okay, sector 1 V reference is fallen in the sector 1, and which region we don't know presently. Okay, so this is the space vector diagram. Now, to identify the region number, so there may be a chance of falling here also, there may be a chance of falling here also. So now we need to identify the where it is fallen, region number. So to identify the region number, what we will do, this is a way reference. The way reference is splitted into two components. This V reference is split into the two components as K1 and then K2. When we split it into the K1 and K2, what is K1? The K1 is equal to the V reference of cos alpha minus 1 by root 3 sin alpha. So there is a one page of mathematical calculation to obtain this K1. So we will get this K1. Then what is K2? If anybody required, I will provide that mathematical simplification. K2 is equal to 2 by root 3 V reference sin alpha. So we will get the two components of K1 and then K2. So now there are four regions are available in the sector 1. So to identify the which region, we need to have certain condition. So if this is the situation, then imagine V reference is falling in the region 1. If this is the satisfied, then that is the region 2. Likewise, we have written a condition A, K1 is less than 1 by 3, K2 less than 1 by 3, both together K1 plus K2 less than 1 by 3. If this criteria satisfies, imagine the V reference is falling in the region 1. No. If K1 is less than 1 by 3, K2 less than 1 by 3, both together greater than 1 by 3, then imagine the V reference is falling in the region 2. Likewise, we have written a condition, and then based on that condition, we will get a particular region.
Why you should take, sir? K1 plus K2 is 1 by 3.
This is the mathematical equation, one page mathematical equation is there. So to write the condition, so whether the magnitude of the this K1 K2, whether we are achieving 1 by 3 or less, so we have written certain condition to get the tentative region. That is the only source we found. So we have written a condition. Okay. So based on that condition, we have written mathematical equation only. Okay. And now from this condition, imagine that V reference is fall in the region 1. So this is that region. You can see, so now V reference is fall in the region 1. So when it is falling in the region 1, there is no need to follow here. Maybe here also. There also we will apply V14, V7 and V30. Okay. Now imagine here. So now the nearest voltage vector is V30, V14 and V0. Now you see the magnitude of each vector here. See, this is the one magnitude. The maximum magnitude we will get 2 by 3 VDC. This is the maximum value we will get 2 by 3 VDC. But this is the magnitude is lesser as compared to this fellow, right? So this magnitude will be different. This magnitude. So there are four different types of magnitudes are available. That is one zero. This is small, and this is the medium one, and this is the larger one. So here we need to. These are the four different magnitudes are available. It means the small vectors are belongs to V30 to V80. This is V30, V40. So now the V reference is fallen in the region 1. Nearest voltage vector is V30, V40 and V0. Then what is V30? V30 is equal to 0.33 VDC e power j theta. That theta is equal to x-axis of 0. So we will get the V13 is equal to 2 by 3 VDC. Likewise, V14 is equal to 0.33 VDC and e power j 60. Likewise, we will calculate the V30, V40, V0 and we also know the V reference. So, those quantities substitute in the equation number 3 and separate real and imaginary quantities, then we will get the, this is the imaginary one, equation number 7 and equation number 6 will be the real one. So in the equation number 6, we have a two dwell time unknown, that is TA and the TB. And equation number 7 having the only dwell time unknown is the TB. So now equation number 7 simplify. Then you will get the TB is equal to 2 root 3 V reference by VDC sin alpha multiplied with total sampling time. Once you know the TB, this TB is substituted in the equation number 6, thereby you can get the TA. Once you know the TA and TB, then we can calculate the T0 by subtracting from TS. So these are the dwell times we find in the particular region because V reference is falling in the region 1. But now there is a chance of other regions also there is a chance. Then how to identify that? So here the alpha fellow is exists. This alpha is replaced with the alpha dash. Then we can identify the another regions also. In any region we can identify the dwell times. So based on that dwell time, we can design the switching pulses in every sector. And this is the three-level diode clamp inverter schematic diagram. And so when we will get the 0.5 volt pole voltage, when upper two switches on, then we will get the 0.5 voltage VDC. And then when the lower two switches on, we will get the minus 0.5 pole voltage. And middle switches on, then this is the 0 voltage we will get. And this is the two level inverter and three level inverter result. Side by side we are given for the comparative purpose while writing the paper. And here you can see the thickness of this line and thickness of this line. So thickness of this line top people is less as compared to here. And at the same time, not only the thickness, you can see the settling time also reduced. So here little bit more means little bit, not more, but in terms of the thickness only, it is reduced more. And this is under loading applied. We have applied 60% of the load on the drive. Then we found the ripple content in the torque. And here you can see the whenever we are applying the load on the machine, the speed reduces and because of the PI controller and it again goes to the steady state. So where the reference, whatever the reference speed we are applying. So because of the loading applied, it is happening. And when the load is removed suddenly, then
some moment of inertia because of that, then this overlap will be there, and then it is settling back to the reference speed. And you can see the THDs in the 2 level and the 3 level. The current THD we found that 3.16, and here we have found that 10.74. As per IEEE standard, by using 3 level inverter, we could able to came between less than the 5%, and the voltage THD will be 35%. And you can see the voltage using 3 level little bit sinusoidal manner we able to get it compared to 2 level.
Fundamental component is frequency 125 kilohertz.
We have taken at that point. We can take it. If at 50 also we can take it. So for the both the things we have taken at the same one. For compared 125 only we have taken.
Normally we take a fundamental
50.
50. Is there any reason sir, to get the 125?
No, while plotting only student might be taken at 125, but we can take it at 50.
Sir, I have a question. For industry purpose, as level is increasing, cost is increasing. So
Level is increases, cost will not increase. Why? Because see, when suppose drive 5 kilowatt machine is fixed. Now we are implementing the inverter, power converter. So drive is fixed. Now we are changing the level of the inverter. When we are changing the level of the inverter, what happens while implement two level? We need to use the IGBT switches of 1000 volt rating. But when we are going for the three level, we require in each leg we require means we are shifting the voltage rating. Okay, so we can purchase the small rated devices, semiconductor devices, instead of spending the huge amount for single device. Okay, thereby the cost means if you are implementing the three level by using the same switches of the two level inverter, then cost effective. Okay, so if you implement a three level by reducing the power module size also, because the power rating of the each module reduces when you go for the multi-level inverter. Otherwise, we cannot reduce because we are applying the voltage is less value and lesser time. Okay, so that is the advantage. Multi-level inverter we can reduce the that IGBT rating also. Okay,
Before size.
before.
So now the THD current THD is reduced. So what is about the ripple content in the torque? How much it increases?
I'll show you the in the slide. This is the ripple content. Torque ripple content. This is plus or minus 3.6 and it is plus or minus
Only
2.6.
slight change.
Slight change.
But if you have the before slide, the fundamental component of the voltage, so 125,
125.
178.1 volt magnitude, THD for. But here, 33% means 10% reduction. Because of that, the voltage will be double.
Okay, we have not gone in that way, but ultimately our aim is to reduce the THD, and here we need to satisfy the IEEE standard. That is our concern. But as we are using the multi-level inverter, obviously the power loss will be reduces little bit because we are applying the means two switches are on, so we are applying the power level, distributing the voltage. Then loss component reduces, thereby torque ripple reduces little. I am not saying huge ripple. Okay, so that is the advantage. Here our main focus is to current THD reduction.
What are the common coupling voltage? So you put a motor. So there is a common coupling voltage.
We balance up to 3 level and 5 level we could able to balance it. So you are asking value.
Yes.
Value I didn't remember exactly, but we could able to manage. That is the point I am saying from starting. So when you are implementing the neutral point, so common coupling that means capacitor, two capacitor cascaded commonly connected, na? So we need to balance it. If it is not balanced, then so obviously when you balance, then it will come zero. So if you don't balance, then that will be the effective. That's why the neutral point clamped inverter implementation higher level, the 5 level, 7 level, and 9 the same that one only. So we could able to manage up to 5 level. Okay.
For that manage, you apply any switches for that.
Next, we'll see the 5 level. Up to 3 level, no need of any manage. So this is the comparative result we have taken. One of the reviewer asked us, you are providing the result at particular load. Give us at 30%, 50%, 70%, 80% also. So when we have given the result, we realize that whenever we are operating the machine at a low load, then we are getting the THT is higher. When we are applying, of course, we will get the efficiency higher when we operate fully on full load only. Okay, so then this is the advantage we were getting under different loading conditions when we are applying. And why we are going for the 5 level inverter? So we found that little bit notches are reduced in the torque, but if we go for the 5 level, can we further reduces the torque ripple? So in that manner, and can we further reduces the THT in the 5 level? So in that way only we went for the 5 level inverter. Then so this is that diagram, and the same space vector modulation we are applying, and this is the 5 level schematic diagram, and how many switches are required in each leg, and entire diagram will give you by the based on same formula. And these are the 5 switching states, that is 4 voltages, 5 4 voltages. And here the problem comes when we are implementing the 5 level space vector modulation. So I will see from the diagram. So here in each sector there are region come from the n minus 1 square. So 5 level 5 minus 1 4 4 square 16. So 16 regions exist in each sector. That is one point. Identification of the region will be the difficult. As earlier case, we have only 4 regions, so we splitted this reference into 2 components, and we have written one mathematical expression, and we have written the 4 conditions, and from that 4 conditions we could able to achieve regions. But here there are 16 regions. So to write a logic for the 16 region, we found the difficulty. Okay, that is one difficulty. And not only that region problem, there is another problem. So imagine this V reference, this is a V reference. So this V reference is fallen in the, suppose take this red line only. So in the R line region it is fallen. Up to now we didn't find any difficulty of the switching states. That is, here when it is fallen in this V region, at this point, how many voltage vectors are available? These greens are showing 1, 2, 3. At this point, there are 2 blue lines. It is given. This is one vector. This is another vector. Up to now, up to 3 level, what happened? Whenever it is fallen in a particular region, we found only one vector. To realize the V reference, we needed 2 active vector, 1 null vector. But in this problem, what is happening when it is fallen in this particular region? Here, 3 voltage vectors are available, origin, and at this point, 2 voltage vectors are available. At this point also, 2 active voltage vectors are available. So, which one is nearest? It is difficult to identify which one is the near. So, because each vector gives a different result. So, that is one difficult. Suppose it is fallen in this region. Again, here we were having 3 vectors, and here we were having 3. Here we were having 3. So, there are 9 voltage vectors are available in this region. Among these 9, which one 3 are the nearest? So we found difficulty of same logic which we applied up to 3 level. The space vector modulation means this logic we could not able to apply for the 5 level. Then what we made the, so instead of making the space vector modulation logic for the 5 level, we have converted this 5 level space vector modulation into 2 level. So certain logic we have written, and by writing that logic we have converted this 5 level space vector modulation diagram into only 2 level, this hexagon one. Okay, so we converted this entire into the single one. How we have converted, we will see. So All our assumption only we have made, means certain with certain assumption we could able to achieve that one. Ultimately we can convert based on the two level. We will get the final one will be the this green one we will get. So how we are implemented we will see. So as we are implementing the space vector modulation for the 5 level inverter, but based on the 2 level space vector modulation. So in the 2 level and the 5 level, the procedure will be the same. So the first we need to determine the sector number. So to determine that sector number, same mathematical equation we will utilize, that k is equal to some fixed of theta by 60 plus 1. So from this equation we will get the sector number easily. But main task start after identifying the sector number. Now the second point, the region where the V reference is falling. So now to identify the region, what we have done, we have again made certain logic. So what is that logic? Imagine these three slopes, that is K1, this is K1 dash, K2 dash, K3 dash, which are passing through the end tip of the V reference, that is beta is equal to root 3 times of alpha minus K2. For this also there is a two-page mathematical equation is there. At the end I'll show you if you want. So and this is the K2, that is K1 dash, that is beta is equal to minus root 3 of alpha minus K1 dash, and for this K2 beta is equal to root 3 of alpha minus K2 dash, and beta is equal to K1 dash. So here these are the three values we were taking for the K1, K2 and the K3 dash. Now what is K1? So the K1 dash is equal to, we could simplify the final equation, K1 dash is equal to V alpha plus 1 by root 3 of V beta. Then K2 dash is equal to V alpha minus 1 by root 3 of V beta, and K3 dash is equal to V beta. So now this K1 dash, K2 dash we have taken, these are the coordinates of V alpha, V beta when the origin is at this point. So before identifying the region number, the coordinates of V alpha and V beta for the K1 dash and the K2 dash. This is the K1 dash, K2 dash is the alpha coordinates, and K3 dash is the beta coordinates. Now we know the K1 dash equation, K2 dash equation, K3 dash equation. This equation help we are taking to identify the region number. So here again the region number we are having the integer value, we don't have any non-integer value. To get the integer value, what we have done, we have scaled this K1 dash, K2 dash, K3 dash to K1, K2, K3. K1, K2, K3 to avoid the non-integer values. There may be a chance of getting 1.9 or 1.10 or something. So to avoid that non-integer value, we scale that K1 dash into K1, that is equal to fix of K1 dash by H. So K1 dash by H. Then what is H here? H is equal to Vm by N minus 1. Then what is M? The maximum voltage that Vm is equal to 2 by 3 VDC. And what is N? That is the number of levels. And similarly, K3 is equal to fix of K3 dash by K. So what is K? K is equal to 0.86 is the maximum magnitude we will get. That is equal to 0.86 by Vm by N minus 1. So here we have written our logic. So if we find these values, then imagine V reference is fallen in the particular vector. Likewise, we have written the equation. From this equation will give you the particular region. So in this equation we have K1, K2, K3. These values will come from this mathematical equation. We have substituted here, and this equation will give you the one particular region number. Now, after so we identify this region. In the next slide you can see. So here we identify the region number 9 from that mathematical equation. After identifying this region, we found the difficulty of identifying the nearest voltage vector. So here also number of voltages vectors are available here also. So what we have done, we have converted, means this origin is shifted from this point to this point, and this entire region, means this entire triangular we converted into the single
triangle. And here we found that only one vector V6, V7, V10 available. So we converted this entire into a single triangular region similar to the two-level inverter. And likewise, we found the dwell times for the each region. So we have simplified the five-level space vector modulation based on the two-level by writing some mathematical expression. Okay. So this is the switching pulses for particular region. And this is a five-level right clamped inverter schematic diagram. And when we will get the 0.5 voltage upper four switches, and then 0.25, and then 0, and then minus 0.25, and then minus zero point 0.5, lower switches will be on. And see here the ripple content from 2 level to 5 level. The ripple content of 5 level is less as compared to the 2 and 3 level inverter. And this is under loading condition. And this is under various wide speed operation from 600 rpm to 900 rpm, 900 rpm to 1200 rpm. Likewise, we change the speed to see the behavior of the torque ripple and current ripples. And this is again THD of 2 level, 3 level, and the 5 level. So the 5 level THD we could able to achieve 1.6, whereas in 3 level 3.36, and the voltage THD will be 17.44. So while comparison, we have taken same magnitude and at the same fundamental frequency, we have taken the result. Otherwise, we will get the different output. So to compare three simultaneously, we need to same magnitude, same frequency, same fundamental frequency we have taken. And this is the 3 level and 5 level. Other parameters, torque ripple, voltage THD, current THD also we have compared and found that 5 level is giving the best as compared to 3 level inverter. And as loading cases also we have compared at different loading 30%, 50%, 80%, and then 100% loading we have compared. So up to now we have implemented 2 level, 3 level, and the 5 level inverter, and then we have also implemented the hardware setup in the lab unit. So while implementing the hardware, so what changes come from the simulation? What are the changes there will be the from the simulation? So basically this is a simulation diagram. So in the simulation diagram, we implemented the voltage source inverter in the simulation, and here the motor also we implemented mathematically. But while implementing the hardware, these two parts available physically outside, this inverter part available outside and the motor part also available outside. So here this MATLAB sibling is interfaced with the controller. So if you are using the D space, then the MATLAB is interfaced with the D space, or if you are using the FPGA, the MATLAB is interfaced with the FPGA controller. So this block, in among this block, simulation block, this part and this part will be physically available outside. Okay, then how we are providing the switching pulses to the inverter? The switching pulses, to provide the switching pulses to the inverter, we need to have a certain controller. So IO ports are required. From that IO ports, we can give the switching pulses to the inverter. So to get those IO ports, we have in the market there are different types of controllers are available. The first controller we have D-space controller you might be heard. Okay, so we have a D-space controller. In addition to D-space, we are having FPGA controller. We were having the microcontrollers also we have. So any part of controller we can utilize to give the pulses to the inverter. In addition to these controllers, we need to measure the outputs. Like we need to measure the whatever the characteristics we have seen up to now, currents, voltages, speed, torque. Those characteristics we need to capture. Then how can we capture? By taking the DAC codes, digital to analog converters. So we will measure the speed. This is the induction motor. So here the inputs are receiving from to the induction motor or PMS motor from the inverter. So to measure the line voltage, we will place a voltage sensor in between two lines. And if you want to measure the current, then here we will use the limb current sensor in the this phase. So it will give the phase current and then line voltage we will get. If you want to measure the phase voltage, and in between here and the ground terminal you can connect, then you can measure the phase voltage. So those measured phase voltage and then measured currents given the feedback to the that controllers. If you are using the DSpace, then we have ADC channels, analog digital converter channels we have. So those measured channels output we will connect directly to the controller. That is DSpace ADC port we will give the feedback. So those feedback signals are given to the on the D space through the another digital converter ports. Okay, and for this inverter we will give the pulses by using the IO ports. In each D space we will have at one pin it will give 32 IO pins, another pin it will give the 16 IO pins. In addition to this, we will have 8 ADC ports are available. So we can utilize all these pins to give the feedback signal at the same time to give the signal to the inverter. So this is the beauty of the DSpace. So here this is the experimental setup we have implemented in the lab, and this is the fellow. This is the part is the DSpace, and all these wires, small threads which are visible, which is connected to the IO through IO ports to the inverter, because here we need to give the pulses to the inverter. This fellow inverter is physically available outside. So how to interface between the inverter and then the D space? So here we will use the IO ports and the pulses will be fed to the inverter. Here we are logic is implemented here, but the pulses are given from the IO ports to the inverter. Okay, and here we are measuring the speed of the inverter. The speed of the inverter is measured in the analog manner, and which is connected to the ADC, analog digital converter ports. At the same time, here we were using the this part basically. Here we were having a current sensors, LEM current sensor we have used. The current sensor, this LEDs are the inverter output is connected to the PMSM motor. So here the inverter outputs are there, and here in the wires we were having LEM sensors, and each phase current we were measured, and that measured current signal is given to the on controller itself, okay, to ADC port. And if you want to measure any current signal, then from where we will take in the D space again we were having a 8 DAC, digital analog converter ports. Okay, so this is the available in the DS1104. 8 analog, 8 digital ports are available. So those 8 digital ports, digital analog ports, by using that we can measure the current quantity, speed, whatever things you want, you can measure. Okay. So this is how we will utilize the DSpace controller. This DSpace controller is interfaced with the MATLAB for implementing the logic. So this inverter available physically outside, motor also available physically outside. The communication between the hardware means physically available equipment and then MATLAB, this fellow DSpace act in between for the communication purpose. Okay, whatever signal we are measuring, we fed to the DSpace, and whatever the things we want to measure, we get from the DSpace. Okay, so here we utilize the DSpace. Is it only DSpace can do? No, any controller can do the same job, but in a different manner. So here we can also utilize the microcontrollers. Here we can also utilize the APJ also. Okay, so as if someone is very good at MATLAB, then these spaces they feel easy. If someone is very good at JAYABABU or writing a program,
program, they feel FPGA feel good. Okay, it's not the first to use this space. It depends upon their expertise. As Shankar sir is using FPGA controller, yesterday he came here, and I'm expert in the displays. So I feel for me because as we are implementing the simulink, MATLAB simulink, then we can easily interface. Means we can connect through simulink only.
It will generate automatically generate the codes. Sir, we are saying that control the DSP using the laptop.
No, no. Here there is a problem. Uh, we using the laptop, we can make it when you go for the micro lab box. One micro lab box is there. That will be handy. We can means wherever you want, you can connect. LAN ports we have not. So the communication purpose. This is a controller for this DS1104. This much what we call the inserting port which is inserted on the motherboard, that PCA slots, PCIe slot, particularly for this DS1104, all the computers are not useful. Certain particular the desktop computer which are having slot of PCIe. Okay, if that slot is available, then only we can able to install this DS1104. If it is not there, then we need to see the alternate one. Okay, so this HP desktop particularly purchased for the installing this DS1104. So while purchasing this desktop, we given a one specification. So like in addition to the RAM, hard disk, and size of the monitor, we have also mentioned particularly the PC slot, PCIe slot is required. So that slot is available for installation of this one. So maybe in the next image you may see that one, how bigger it is. And here, how we are applying the load on the machine. So this is the PMSM motor, which is coupled. This is the 4.5 kilowatt PMSM motor, and this is the 5 kilowatt generator. So we have taken the additional load of, we can so that we can apply 100%. So this is the 5 kilowatt generator, and how we have applied the load on the motor? We have applied the load on the motor indirectly through the support of the resistive load. The resistive load is applied on the DC generator, which is coupled to the PMSM motor. The load is applied on the PMSM motor, and this is how. And this setup was created because of the support with the support of the CEN DST. They have sponsored a project with the worth of 40 lakhs. Out of 40 lakhs, the 20 lakhs budget is given for the equipment creation. So we procured this motor and the desktop and this DS1104, and of course this inverter we have given a configuration how we required it, and the name you can see three phase reconfigurable inverter. Reconfigurable means the midpoint between the switch to switch, the tap point we have brought outside so that we can utilize the same inverter for the 2 level, 3 level, and the 5 level. Okay, wherever we do, means if you are implementing the 2 level, then only two switches are there in the each lane. So the if we are using the 5 level, then there are 8 switches. So midpoint four, three midpoints will be there. We will open the three midpoints. Only remaining will be short circuited, and we will use the only two semiconductors. Likewise, we made a configuration so that we can operate in the three modes: 2 level, 3 level, 5 levels.
Sir, I have a question. Where you get the quotations and all, where you purchase all the equipment, sir?
See, these quotations we can get the from any company. So there are different companies are available in the market like V Instrument, VN Microsystem, and G2 Gold, and there are different. But finally, after placing the bid in the GEM section, GEM portal, you might be heard, government e-portal basically. The government organization institution must give the first priority for the GEM portal. Okay, for the whereas a private institution need not to go for that one. It's up to whoever gives the directly means it's management amount. But whereas for particularly government organizations like IITs, NITs, and the CFTIs, we cannot purchase directly by contacting one person.
Sir, if it is a funded project, for example,
Whatever. should be through proper procedure. Okay, first we need to go for the GEM, GEM portal, government e-market portal, and if it is not available, then we can go for the CPT. That is, we can call a tender. CPT. Okay, CPT. Public, some common public, some portal, something. Okay, so CPP portal. So anyone can see that one. But in the GEM, they need to have a access. They need to purchase the, means they need to register like GST. In the GEM also they need to register. Okay, so they need to show the some annual turnover. Then only they are eligible to participate in the GEM portal. So the NITs are not having simple freedom to purchase, like some JAYABABU, Dr. JAYABABU is a good person to give with the lowest rate. This is not feasible. Means this is not applicable for us. We need to go for open tender. So anyone can participate. Okay, but we can write a stringent conditions, like we need these equipments only with this rating. Okay, so this is the equipment. Ultimately, the finally we got a vendor, V Instrument from Chennai-based company, and we received in a working condition. They have given us by installing this equipment, and they will not operate all this level inverter. They will run in a open loop. This motor, whether it is running, or whether it is giving sinusoidal result or not.
So you supplied that motor, PMS.
We supplied the PMSL motor. They supplied. We procured it. Okay. They operate in a open loop and they give us by installing. And this.
Okay.
And see here, this is the fellow. You see the carefully. This is the one type of inverter. This is based on the neutral point clamped inverter, and this is the another inverter. This is a 7-level cascaded H bridge inverter. So cascaded H bridge inverter, we implemented a cascaded type also to see whether any differences comes between the NPC and the H bridge. In the output result, there any difference? Then we realize that we are not getting any difference in the output by running the 5-level NPC inverter at the same time 5-level cascaded H bridge inverter. So for the comparison purpose, we operated with the both the ways, and we found that both are giving similar performance. The only difference is that here we don't require the isolated DC supply, but here we require each bridge. This is the bridge. You can see this is the bridge, and these two ports are there. This is the isolated DC supply. This is isolated DC supply. Likewise, the isolated DC supply is given to each branch. So that is the only difference, and this is the almost we procured with the cost of 9 lakh, and this is we procured almost cost of 6 lakh. So where the almost 3 lakhs is going, because here the lower portion they have placed all the isolation transformers. So they have given supply from the main supply. They have given through auto transformer. They have given supply to the isolation transformer. Through isolation transformer, they given they able to brought the individual isolated voltages for each bridges.
That V supply is there, na sir. That independent separate V supply. Is it rectifiers or on DC batteries? That
Rectifier only.
rectifiers.
Through isolation transformer, inside rectifiers also there. We are not giving direct DC supply. Okay, through auto transformer, it goes to the isolation transformer. Through rectifier only, they are getting. But we can give, if it is available in the laboratory, directly by avoiding this rectifier, we can directly give here. Okay.
We can apply the battery direct.
But that was a huge battery. So to operate this machine, we required 400 volts. Applying the 400 volts batteries are not available. Even up to 12 volts, 24 volts, maximum 48 volts batteries are available. So, so this is the hardware, and see in this diagram, interesting part will be there. So this is a fellow of TMS controller. So see here the logic, you can interface the MATLAB
This is the TMS controller we procured with the cost of 5,000 rupees only, not 6 lakhs rupees. This is the equipment of TMS controller. This is a one microcontroller. Whatever job is done by the using DSpace 1104, we can do the same job by using this TMS controller. Launchpad we call it as Texas Instrument. This is, and we can purchase within the 6,000 rupees. And for your people, for you purpose, this is very much means useful, because in the private organization purchasing a DSpace by spending 6 lakhs is very difficult. Even government organization also difficult. Because of the project support we could able to purchase it. Okay, but later we realized, and as number of scholar increased us, then we found we could not able to give one DSpace to each scholar. See, when a scholar is joined, then we need to create one setup. One multiple scholars cannot work at same place, because the hardware setup is dedicatedly required for particular cadet. So he throughout his PhD duration, he needed dedicated one. Other person cannot means he cannot get the result later on. Okay, so for that purpose, we purchase the launchpad TMS controllers. This is one kind of microcontroller. I'll show you the number. Then you can procure it in 6,000 rupees. Here, whatever the job we are doing with the DSpace, we can do that one. But we cannot measure the four analog outputs. In the CRO, two channel CRO is there, four channel CRO also there. Now six channel CRO also there. 5 channels here also there. So in the 4 channels CRO, we cannot able to measure analog signals of 4 by using TMS controller. Only two ADC ports are available. Sorry, DAC ports are available. Digital to analog converters, which are
Two signals you can measure.
only two signals can be measured. Okay, so the see in the result how we can produce in any manner. So two results you can show in the one diagram, another two in another diagram you can show. Okay, there is nothing wrong. So no one is asking to show all the result at a time. So this is the best one. You can utilize the TMS controller instead of the microcontroller, so that you can reduce the cost of the experimentation. So better purchase this TMS controller. This is very much essential and useful. Charging. So seems charging agent sir. Sir వస్తుంది. Okay, so this is that you can write down this number, sir. TMS 320 F283. So this is launchpad, and whatever the work we are doing with these are the IO ports. 32 IO ports are available. These are also IO ports. We can utilize this IO port for giving the feedback signal to the inverter. So whatever the work we are doing in the DSpace, by using the DSpace, we can implement easily. And even sometimes while experimentation, even if you supply highest voltage, need not to worry, because this is a cost of 5,000 only. If DSpace damages, is cost of 6 lakhs. And these are the equipments we have used while implementing that hardware setup. Those equipments are, this is a 5-phase PMSM motor, and sorry, 3-phase PMSM motor, and coupled with the generator and inverter we required. And this is a 10 kVA inverter we have taken, and DSpace, and their rating is given here. And 5 HP and 10 kVA 5 level inverter we have taken. And here IGBT switches we have used scheme 100 GB 12 the maximum voltage it provides 1200 volts, and current will be 100 ampere. So these are the switches IGBT switches we have used. And encoders we have used 512 RPM encoder, and this is the number we have used. And the rectifier is maximum giving 16 ampere and 100 volts. So these are the huge values, but for the safety purpose we have taken. This is the motor parameters, and same motor parameters we use for the simulation also. And this is KPK values breaks them. Okay.
Now you can take the break. After lunch break, all of you have assemble here only. The session 2 starts at 1:30, so it will go up to 2:30. So we are conducting the sessions as per the AST norms. Each session 1.5 hours. So, sir, taken today the plan is sir we two sessions, so it will continue up to 2:30. After 2:30, third session. Today there is no article discussions. So all the articles and discussions are completed. So the 4 into 2, 8 article discussions are completed. So the 8 sessions completed. So the today 3 sessions are there. Okay, so the at the end of this day, we are able to complete 11 sessions. Okay, so already we taken the permission from industrial visits. That is Effectronics, Bharati Solar Power Plant, Josel, next one is Avera Electric Manufacturers. So all of you try to plan for that. So we are already taking the permission for all the industries. So there we can see the problems and solutions also. So at the end of the day, okay, each participant should give the presentation what you have learned in this 12 days program. So okay, so thank you all of you. Thank you, sir.
How to define reporting and all for you, report what was the report?
చూసుకున్నా చూసుకున్నా నీళ్ళు పోతున్నా లేదు పెడితే ఇంకా మెల్లగా మనకి
Now the second session continued. Dear participants are trying to interact with the sir. Sir will give more information related to the research papers and the topics related to electrical vehicles and the power electronics devices also. So the try to interact with the sir and get the more information, sir. And sir has excellent research papers in various implementation and definition algorithms and frequencies. So please try to utilize the opportunity. Thank you.
Thank you, sir. Thank you once again for introducing me, and I'll try to cover the topics. So, with the experimental setups and results of experimental and paper publications too. And as I was saying previously, this is the experimental setup which is implemented in the laboratory of, at NIT Andhra Pradesh, and this is the launchpad. We can do the we can utilize for the control purpose. And these are the equipment we have utilized during the hardware setup. And these are the parameters of the PFSM motor. And this is the KPK values of plus controller, torque controller, and the speed controller. And here, I would like to tell you one thing. While doing the experimental setup, there are two ways are possible. The one way is for using the motor is mechanically coupled, a load is coupled mechanically, and here we need to apply the load on by using these drums. So, and second way is we can apply the load on the drive EMSM motor indirectly with the help of the rheostats, resistors, which can be applied in the PMS motor. So the difference between these two is that if you want to measure the transient performance, transient result, then the second coupled setup is best as we can measure the speed instantaneously whenever the load is applied. Whereas in the mechanical load, suppose if you want to 40% load on the machine, then that much Newton meter we need to rotate this drum up to some time to achieve that 40%. By that time, we are able to measure the transient performance result here. So this is the difference. So better whenever you are procuring, procure a machine, PMSM or induction motor, which is coupled with the generator. And this is the D space 1104. So here this is the D space 1104, and while purchasing the D space or any, so here we need to have these are the PCIe slots. So in this slot we will install this is the D space R&D board we call. So this R&D board we will install on the desktop. So here the PCIe slots are available. In that PCIe slot, we will install this DSpace R&D controller, and this part will be attached to DSpace R&D controller. And whenever we are utilizing the DSpace which is MATLAB interface, so we need to have this dongle. So this dongle need to be inserted in the pen drive port. So without this dongle, we cannot operate. We cannot utilize this DSpace. So like if you want to enter in a house, what we will do, we will open the key of our door. So then only we can able to enter into the house. So similarly, this dongle is very much important to operate to utilize this DSpace controller. So try to protect this dongle. This dongle costs itself 20,000 to 30,000 rupees. So without this dongle, the DSpace will be useless. And here we can provide the pulses to the inverter. In the D-space controller, we have IO ports, inputs output ports. So by using that ports, we can give the pulses to the inverter. As the inverter physically available outside, so the pulses can be given through the support of the D-space controller by using the master bit outputs. And we can also measure suppose if you want to measure the current or if you want to measure the speed, then we can measure by using the DAC channel ports. So in the DSpace 1104 there are 8 ADC channels, unlocked these digital ports are available, and 8 DAC ports are available. So you can measure the any quantities of signals, maybe current, voltage, that by using the DAC port we can measure, and which can be seen on the scope CRO. And these are the master bit out for the zoomed we have shown here, which are given to the inverter. And this is we can measure the signal which can be given to the CRO. And you can see the experimental setup result. This is the machine operated with the two-level inverter. Here you can see the current liquid content, how liquid contents are coming. So this is the CRO result we are seeing on the scope. And this is the PMSA motor coupled with the DC generator, and this is the DSpace 1104. These lights are blinking based on the pulses are transferred to the inverter. And here you can see the three-phase current result on the figure, and we can vary the speed from 150 rpm to minus 100 rpm. It means forward modeling to reversal modeling speed. So whenever the speed is changing, you can observe the huge ripple content. Once the speed settle to the reference speed, then the ripple contents are reducing, and you can see now the motor is running in the reversal operation, and again we brought from minus to plus forward modeling operation. So you can see the again it is coming 150 rpm, and these are the current result. All the things are we are showing at a time. That's why the camera movement is moving from result to this portion.
One doubt, sir. How to get the MATLAB into MATLAB? How to get the C code for the DSpace?
No, not C code, sir. Directly we are implementing all the parts. How we implement in the simulink, the same manner we implement. So no need of any C codes here. So whereas in the FPGA it is required, but here we don't require any C codes here.
Simply we want to give connection and
Plus,
want to
right.
connect
So
on the other side.
here that's why how you are familiar means for us it is this space is familiar. We don't require any codes. So in the FPGA we require codes. We need to convert this FPGA MATLAB into the Xilinx. So we need to create the codes.
Jaining.
Xilinx. Okay, so that is required for the FPGA. For here we don't require.
So just like a MATLAB, we want to design, again we want to design the same
Only.
same
Right.
system.
Mm.
And we want to connect them.
Mm.
That's all.
So which is interfacing with the D space. And this is with the demonstration of the three level inverter of 5 phase. Uh, and we will show you the zoom out a little bit later. Now it is operating at 200 rpm, and see the current levels are reducing a little bit as compared to previous, and the motor now is running at low speed. We are operating at low speed, and thus you can see now it is operating at 200 rpm. So now it is reduced to 150. So you can see these results are 200 rpm to 150, 150 to again 100. So under low speed operation, you can see there is a huge improvement because when the machine runs at low speed, then obviously we will get we will get the proper current output when the machine operating be at the low speed. And this is you can see how we descending order we have reduced the speed from 200 to 150, 150 to 100 like that. And again the speed is again pick up back to the forward motoring mode from 150 rpm to 200 rpm.
In CRO also we can observe that.
Yes,
Speed and
we can observe in the CRO, and for the better feasibility we are shown in the monitor also.
but normally the motor means it should be loaded by weights, normal weights.
Weight means
Springs
no.
before
See here the DC mode. Why we are using those stick to apply load on the machine on means mechanical load, which we are applying on the that pulley. Okay, so when we tight, then the load is applied indirectly on the machine. So what happens if you apply that? Suppose you want to apply 100%, 50% now, from 0 to 50% simultaneously. Then what happens? You have to rotate to up to get the from certain Newton meter. Those meters should show that 50% of range. So this load we are applying gradual. It will take some time to reach that one. So you want to measure the instantaneous result, then how can you get it? Because this is a continuous process, right? So if you want to measure this result, this will be gone, right? So that is the problem. So instantaneously we have to apply the load on the machine. Then and we need to see at that position what is the behavior of the current, what is the behavior of the speed, what is the behavior of the torque. That
to observe the transient
response.
transient response.
We need to have coupled motors. Hmm. So this kind of motor, that mechanical load is not feasible in such cases. For testing, it is okay, but to see the transient response, we cannot see from the mechanically coupled. And this is by using the pi level inverter, and you can see this result in the CRO. So here here you can see ripple content in the current are reduced as compared to the previous. We are mainly showing the current for viewer understanding purpose. So here you can see the ripple contents are less here. Now we are operating using the 5 level inverter. So 200 RPM to 100 RPM and 100 RPM to 50 RPM. So we tested the machine at various operating speed. So likewise, we tested the machine at different conditions, and we successfully implemented 2 level, 3 level, and then 5 level, and we have plotted the result of 2 level, 3 level, and then 5 level. You can see the torque ripple contents are gradually decreasing up to the 5 level, and this is the result under loading condition we have applied. See, when you are using the that mechanical coupled, see here I have applied a 50% loading. When it is 50% load is applied, then this transient response, the speed is little bit decreased. So when we throw a load on the machine, then what happens? That machine slows down little bit time, then start picking up. So now this is slow down and again pick up to back reference speed. So this is how this transient response we can measure when we are applying on the coupled motors. This is not possible in case of the mechanical load. And this is the other different speed operating 600 to 900, 900 to 1200. So by reducing the speed, we have measured the result. And this is also same case under different speed from 600 to 300 like that. And these are the line voltages of 2 level, 3 level, and then 5 level. So you can see the 5 level is a little bit sinusoidal compared to the nearer to the sinusoidal compared to 2 and 3 level. And now you can see the uh, while writing the paper, you have to keep it in mind that both the experimental results, simulation results, we have kept side by side for viewers understanding. So experimental way and simulation way, both the things we have kept side by side. So while writing the paper, these are the certain things you have to remember, so that there is a huge access, sanctioning, accepting rates will be more. Now here, while implementing the hardware setup, certain precautions we have to take. What are those precautions? The first precaution we need to take that all the feedback signals given to the ADC, and then the feedback signal which we are giving, the voltage signal should be plus or minus 10. Okay, we need to create a one gain. So that gain must supply, the gain output must be 10 volts maximum plus or minus. So if it is beyond 10 volts, then there is a chance of damaging the D space. The D space allowed range is maximum voltage range is plus or minus 10. The current will be the 100 milliamperes. If you are able to supply more than this, then there is a chance of burning the D space. So this point we need to take care first. Then second thing, while implementing the hardware setup, we have to care if you are measuring the two signals or three signals at a time. So suppose one signal is 2 volt you are measuring and per unit, and the another signal you are measuring 8 volt per unit. So when you are measuring two different quantities, different ranges, then the two port point should be individual. Okay, if you common the both the ground common, then what happens? There will be a circulating current passes between the two ports, because here we are measuring the 8 volt, here we are measuring the 2 volt, and thereby it damages the CR. Okay, so while taking the result, you need to be cautious. The ground should be individual, should not be made common. So likewise, certain guidelines we need to follow, and we must connect the auto transformer or isolation transformer for while doing the while applying the voltages.
So one doubt, sir. How to estimate that limit the voltage by using resistance and capacitor by using that current?
Where
Here,
here
yes, sir, in practical.
in practical, here in the Simulink only, we will create a block. So this is the block we are measuring, and here there is a DAC ports are available. So in the DAC port we will create a one gain, and that gain will give us a signal 1 by 1500.
1 volt.
1 volt only it will give. Okay, so this gain we need to create. If you don't create this gain, then it will supply a whatever voltage we measure from the machine. So this is how we can create the gain. So like simulation, we are creating the gain. And then as in this machine we use the speed sensor. Uh, so here there is a part of a tacho generator. So if some obstacle comes between the tacho generator and the shaft, then this tacho generator gives a false reading. Thereby, we will not get the accurate performance which we are really needed. So that is a one drawback. And another thing is we need to keep means we will add it in the cost of this taco generator also. This take some amount, so which is another drawback of this method. So instead of measuring the speed, it will be better to estimate the speed. Thereby, we can reduce the experimentation cost. At the same time, we can get the accurate result also. So accurate results also we can get it. So now what we have done, we have made speed estimation methods. There are different speed estimation methods are available in the literature. Our main focus is to reduce the drawback of the speed censored drive. So now we implemented the sensorless method. These are the certain drawbacks. So of course maintenance also requires, because we need to clean that speed sensor to remove any obstacle between the sensor and the shock. So because of these all disadvantage, we have estimated the speed instead of measuring. So in the literature, there are different types of speed estimation methods are available in the literature. The first one is the observer time. So observer time, again there are subdivided into extended Kalman filter, extended Luenberger observer, and sliding mode observer. So these methods are having its each method having its own advantage and the disadvantage. Basically, the extended Kalman filter is a huge mathematical complexity having this in this method, and the sliding mode observer is required a charting phenomena. We need to tune the one parameter of beta in the sliding observer. So there will be huge charting effects, phenomena effects will be there using the sliding mode observer. So what we feel, model reference adaptive system is the one of the best speed estimation method for AC drives. So again, in that there are different types of speed estimation methods are there: stator current, back EMF, and the reactive power. So this method also certain drawbacks are available. So especially for the back EMF, it create problem with low speed. When the machine is running the less than the 100 RPM speed, then it creates a problem. Which it will not estimate the result accurately. It gives a huge noises, and reactive power is having a instability, means during the low speed operation it will vibrate the machine. So this is also not accurate method to estimate the speed accurately. So we have followed the stator current, so which gives the proper result in all the circumstances majorly.
So, for doubts, reactive power normally reactive power.
No, not that. Means that base speed is, that is a completely block diagram. It is there. So based on the IQ and ID, we may estimate the speed. Okay, so that is there in the literature. So here, this is the part. Generally, what we do, we measure the speed from the PMSM motor by using the encoder. Now you can see that this encoder part is eliminated from the block diagram, and instead we are measuring, we are estimating the speed of the motor by using the quantities which you have measured. So here we are using the two current sensors. By using these two current sensors, we can measure the two phase currents, and we can get the third phase current by making the IA plus IB plus IC is equal to 0. And then in addition to the currents, we also need a voltage quantities. So instead of using two voltage sensor, now we are using only one voltage sensor. By using that one voltage sensor, we are measuring the DC voltage, and here we were having a SA, SB, SC pulses. Those pulses we can utilize for calculating. This is also again mathematical equation based. So by using the mathematical equation, we can calculate the VA, VB, VC, and by using the clock transformation, we can transform three-phase quantities into the two-phase quantities. Okay, so this is voltage we are calculating by using mathematical expression only. That is easy. So here speed is estimated using the voltage and current quantities. Now here in the speed estimation there are three blocks, major blocks are available. One is the reference model, another one is the adaptive model, and third one is the adaptation mechanism. So in the reference model is independent of the estimated speed. So here this reference model we can model easily by using the mathematical modeling of the induction motor. So I'll show you that one also. So here we can model this reference model by using this mathematical equation. So we know the information of omega, we know the information of RS, LQ, everything. All this data we have, and VDS and VQS we just calculated by from the VA, VB, VC. So all this information we have, this is just by using the mathematical model, we can create a block of the reference model. At the same time, we can also create a estimation block and adaptation mechanism. So that is this block. So this simple block we can create in the MATLAB.
Sorry, that adapting. So it's just like a decoupling controller. Where are you part of
This one,
control that adapting?
this is adaptation mechanism is similar to the it will give you the for behave it will behave like a one PI controller. Okay, so here we have a KB plus KI by S. So it will behave this performance gave us a like kind of a PI controller.
It is Thailand and method came.
Here we have used the heater dial method only. We have not used especially for speed estimation purpose. And here we have estimated the speed. You can see here there are two speeds are available in this line. So NA is the actual speed, and the NR is the reference speed, and NE is the estimated speed. These points are not visible. So, but here there are three lines are there. Here in this one black line and one orange line, pink line, there, and this is the reference line. So here the black line, this line is accurate tracking the reference speed. Okay, so the point is that the estimated speed is tracking actual speed accurately. So this method estimating the speed accurately. So we also tested for all the three levels, that is 2 level, 3 level, and the 5 level. As we have written the paper for on the 5 level, so we thought of comparing all this level whether we are achieving, we are estimating properly in the 2 level by using a 3 level or not. We have seen, but we have measured all the aspects. So here we found the less ripple content, and here will be little bit more ripple content. And this is under loading condition, and this is how we implemented speed sensorless technique also. And here I thought of giving certain guidance, certain suggestions for a scholar, that means for a MTech participants who are having with MTech degree and aspiring for the PhDs, higher studies. And also there are participants from the faculty members, many faculties are attending. So it will be helpful for them to in drafting of the research proposal, or there are faculties are with master degree, so they are aspiring to completing the doing the PhD. So for them, I thought of giving certain suggestions. So for which I have taken certain slides. So that is how to write a research proposal who are aspiration of doing higher studies, or how to write a project proposal like SERP and etc. So here certain steps we need to see. The first step. So here the first step is creation of the title. The title of the project should be, the title of the research proposal should be attractive. So the title we have given here, the 5 level inverter fed director control with specific term violation for permanent magnet synchronous motor drive. So this title we have given in a crisp manner and in a attractive manner. So whenever we see some object, whenever we see, the first impression is the best impression, we always say. So here the title we need to design accurately, and in a attractive manner we need to design the title. So this is the, so key component of successful research proposal is, first is the title of the proposal. So we need to take care while framing the title of the proposal. Then next one is the literature review and the research gap. So literature review up to 2024 we need to see in two ways. Literature review in two aspects. One is the national, second one is the international. So in the national means in India, who are doing in this area. So up to 2024, all the papers need to be cited, and then international means in any country in the same area who are working, we need to give the both international and national. From the literature review, we need to identify the research gap and we need to propose the objectives and the research objectives and research methodologies. So whatever objectives you are proposing, those objectives should be relevant to the current trend and the upcoming generation and the tentative timeline. So you have to give Gantt chart for the every 3 months or every 6 months what you will do in these 3 months or 6 months. And likewise, if it is a 3 years call, then we need to design for the 3 years. If it is a 4 years, then we need to design accordingly. So timeline.
One doubt, sir. How to give the literature review on foreign countries?
In the literature, there are two columns will be there: national review, international review. So in the national review, who are published in the India, you need to give their, you need to cite their papers. And international, you can avoid the Indians who have done, and you can cite only their papers, their methodology, who have done the work in certain areas, and then you can conclude. So as these matters are having a research gap, so uh, the objective which I am proposing will fulfill that gap. So that you need to mention that one. So here these are the certain few titles. As I said, title of the proposal is very important. So this is the one of the title means a few titles may which may helpful for you while drafting. So the first title you can see design and development of multifunctional PV battery based smart charging stations for EVs, electric vehicles, and household and grid applications. So see how the beautiful the title is. So this fellow conveying the his message that he is going to design one PV battery based smart charging station. He is going to design PV battery based smart charging station for electric vehicle application and household load applications. So he is developing and designing also. Okay, so majority of the objectives we will find from the title itself. So your title should be in a manner, crisp manner and attractive manner. Okay, the first impression is the so I'll get the certain impression from by seeing the title. Okay, so likewise, I have taken one of the project. This is my one project. So design and development of multi-level inverter fed multi-phase sensorless PMSM drive for electric vehicle application with reduced torque and flux ripple. So I'll implement the multi-level inverter for multi-phase drive. It is for proposing for the electric vehicle application which are booming now in the current trend, and I'll reduce the torque ripple and the flux ripple for smooth operation. So I'll design and develop. So these are the top. This is the name we need to assign in a proper manner. This is another project sanctioned design and development of multi-input, multi-output power converter. So he will design a power converter with multi-input and multi-output. So these are the objectives means a person can see what are the objectives there in the research proposal by seeing the title and importance of the project proposal in the context of the current status. So see now electric vehicle mandate is going on. So after 10 years, if you talk about electric vehicle, then useless. Okay, so what is going to happen after 5 years and what is going on now? If you talk those applications, then it will be really useful. So 10 years back work has already completed and will all be implemented. Then if you talk about those things, then nobody is going to care. Okay, so the project proposal should be in terms of the current context are the future purpose. So likewise, we need to choose the objectives. And second thing, suppose you are writing a project proposal. You are imagining, okay, if this objective is there and I'll get this result. But you are not having with any supporting data. You are just in a hallucination that I'll get the result if I do like this. I'll get the result. But how can I believe whether you will get or not? How can I believe? This is a 3 year project. So you are with the idea only. You have not implemented it. So a reviewer will get a positive opinion on you by seeing the supporting data which you have provided. So I have written a project, implementation of multi-level inverter FET, multi-phase PMSM drive for electric vehicle application. What I conveyed the reviewer that initially I'll implement the 3 level inverter, then 5 level inverter, and then sensorless drive. Then I will make the hardware implementation. So to convey you in a better manner, I have already implemented the 3 level inverter. The multi-phase, this is a multi-phase, 5 phase PMSL drive, 5 phase currents, IA, IB, IC, ID and IF. So I have implemented the simulation of 3 level, 5 phase and 2 level. And I have given the supported data with publication of conference and simulation result. Then that fellow have a positive opinion on us that this candidate already started his work and provided a result with a simulation work, and if we support with the project, then definitely there is a high chances of completion. So this positive impact we need to provide, so we will get a positive result in this way. So give a simulation result, we start the work, start implementing, then produce certain result with the this like this, then a reviewer will get a positive opinion on it.
Sir, for particular project, we need to upload such kind of simulation results.
Huh?
Is there any need?
Yes. See, I cannot say I cannot say need. I always say needed. Why? Because why should I trust you? Why should I believe you? After sanctioning a project, you may feel the difficulty and you may not able to implement it because you have not started it. If you have started, then by that time you could have faced the difficulty in that implementation. So, as you are producing the supporting result up to 3 level, it means the difficulty which you are facing might be resolved little bit. And in future, while implementing the 5 level, whatever the difficulty you are going to get, maybe definitely you solve those difficulties. As you are already experienced in this area, because we provided with a certain simulation result. Okay, then that person will believe us. So we need to bring him in our track. Okay, so he always think if I sanction the project, whether he will able to implement or not. Yes, that person able to implement because he is already having the supported data. Okay, so this is the way we need to write the project proposal. You can give the simulation result, not only simulation result. So here this project I have already implemented and submitted the closing report. Now I have written another project and I am saying that I am already having a hardware implementation exposure. So this is a 3 phase PMSM motor. I have a multi-level inverter fed PMSM motor. I have successfully completed this project. And if you sanction me the another project which I have written on the 5 phase PMSM motor. So by highlighting the drawback of the 3 phase PMSM motor, the drawback is one of the phase is faulted or open circuited or short circuited. Then we cannot get the accurate result because with the 2 phases we cannot get the accurate revolving magnetic field.
Thereby, we cannot generate the proper torque and we cannot get the proper result. But if I go for the five phase, if one of the phase is faulted, I can run the machine at least with three phases and four phases. Okay, so those are my justifications. And the five phase machines are really helpful for the heavy duty vehicles, trucks, buses. Okay, as they are giving the high power ratings. Okay, and if one of the phase is faulted, then at least they can travel to certain distance to reach the repair station. If two phases means in the three phases, if one of the phase is faulted, then it is difficult to bring that machine up to the repair station. So these are my claims, and I have supported with the simulation, and then I'm conveying the reviewer that I have already had a exposure of hardware implementation in the relevant field with the supporting hardware picture.
Doubt, sir. In single phase induction, if you get a single phase supply, it does not produce the rotating magnetic flux. It is a pulsating magnetic flux only.
Auxiliary winding we are providing.
Auxiliary winding, or it does for twist in one direction, regular single phase supply, it will rotate in the direction only. So in the PMSM, one phase is failed, means it's the single phase only, simple single phase.
What is the efficiency of the single phase induction motor?
Efficiency is less, sir.
So I'm talking about the efficiency only.
Operation part.
Operation point. See, will rotate. I'm not saying that it will stop there itself, but I need a efficiency. See, this three phase PMS motor or three phase induction motor utilized by the industry. Industry always needed a good efficiency. Then only they will get the profit. So if you operate at 50% efficiency, will they get the means huge wastage of power happening? Will they get the profit? So I am proposing for the industry. So the single phase, see, in two phases it will run, but loss.
Loss will be more.
So that is the thing. So these are the my claims. So I am supporting with simulation result and supporting with the hardware exposure also in relevant to the what I am proposing. Okay, if it is not relevant, then need not to give the hardware.
And this is the Gantt chart we need to provide for in a proper way. First 6 months, I'll start the initiation of purchases and the SRF and recruiting, and then literature review of remaining works, and the next 6 months what he will do, then next year what he will do. We need to provide in a proper way. Okay, so people will take lightly, no one going to see this one, but we need to give comment on whether the candidate has given the Gantt chart every 6 months, whether in a proper way or not. So whenever a project goes on a review, there are subdomains. In each domain, we need to write a 500 words. So what if we don't write 500 words, it will not go further. So what we can write a 500 words? We will write, see, this person has conveyed for 6 months he will do this work. Next 6 months he will do that. So these are categorized in a proper manner. Like that we will comment. And budget. As I was saying while having lunch, asking too much, asking too less is not good. So we need to ask always what is means appropriate. So we can ask if pen cost is 10 rupees, we can ask 11 rupees, or you can ask a 9 rupees. It doesn't mean that you should not ask 15 rupees or you should not ask 5 rupees also. Okay, so in the budget also we need to write a 500 words whether the candidate has proposed the budget justification in a proper way or not. Okay, so budget, give the budget with a proper justification. And then the research team is one of the important points. So see, being a human being, we will stuck somewhere. Okay, so when we stuck somewhere, then somebody should be there to bring bring us from out of that stuck. So who are there with you? So it's a human nature. Anybody can stuck any point of time. So somebody there to bring out of that point.
So who are there along with you? So you present their name, their area of interest, and their experience. See, 100 people are there, but expertise is required, right? So along with you, there are in Facebook there are thousands of friends, but nobody is there to talk when you are not feeling well, right? So, so, so somebody who are there with you, who can help you during the difficulty periods. So you need to give their details in a proper manner. So in your institute or nearby institute, you can give their name, but you just inform them like I am taking your name in this proposal. So if project sanction, if I am stuck somewhere, then I'll take your support. And while writing the paper, I'll give your name or I'll acknowledge your name in the somewhere in the project. So definitely those person will accept. And see, these people will not send any email whether you are going to help or not. But there may be a chance. Suppose this project proposal went to the review for knowing persons. I know JAYABABU sir. Okay, you have sent a project proposal and you have kept his name. Okay, but there is a virus between you and him, and he might write whether you have given a consent to help him. Then he'll say no. Then what I'll do? I'll write the candidate is given unnecessary names, means he is not taking any consent like that. So there is a chance, because where it will go for review we don't know, right? But once you inform the candidate, that's good. Okay, so these things happened already. So few cases it is already happened. Okay, so if you are keeping someone names, if you are taking someone data, just highlight it. No problem. Okay, cite it, highlight it. Okay, so this is the research team. Better give research team uh, the faculties in the your institute or nearby institute or any people from the NITs or IITs, but inform them in prior. And research team expertise and your last 5 years publications. So project will not accept like that. So they will see the last 5 years data also, whether you have published anything under corresponding proposals, relevant proposals. They will see last 5 years. Okay, we need to write a while reviewing. We need to write a 500 words. Whether what is the calibrations of the candidate, whether he has any publication for the last 5 years or not. So this.
The papers are related to working ability or there
See, if you are working in the dry, need not to be on PM vessel. It can be an induction motor. It can be an BLDC motor. If you are writing papers, proposal on converters, so need not to be exactly any particular converter. So converter, any type of converters.
So, one more, sir. You, okay, you accepted my proposal, sir. But at the time, I have not reached the pitch of the sanction. Then how can we finish?
Then you will not get a closure report until you will submit a final proposal. Then only you will get a NOC, means your project is successfully completed and there is no means dependency. Okay, so they will give a clean sheet. This person is successfully completed the project. And while reviewing the next project, when you submit the next project, then they will see what is the conduct of this faculty. He is always writing hundreds of proposal. After sanctioning the proposal, he is not submitting the resultant. He is not submitting the closure report. The depression will be there because everything is online nowadays, right?
Sir, time is not sufficient. Then they will extend mission. So,
Maximum 6 months. So these are the certain calls. Name this is data I have taken 23, but now everything is related, named Anusandhan or Prime Minister something. But name CRG and EMEQ, everything same, but some Anusandhan name is added. So these are the certain calls.
self, you can go to the self website, you can find all this. And
Sir, if the proposal or complete project, so we are designing or developing for a small scale, for example. So it is not suitable for the large scale, large scale. So if that kind of proposals are accepted by universities.
yeah, it is accepting. See, they will not say, means they will always not means take a consent of whether you are going to implement for the large scale or small scale. So they will always see what are your objectives, whether it will helpful for the current status or not. Whether it is going for the large scale or small scale, not that much impact. So even small scale also they are accepting. There are many proposals are there. Hmm.
Suppose if you want to write a project for education institutes, so the like for example you have a charging. So suppose the students or faculty may use in future 2 3 4 years all electrical vehicles. So suppose if you write a proposal charging station for education institutes like that.
Yeah, means how best way you are creating that charging facilities. See, assembling, you will purchase battery from one place, solar panel from one place, and you are just assembling. It doesn't mean you will granted a project. But how best way means whether you are utilizing the batteries are less or you are charging means this solar panel power, how best way you are extracting by using the controllers. Okay, so what is your new
The PV can purchase, but the technology is
something new?
something.
Ah, so what is the objective?
Whatever existing is there, you
Ah,
can
so anybody can do that one. But what is the new? No, so whatever in any area, what is the novelty? That's why they are asking literature review, right? What is the gap? Literature gap they are asking. Okay, so national and international review. Not only see in India, Indian people not done. That mean doesn't mean that in the entire world nobody is done. So that's why we need to see international, national, both the reviews we need to give. Okay, so in USA they have implemented. In India, I will implement. Give me a project. No, they will not give. Okay,
So there also they want to see, we have to see that one.
novelty. So this is the generally they see these are the points they will see while reviewing the project proposals. So they have to comment. So merit and impact of the research proposal. They have to write 200 characters. Merit and impact of the research proposals. So they will read and they will write the 200 characters. This proposal is good and as per the standards. And comment on innovation and the impact of the proposal activity. So what is innovation? Novelty. Then we need to write minimum of 200 characters. And then research, expertise of the researchers and collaborators. As I was saying just. So is anyone there with you to support you while implementing this project? And to what extent does the PI provide evidence of the creative thinking?
Sir, if the supporters are some far away from this college, for
Doesn't
example.
matter. Nowadays everything is online. See, that person will be in Google Meet. He will see the experimentation and step by step, and somewhere he will might be making the fault. So that fault he can able to convey you by seeing the over desktop and laptop by through Google Meet. So nowadays everything is online.
No, no restriction.
These are the things they will see while reviewing. Would PI develop new capacity with the project detail comments? So we need to give all these points while reviewing the project and resources and budget. So whether the consumables what we ask are appropriate, are too much or too less. At the same time, equipment cost is appropriate or too much or too less. So these are the comments we need to write, and then at the end we will recommend the project is excellent or medium or low. Rating will be given based on this. If project is being sent to two or three people, if three people gives excellence, then huge chances. If two give excellence and one is in, then there is a chances are high, but we cannot say exactly. If only one is excellent, then rare chances.
That's the case.
Hmm. So the research proposal why they fail because people are not giving objectives in a proper manner. They are not writing titles and with justified data, and they don't have any publication for the past 5 years. This just ideally. So like that means how can a person believe? That is the matter. So if you provide a supporting data, then definitely the selection rate is high. Similarly, what student is approaching for the higher studies. Nowadays, we are seeing the students like, see, some student is approaching for the part-time PhD or full-time PhD. They are coming with nothing. So, in which area you will do? I will do the research in the cauldrons. Cauldrons means what? Cauldrons is a ocean. It's a broad area. In the cauldrons, what you will do? Some people say, I will do the drives. Drives, the lots of research has been done. What you will do? Then, sir, I have simulated this material innovative drives, and I have a hardware exposure of just implementation of the pulses. No need of hardware experimentation, everything. I know how to give the produce the pulses from the controller. Otherwise, the learning itself takes the 1 year, 2 years time. Then when you will start doing the conventional thing, when you will do the new things and when you implement it. So nowadays people are expecting come with the at least 50% of the work. Then remaining 50% you can do after joining. Okay, so you need to go with the objectives. People are expecting that to take the better candidates. Otherwise, you will not be selected. So these are the focus areas. If someone is working in the drives, they can focus. And so here, as here we are using the cascaded PI controller, and the modeling is required for this method, DTC with space vector modulation. And we can go for the model PDU controllers. There we don't require any cascaded PI blocks. So this is one of the research topic. If somebody is working, so they can choose this is one of the research topic. And there is another research topic. Basically, this is the conventional PMSM drive or DTS based PMSM drive. So here there is a PI controller. This PI controller can be replaced with the machine learning. The machine learning techniques can be applied to the drive applications also. Up to the 2020, people might be thinking machine learning for only the computer science. But now the machine learning is entering into all the branches. It is not limited, no longer limited to the CSE. Okay, so machine learning is adapted by other engineering stream also, and future is no longer restricted to only 3 phases. So people are working on going to work on the 5 phases, 6 phases also. So this is one of the research topic you can work on. And then we can also see the model free. So up to now what we are talking, all those controllers are required a model. Mathematical modeling we all require, but we can go for the model free. So we don't require any modeling equations also. That way also we can design one of the Scala is working model free controller of PMSM drive. So this is one of the research topic, and these are the people are thinking might be thinking the electric vehicles are with all three phases. No, six phases are there, five phases also there in the market. So already available in the market. Okay. So I think I'll stop here.
20 minutes.
15. Okay. And these are the advanced research areas, and you can think about one is DTC with the PMS based, uh, and then the speed sensorless technique also you can work on it, and one more is the deadbeat predictive control of PMSM drive, you can work on it, and the model free control of the PMSM drive, and muscle learning based PMSM drive you can think about. So as of now, we were estimating the speed of the motor. So now there is a when you operate the machine. So when you operate the machine entire day, what happens? The stator resistance keeps on increases. When the stator resistance keeps on increases, then we will get the faulty outputs. So in order to get the proper result, so we are just now we estimated the speed in so we can also estimate the stator resistance in parallel with the speed. So here what we are doing, what is the need of estimating the stator resistance in the drive applications. So just now I conveyed that if you operate entire day, then the winding will be heated up. When the winding is heated up, then stator resistance value will be keeps on increases. When the stator resistance value increases, then the voltage drop keeps on increases, then we will reduces the stator flux linkages. So when the stator flux linkages reduces, then we will get the we will get the reduced output. So in order to avoid this difficulty, we need to estimate the stator resistance also in parallel with the speed estimation. So here we have proposed one method. So in that method, what we have done, we have estimated the speed in parallel to the stator resistance. So here we estimated the stator resistance in parallel to the speed estimation. So how we estimated the stator resistance? We estimated the stator resistance. How we are estimating the speed of the drive? The speed of the drive we are estimating by using the voltage and the current quantities. So which are measured quantities? By using voltage sensor and current sensors, we are measured the voltage and current quantities. And then we are estimating the speed of the motor. Similar way, we can also estimate the stator resistance. So now we can see the block diagram of the stator resistance. So here we will have a reference model, adaptive model, and then this is the adaptation mechanism. So here the reference model we can model by using the mathematical equation of the PMSM motor. So there the reference you can see VDS and VQS and the IDS, IQS. These are the measured quantities. So by utilizing these quantities, we can model this reference model and adaptive model also. This is the mathematical equation. I'll show you in the next slide. No. Okay, similar to the sensorless PMS drive only, this mathematical equation. I think these are the skipped mathematical equations. So this is that block diagram. By using this block diagram, we can also estimate the stator resistance. So by estimating the stator resistance, we can accurately control the speed of the drive. We can see, so here we are estimating the stator resistance. So, so these three cases, two level inverter, three level inverter, and then five level inverter. So if you don't estimate the stator resistance, so if you operate entire day, then you will get the distorted output. So we could have provided that result also, but in the publication it is there. On our name, you can find the parallel operation of the speed estimation and stator resistance estimation in the Google, and you can find that paper. So there we have produced that result also. I think it is missed here.
So if you don't estimate the state of resistance properly, then what will be going to happen? So that we have given, and this is the result under loading condition. So 2-level inverter, 3-level inverter, and then 5-level inverter. So we are getting the better result by using the 5-level inverter compared to the 2 and 3-level inverter. So now, so far we were utilizing the PI controller. See, here we are using the speed controller has PI. Instead of using the PI controller, we can also utilize the fuzzy logic controller. So what is the advantage of the disadvantage of the PI controller? We were using the PI controller, there we need to tune the KP, KI values. So when we are tuning the KP, KI values in a particular speed, the reference speed we are giving maybe 200 RPM, and we are doing the KP, KI value. Or at 200 RPM, we are applying the load on the machine is 50%. At that time, we are tuning the KPK value. Now, after a certain time, we are applying the 80% load. When we are applying the 80% load, what happens? This KPK values will change because its transfer function also changes. When transfer function changes, this KPK values also changes. So, to avoid this problem, in the literature we will find, so instead of the PI controller, we can go for the automation techniques or fuzzy, means artificial intelligence techniques like fuzzy logic controller and neural network controller. So initially what we have done, we have replaced this PI controller with fuzzy logic controller. Okay, so in the fuzzy logic controller there is a the different rules we can create based on the inputs we are receiving from the source. So there is a reference speed, and actual speed is fed from the encoder. The error speed is fed to the controller. So now, while implementing the fuzzy logic controller, we will take one error, that is the difference between these two, that is error, and we will take another input, two input, one output, we will take it. So the second input will be the change in input. So some delay we will apply. After the some delay, so another input will be there. So likewise, we will take the two input, and the output will be the error reduced output. So that is the type of fuzzy logic controller we have implemented. So similarly here also we have a two inner PI controller. There also we can apply the fuzzy logic controller, because here also there is a chance of similarly when we are changing the reference speed or load on the machine, then these gain values also changes. So there also we can implement the fuzzy logic controller. Then how can we implement the fuzzy logic controller? So there are two inputs. One is the, so one input is the error, that is the reference speed minus measured speed. Then the another input will be the change in error. Just d by dt delay we will apply. So there are two inputs we will apply. So this is that schematic diagram. This is error and this is the change in error, which applies to the fuzzy logic controller. So in the fuzzy logic controller, there are different blocks are available. So the first block is the fuzzifier. What is the use of the falsifier? So here we are providing the inputs, the, error and changing error in terms of the crisp value. So the falsifier activates the linguistic rules and gives the fuzzy sets from the crisp values. And then here there are two another blocks, that is interference and then rule base. The interference, what it will do, it determines the how rules are activated. So which kind of rule is activated, and it will combine the it. And here rule base is whether you are taking 5 by 5, 3 by 3, 9 by 9, 7 by 7. Which one is feasible? You will take it based on your application. Then here rule base will be there based on the inputs receiving. So that will be activated. And what is the use of the defalsifier? So here input we are providing in terms of crisp, one particular value we are providing. So the output also in the same manner we need to receive. So the defalsifier will do transform these fuzzy sets into the crisp value. So that's why name itself defalsifier. Here is the falsifier, it is a defalsifier. So it will transform the fuzzy sets into the crisp value. So provide the crisp value.
So this is the how the fuzzy logic controller acts. So now uh, there are two errors we were having. That is one error, another one is changing error. The difference we will get into the control unit, and we will write a logic. If you are taking here, we have taken 7 by 7. Then 7 7 there are 49 rules will be written. Okay. How we are writing those 49 rules? If error is big, change in error is small, then what should be your output? Both the errors are big, then what should be your? So these are the properties in that manner only. We will write all the cases. So it doesn't mean that all the diagonal gets a zero. So it need not to be all the in the diagonal way you will get zero. Need not. It's up to what best you can give the logic. Okay, so this logic we will create, and in the rule base we will write that logic. Okay, so this is error, this is change in error, and this is the output. If my error is like this, if my change in error is like this, I need an output like this. So there are more probabilities are there, but it is not there. It is not feasible in case of the PI controller because KPK values we were giving fixed value. But here, based on the input what we are receiving, the output changes according to because different positions are available. So that is the beauty of the fuzzy logic controller. And this is about the type 1 fuzzy logic controller. You can search in the Google, you will find the interval type 2 fuzzy logic controller. So this is another method type 2 fuzzy logic controller. So what is the advantage of the type 2 fuzzy logic controller is that here the fuzzy within the fuzzy, what we call, so at particular I'll tell you in the next slide. So here there is a huge advantage by going the type 2 fuzzy logic controller instead of the type 1 fuzzy logic controller, because in the defuzzy where there is a another term we will have a time reducer. So it will give the better performance as compared to the type 1 fuzzy logic controller. So there are good transactions available in the literature. You can see this one. So here I can explain in a better manner between the difference between type 1 and then type 2. Suppose at particular point x dash point, if I take a vertical line, then it will cut this point. Then we will get a crisp value of x. Some crisp value we will get it. So in a similar manner, this is the type 2 fuzzy logic controller. Fuzzy within the fuzzy we generally call it. So the bandwidth will be here. There are numerous fuzzy means such kind of triangles are there. Numerous triangles are there in the type 2 fuzzy logic controller. So at x point, similarly how you are cutting at x point, here also in the x dash point, if you draw a straight line, vertical line, then you will get this point. So here you are getting a crisp value, a single crisp value, but here you will get a again fuzzy. It means zero point 0.4 to zero point 0.6. So it will say fuzzy within the fuzzy. Okay, so this is the beauty of the type 2 fuzzy logic controller. There are lots of fuzzy sets are available within the type reducer. So this is where we can further enhance the performance of the fuzzy logic control as compared to the single means type 1 fuzzy logic controller. Okay, so that is the beauty of type 2. And this is the same. So as I was saying, the number of fuzzy sets are available within the fuzzy. Okay, so if you cut at particular point, then you will find these values fuzzy within the.
So what is the effect of fuzzy type 2 set, type 2 fuzzy?
Effect means see we can get the uh, means majority means even though at worst case also we will get the output. Like in the type 1, what happens, whatever the probabilities we are giving, it may miss. But here there is a chance to cover those probabilities also. Okay.
So is there any reduction in THD? Is there any reduction?
Obviously, means I'll show you the result. So there is a better result we got from the T1. So
This is also we have taken the 7 by 7 only. So to compare both the things side by side, same rule base we have taken. And see here we have taken the result of type 1 and type 2. So there is a small reduction. So not a more, but small reduction in the type 1 and the type 2. So there is a little bit advantage is there while implementing the type 2.
But in MATLAB, type 2 is not there.
In the MATLAB, type 2 is not there. We need to purchase that license. So then we will get the code, we will get the file, then that file we need to install in the MATLAB. Then only it will work.
What is the cost of that?
It depends. Means whether it is going for the government organization or it is going to a private college. Recently, by spending 8,000 rupees, one of student purchased the book. So with that book, they have given one license.
Okay.
Okay, it depends.
So
Okay.
IIT Roorkee, they are working, they are developing. So, you know that one.
That's right. So it depends. So how they are getting that C codes, that codes they are getting. Okay. So not only that, we have also implemented the reduced switch type 5 level inverter. So how it is implemented? So this is the basic to implement the 5 level inverter. We need to have for each leg we need to have 8 semiconductor devices. Okay, but here we could able to implement by using only 5 semiconductor device per leg. Okay, so in this also 5, in this also 5. So this is the type is called it as a reduced switch type. So this is the one type, but this method having the drawback of means in all the cases it may not work properly.
In drives application, is it applicable?
Means why it is not properly means see this is the circuit isolated, this is isolated, and this is also isolated.
Cascade.
Even though if you go for the cascaded edge bridge type, we require 8 because each edge bridge will give you the 3 level, then added one will give you the 2. So for 2 edge bridge will get the 5 level. So there also we need 8 switches. So here we can implement by using the 5 switches. The only thing is again isolated. These resources are required. And this is the diagram.
So what is about the voltage stressor? Is it VS?
No, stress across the switch definitely it will stress across this switch keeps on increases. This is the switch is acting more. So stress across this switch will be increases.
So what is about the common node voltage?
Here nothing, nothing is there.
Capacitors are there.
Where? Zero one means only one capacitor act at a time. Not both the will not act. So I think the diagram is there. So direction you can see. So this is the when we get the half VDC and when you can get the zero and this is the direction of the current when we get the negative half. So this is a switch getting huge stress in all the cases. And this is the simulation result we have implemented in 3 level and 5 level. And THD, it is again coming not visible exactly. That is 4.39. This is 1.8 or something, not visible exactly. And so here it is visible. 1.4. And these are those code I was saying the means how we have calculated those. So and these things. So how we have achieved beta is equal to 3 times of alpha minus k2 dash. solving this mathematical equation, we could able to got this equation. And then because all these things explanation in the PPT is not possible, so direct equations we were giving, and this is also. And if somebody really working in this area and for their feasibility purpose, we provide this mathematical equations. Okay, generally people are not sharing these designs. Okay, so
It is very useful, sir. Why? Because
and okay, this is again how we have implemented the solar tree and how we fed to the BLDC motor. And
now
why
solar T is applied to VLDC motor.
BLDC motor. So for the proposing of the water pumping applications. And initially we thought of writing one project for the villages. There are certain villages in the Andhra Pradesh, like especially Srikakulam and few districts of the East Godavari, in the
Remote areas.
remote areas. There still power is not available as on date. Tribal areas, as on date, still power is not available. So we thought of installing one PV tree in one road one thing, and in another road another thing another, so that at least in the night duration, night time, they can have power, or they can charge their mobiles during night times. Okay, some majorly they experience the snake biting or some other things in the night time. So maybe the solar trees are maybe feasible for them, we thought, and we calculated the load for a small household, how much lights and switches are required. So we calculated all these things, and how many bulbs and TV, how much it takes the power and fan. So likewise, we thought, and how much it takes the day in a day, and we proposed that 960 watt, and easily we can able to install that in a tribal areas. But I could not able to take it further because we needed local support. So in the tribal area, there is a project we can um, Science and Technology Innovation Hub for the scheduled caste or scheduled tribe development. So in that project, I thought to write this project, but what we need a data. Data means how many tribals are there, then what is their livelihood, and how they are earning, then all these things data we required, and their some other cards and all these things are required, and one active person is required who works after sanctioning the project. So we need all this support from the locals. So that I could not able to bring those things because nobody is there to support. But this is one of the way to get the projects. Or there are certain colleges writing project with the same STI, STI for SC ST development. You can search in the Google. So there is a one project, they develop the RO water and they supply to the village. So that is one of the simple project they have written, and they got the 1 crore rupee. So this kind of project also they can get it, but and they have one project they have written on the drainage. So smart drainage. How can they clean the drainage in a smarter way? In the villages, generally nobody care about the drainage. So how can they clean the drainages smarter way? So like this, there are certain projects. Okay, you can see that kind of project. Sanction rates are huge, but we need a data. So that village data, and who can work further later on. Okay.
So, is it possible to do that kind of analysis nearby towns?
Huh?
Village Vadlamudi is there.
Support, yeah. You see, you need to develop some area. Area means 80% population are belongs to the community. Okay, so you can develop anywhere.
he has written a project to develop water pumping system in the some Srikakulam area somewhere in the tribal area. Okay, so through the solar only. So they got the some 60 lakh or 70 lakh project. Okay, say they are designing some converter. So new converter they are designing to reduce the design concept. Okay, so there is a possible, but they want to implement in the community area only. 80% of the population should be community, 70 to 80%.
Sir, that particular area, suppose one project is implemented. Suppose if you provide the another method to improve the livelihood of that particular area. So these kind of proposals are accepted.
Yes. See, for above, for some example, in the Banjara community, Banjara ladies, you might be seen, there are some, yes, they wear the some kind of different, you might be seen, what we call some,
Mirrors.
okay. So now it is moving towards the fashion. Earlier it's their
Tradition.
tradition, particular tradition, but now it is going towards the fashion. Then what best way you can design by using the technology. So one of my friend from the Central University of Haryana, he has written a project by worth of 1.6 crore. So they are designing that traditional items. So there are huge chances in all aspects. So how you are taking it matters. Okay. So you can train the 10 members. Then with the training, they can do their household things. Okay. They can enhance their livelihood, right? So there are certain calls we need to see, we need to follow, and we can run the project, such projects. And I have written on project for the same STA hub development for 3D printing. So this share is there in IKEA. You might be visited IKEA, or you might be followed in the Google about the IKEA. So what they are supplying, this table they supply, this table they supply, but they will supply with a one pack. So you open that pack, then you can find this is one leg, that is and multiple leg, and you will assemble it. Okay. So once you assemble it, if one of the leg is broken, then that is useless. But what we propose that if one leg is broken, then by using the 3D printing, we can design that leg, or we can support the some handicapped people, and we can design their things, or we can design some good toys. Basically, toys are generated from the one model. Okay, some model car designing in the plastic they dump it and they'll get the means some dye will be there. From that, hundreds of toys will be created. But we are not meaning for the means 3D printing is not for making the dye because it will take time. Means from the die they will make the hundreds within a couple of minutes they can make hundreds, but 3D printing will take time. So the things means drone components, the drone parts we can design from the 3D printing. So likewise we propose and we have asked more. Basically why our project is rejected, we asked 4.5 crore. So there might be we ask them more, and there we might be failed, and we are thinking to rewrite that project with a smaller
Sir,
budget.
same proposal can you submit to other agencies
If
or
it
bodies?
is if it is rejected,
Okay.
if it is rejected, then you can submit to somewhere else by modifying. So okay, with this I'll stop here.
Good afternoon, dear participants. Thank you for sharing valuable information, sir. It is an honor and privilege to felicitate today's research person, Dr. T. Ramesh Garu, who has has truly enriched us with his knowledge and insights. On behalf of Vignan Management and Principal Sir, all participants, I would like to express my deepest gratitude to Dr. T. Ramesh Garu for taking the time for more expertise with us. The presentation today has been insightful and thought provoking, sir. I would like to invite Dr. K. Rajni Madam, the convener and head of the Department of EEE, to join with us. As a token of our appreciation, we would like to present with you a small video, sir. Please accept, sir.
Thank you. Project one. Switch off. Thank you so much, sir. Very useful, sir.
పెట్టేసి దీంట్లో పెట్టండి. అది మధ్య వస్తుంది. నెట్ కనెక్షన్ నెట్ is connected and dash back side and dash side side ఇప్పుడు బయట ఈ సైడ్ గూగుల్ అప్లై చేయండి. అది కూడా ఓపెన్ చేసి పెట్టండి. అది ఓపెన్ చేయండి. అది అప్లై చేసుకోండి. అది క్లోజ్ చేయాలా?
డూప్లికేట్ ది స్క్రీన్ అంటే సార్
ఇప్పుడు వస్తుంది సార్. ఇది ఇప్పుడు చూస్తుంది. రైట్ సార్. ఓకే రైట్. పీపీటీ రన్ సార్. Good afternoon. The 10 sessions are completed. This is third session today. So the in overall, this session number 11. The session number 11, the title is Present Status of Agri PV Systems in India. As a coordinator, I have to give the two sessions in the advanced FTP as a part of the faculty development program. Now this is a plan of presentation. So the solar applications to agriculture activities. Here I will take one specific example. What is the conventional method of doing that particular agriculture activity, and then what is a solar based solution. After that, how we are able to integrate the solar and agriculture. What is the basic idea behind that? Why agri-voltaics are so popular nowadays? In the other countries, what they are doing? So, what is the status of other countries? After that, you will see the status of agri PV systems in India in the interactive way, and then we will see the resources. What are the different types of resources? Because these are latest topic. In India, it is a advanced topic. Maybe other countries, advanced countries, maybe this is a old one. So how we are able to adapt agri PV systems in the Indian scenario. That is the main presentation of outlines of today's presentation. All of you see this slide and tell me, can poultry farm considered as a agriculture activity? Most of the participants thought that it is not a agriculture activity. All of you think and tell me, is it poultry farm considered as a agriculture activity or not? Yes, the poultry farm is considered as an agriculture activity. The agriculture is a cultivation of a plants and animals for the food and other products. So these are related to animal. So therefore these are considered as a agriculture activity. So in this we are going to take the specific example, that is a generator, because we are belongs to the electrical engineering. The generator conventionally how the generator is used in poultry farm. Then we will discuss what are the disadvantages of the conventional DC generator. After that, we will see the what are by adopting the solar, what are the advantages. Like that, we can discuss these. I have taken the specific example. The many resource persons explained many of It is a common to use kerosene, diesel to power the conventional diesel generator in agriculture applications. While these systems can provide power where needed, there are some significant drawbacks. The fuel has to be transported to the generator location, which may be quite a distance over some uh, challenging roads. Their noise and foams can disturb the livestock. Generators require a significant amount of maintenance. Like all mechanical systems, they break down and need replacement parts that are not always available. For the many agriculture needs, the alternative is solar. The modern society, it is solar is simple to maintain and it will provide energy that is needed where it is useful for agriculture kind of thing. There are systems that have been tested and proven around the world to cost effective and reliable. There are always rising levels of agriculture productivity worldwide. If you see the solar, if you replace with conventional DC generator, non DC generator, so with the solar application, actually the solar system, solar, there are two types of applications are there. So the one is generation. So the PV systems, so convert the solar PV systems are used for generating the power, electrical power in the large amount or in the small amount also. So the next one is the solar is used for the heating application also. These are the major applications of a solar. First we will see the generation, the power generation. After that we will see the heating. So the here generator, I have taken the specific example that is a conventional generator used for poultry. So the first we will see. So the this converts this a PV cell converts the so the sun light energy into the DC. The output of a PV system is a DC. So the in the DC in the low actually the loads are the AC. So there we need to convert DC voltage into the AC voltage. For that we require the inverters. So if the large amount of power is generated, then so that amount the power is transferred to the transmission line. So that then in the daytime only we are able to generate the power, solar power. The rest of the power is stored in the batteries. So that is called the energy storage. So in the agriculture we need to run the different operations we need the electrical power. Suppose if you generate the power required for agriculture or so the here we have taken the poultry farm example. So there in the conventional case we required so the diesel in this case so the transport the diesel there is no need to transport the diesel if you adopt the same location if you adopt the PV systems. So that is one advantage of a solar system. The solar has many advantages for the poultry farm case. I have taken the example poultry farm. The first one is reduce the energy cost. Solar panels can help farmers produce their own energy, reducing their reliance on the grid and lowering the energy cost. Reliable energy source. The solar is a reliable energy source. Solar panels can provide reliable source of energy during the power outages and can help farmers become less vulnerable to the power outages and other outages. If you see the investment in the sustainable practices, the farmers can invest more in sustainable practices like soil health and biodiversity after saving on energy expenses. Now these are solar, if you adopt the solar system in the poultry farm, these are the advantages as compared to the conventional. So conventional diesel or kerosene is used, so therefore the noise will, the noise problem is there. So in the solar system there is no noise, and then maintenance cost is less. In case of conventional, the more maintenance. That is a basic difference between the, so the conventional based generator and the solar based generation. So next you will see the power is required for water pumping also. The water here also conventional thing is, so here this motor is connected to the distribution network. So the motor basically converts the electrical to mechanical. So the one way of operating the water pumping system in the agriculture is by tapping the power from the distribution network. So that is a conventional way. Suppose this is replaced with the solar, so then the farmers can benefit it. That is, so there is means that the generation. So generation cost, solar power generation cost is less as compared to the distribution. So that is other application, that is the conventional versus solar based application. In fact, the water pumping is one of the simplest and the most appropriate uses for the photovoltaics. From the crop irrigation to stock watering to domestic uses, photovoltaic power pumped systems meet the broad range of water needs. Most of these systems have added advantage of storing the water for use when sun is not shining, eliminating the need for the batteries, enhancing the simplicity and reducing the overall system cost. Now coming to the heat applications, we will discuss one more application for the agriculture. That is so far we discussed the generation side, how we are able to generate the power. Then we will see the one application of a heat. Then we will move to the definition of agrivoltaics. Now another heating application. So the drying crops and grains by simply exposing them to the heat of the sun is one of the oldest and the most widely used application of a solar energy. But allowing the crops to dry naturally in the field exposes them to elements and contamination as well as the birds and insects. Now this is a conventional way to dry the crops and grains. Now you will see the solar solution. The solar crop dryers is a conventional method. This conventional method is replaced with solar. This solar crop drying. The solar crop drying uses solar energy to heat the air, which is circulated through the drying chamber to dehydrate the crops. This process will dry the crops. In the figure you can see the solar collectors. Basically, solar collectors use the black metal absorbed to heat air that enters from the bottom, and then the hot air is then circulated through the drying chamber where the crops are placed. The hot air decreases the air relative humidity, which increases its capacity to absorb the water from the crops. The solar crop drying has several advantages as compared to the traditional sun drying. It is a hygiene. Solar dryers keep crops in the closed system, so they are not directly exposed to it is easy to use the solar crop dryers. Next we'll see the water heating. So the another use of solar energy for the higher agriculture productivity is the water heating, particularly in the livestock operations. Now, now these are the different, we have compared the conventional method and the solar based applications. Now you can see what is agri-voltaic. So by seeing the figure, you can understand. So the what is the traditional way of farming? The agri-voltaic is a system that combines agriculture and photovoltaic technology in the same land area. In simple terms, it is refers to the practice of growing crops and plants under the solar panel, where both can be produced simultaneously. The concept of agrivoltaic has been around for several decades, but it has recently gained momentum as a sustainable solution to increase the food production and renewable energy. The integration of a solar panels with agriculture has several advantages, including the maximizing the land use efficiency, reducing the water consumption, increasing the crop yield. Now these are the advantages of a agri-voltaics. So all of you observe the traditional farming and the ground-mounted solar plant. In the we are observing the land, some amount of land is used for the farming, some amount of land is used for the ground mounted solar plant. So the here the agrivoltaic system means the combination of the traditional farming with the solar plant in the same land. So the farming is done as well as the power generation is also happens. That is the integration of agriculture with the solar. That's why this is called agri PV systems. In the literature, it is in the literature agri PV system. We are going to observe these are other name. The different names are there. Agri voltaic is also other name for the agri PV systems. Food security and the rapid role of a large scale renewable energy production are critical for the sustainable development. For both required the significant areas of land without adequate planning may compete for finite land resources. In coming years, increased food demand due to the Indians' rising population and improving the living standards may put a pressure on agriculture land resources. In addition, in very short term, the governments have accelerated a push for localizing the both food and energy production. This underscores the importance of early planning by policymakers on links between the food, energy, and land. Agrivoltaic is one of the solutions proposed to address this potential conflict. Agrivoltaics refer to the simultaneous use of a land for agriculture and photovoltaic power generation. The figure in the figure you can see this is achieved by the designing the solar power plant to enable farming between or below the panels on the land that would otherwise remain unused. So in India, agrivoltaic is still limited to handful of pilots and has not reached the commercial scale. In the in India, it is not reached the commercial scale. However, existing schemes would facilitate the widespread adoption of a practice. So the government of India, that is the PM Kusum scheme, promotes the solarization of agriculture. Among other strategies, the scheme promotes the setting of a small scale decentralized grid connected solar power plants on farmers' land. continuing cultivation to continue. This provision enables the adoption of agrivoltaics under JAYA scheme. So that is means that here the limited opportunities are there in India. So to adopt the agri PV systems. Now before going to discuss the status of agri PV systems in India, we'll see what other countries status. Later we'll see the status of agrivoltaics in India. The major developments in agrivoltaic system, if you see the countries, that is China, Japan, Germany, and Italy. So China installed the capacity of agrivoltaics 1900 megawatt. The promotion through the PV poverty elevation and power generation front runner based schemes. So the China is, I can say the China at present, the China is the, so the more number of agrivoltaic systems are installed. Next coming to the Japan, the installed capacity of agrivoltaic is ranging from 500 to 600 megawatt. The promotion through feed in tariff scheme with the preferential treatment to the agrivoltaics. Coming to the Germany installed the capacity of agrivoltaics 15 megawatt. The Germany regulator, Germany also, so the Institute for Solar Energy Systems published new guidelines on the agrivoltaics. But in India, so there is still now there is no guidelines. So we need to establish the guidelines. We need to frame the guidelines in the Indian context. So the Italy also invested more amount of money for development of the agri PV systems. Now these are, so the mainly agrivoltaics, there is China, Japan, Germany, Italy. So these four countries are so the top to utilize the agri voltaics. Now here we can see the agrivoltaic projects in India. So what I am going to do is, first we will see the what are the list of agrivoltaics in India. Later we will see the, so the plant by plant, so the plant by plant. Now these first one is see the all of you see the table. First one is a project name, developer. Next one is a capacity, the type of agrivoltaic, type of crop, the commissioning year, additional remarks. So the in this table, so the try to identify, so what type of crop is cultivated. So that is important because in the Guntur district, the cotton and tobacco is famous. So therefore, from this table, we are going to identify, so the what type of crop is suitable. So what type of agrivoltaic system is so suitable for a particular area. Suppose if you see this table, fourth one, so they mentioned that is a type of crop is, that is a groundnut, so the cotton, right? So therefore, this type of structure, interspace overhead agrivoltaic systems are so already successfully completed. That is in the state of Gujarat. So the GIPCL plant in Surat. So this type of structure, that is a interspaced overhead structure. So this is suitable for the Guntur district. There is a cotton wherever the cotton crop is growing. So in that particular field or land, so we are going to use this type of structure. It is already implemented. So this is implemented in collaboration with the Anand Agriculture University. Anand Agriculture University. So the like that you can identify. So the what are the projects in India. So after that you can see. So the what type of structures I want to, so the provide, so the online by using the online we are going to study the each and every project. The first project is GSECL STPS Solar. These are located in Gujarat state. The developer is Gujarat State Electricity Corporation. The capacity is 1000 kilowatt. The type of agrivoltaic interspace overhead. The type of crop is lady's fingers, bottle gourd, and coriander, cluster, beans, tomato. So the here in the Narakoduru, so the tomato is growing. So therefore, this type of land, so you can see here interspace overhead. So by seeing the type of crop, you can select the type of agrivoltaic system because already tested. So based on that, you can select the type of agrivoltaic. So the here the first one is adopts the drip irrigation. So the Israel is famous for drip irrigation. Next, agri-based solar power plant, which is in the Gujarat state Kutch area. So the Gujarat State Electricity Corporation installed the capacity is 100 kilowatt. The type of agrivoltaic interspace overhead. So the type of crop, such as brinjal, cluster, beans, and coriander, ladyfingers, bottle gourd. There is a commission year 2016. So here also they adopted the drip irrigation. Number three, so the Umbrol. Umbrol is a very popular agrivoltaic system which is also located in the Gujarat state. So the here Gujarat Industries and Power Corporation. So the this industry developed the Umbrol distributed solar power project. The capacity is 1000 kilowatt. The type of agrivoltaic is interspace and overhead. So type of crop, there is a groundnut and a soya bean. Commissioning year is 2016. So this is a collaboration with Anand Agriculture University. Next, the fourth one is GIPCL plant in Gujarat state. So here the capacity is 1000. First four agrivoltaics are the 1000 kilowatt. Here type of agrivoltaic is interspace and overhead. Type of crop you can see the groundnut and the soya bean. So the millet, cotton. These also commissioned in the year 2016 in collaboration with Anand Agriculture University. Now, next fifth one is Central Arid Zone Research Institute. So, here the capacity is 105 kilowatt, interspace below the panel. Now, we will see so all the figures and the related data. Now, next one is type of crop is aloe vera. The commissioning year is 2017. It is equipped with the rainwater harvesting system. This is the beauty of this project for cleaning the panels and irrigation. In the video, I will show you video how they are cleaning the panels. Next, Amit University plant that is located in the Uttar Pradesh, Noida, Amit University. The 100 kilowatt agrivoltaic systems are tested. So these are overhead type system. The type of crop is brinjal, potato, mustard. This commission in the year is 2017. This here the beauty of this project is automated sprinkler system for panel cleaning. All of you try to know down some important points. At least try to identify the crops, then additional remarks. So next one is the next project is capacity is 200 kilowatt. Type of voltaic is overhead. Type of crop that is a brinjal, tomato. This commissioned in the year 2020. The panel mounted. The beauty of this project is a panel mounted on a towers at 18 feet height. Provide enough space for the machinery use. So the video I will show you. So the how the cultivation as well as so the machines are using in the cultivation purpose. Next, Jonagad Agriculture University, they installed capacity is 7.2. The overhead now this type of crop is a tomato. The commissioning is 2017. So no requirement for agriculture machinery. Ninth one, solar agri electric model, Ahmedabad, Gujarat. Here the capacity is 3000 kilowatt. Type of agrivoltaic is interspace. Now the type of crop is there is a bottle gourd, ladies fingers, the watermelon, turmeric, ginger, chili. This commissioned in the year 2012. The project is set for under the Gujarat solar policy. 10th one is the clean solar, that is which is in the Telangana, 200 kilowatt interspace. So the here brinjal, ladies fingers, onion. So 2016 it is commissioned. The project is a part of so the 33.6 megawatt ground mounted project. Now agri PV model plants, the Maharashtra. So these are joint irrigation. Capacity is 14.4 overhead. It is commissioned in the year 2004. Here, this project highlighted the so the tills allow the movement of agriculture machinery. Now, the National Institute for the Solar Energy, Haryana State, the 100 kilowatt capacity, the type of agrivoltaic is interspace below the panel. The type of crop is tomato, chili, flowers. So this institute is the planning to develop the vertical PV panel with bifacial models. That is a important point. So the Cochin International Airport, Cochin, Kerala State. So the here the interspace structure is used: vegetables, cucumber, and pumpkin. So the this Cochin International Airport, so they are giving the these crops, vegetables, cucumber, and pumpkin to the employees. Now the fourth one is grow solar. This capacity is 700 kilowatt. The type of agrivoltaic system is interspace below the panels. Onion crop. It is commissioning year is 2021. The project was set for the under the government scheme. Now, what I am going to explain to you is, I will show you each and every agrivoltaic systems in the state wise. I will show you all of you. Let me open. Yes. Now this wait, I will check. I am checking. The National Solar Energy Federation of India. So they provided data. I will show you. Yes. Now this National Solar Energy Federation of India, they provided lot of data. So in Indian context, so the first one is that is agrivoltaics in India. I will show you the map of agrivoltaics one by one. Now these are agrivoltaic systems in India. If you observe this, so the state wise I'm explaining you. So the see here, now these are India map. In the India map, so if you see here,
Passengers using Cochin International Airport in Kochi cannot miss the sea of solar panels on attractive land by the roadside and on the car park, powering India's seventh busiest airport. In a city that lies close to the equator, the sun's energy meets the airport's needs around the clock.
We produce the entire energy during these morning 10 hours, and directly we use some part of energy, and excess energy we will back to grid. And then during night time, we will take it back.
The project was launched as authorities searched for ways to minimize rising power bills. Doubts about whether the green energy alternative would be financially viable were laid to rest by the falling costs of solar panels.
We get back our investment in less than 6 years time. So which I thought was an excellent investment opportunity. And next 25 years is meant for all profit. So it has been a good capital investment and environmental friendly use.
After being recognized as the world's first airport fully powered by solar energy in 2015, the airport has been steadily expanding capacity to retain that position. Energy needs are ever growing in a city that is Kerala's commercial capital and a gateway to tourist destinations. Solar panels are being placed wherever possible, such as the car park and on top of a 2-kilometer canal. The carbon emissions reduced over 25 years will be equivalent to planting 3 million trees, according to estimates. And to make the green project even greener, vegetables are being grown under the solar panels.
So the beauty of this project is the vegetables are distributed to the employees. So that is the beauty of for this project.
The initiative is getting attention.
They have a demonstration effect also. So many people walk through the airport, and if they get to know that yes, solar energy is being utilized in such a fashion at such a scale, so that means it is something which is worth looking for. It's a viable solution.
The project has also generated interest in some African countries.
We have signed an MOU with the government of Ghana. We have had a team from Nigeria who are all interested in us helping them to put up solar panels in their own country, especially in the airport sector.
The Cochin Airport is seen as a model of how, from office and household rooftops to big infrastructure projects, Sun-drenched India is scaling up solar power.
So the see how they are cleaning the solar panels. So the cleaning is very very important for the solar panel to generate the more electrical power.
Anjana Pasricha for VOA News, Kochi.
Now coming back. So Kerala state we have seen that is a airport. So the now let me show you the next state. So in the Kerala state we have only one agri-voltaic. Now coming to the if we see here Andhra Pradesh map, there is no voltaic agri-voltaic. As we see here in this region there is no voltaic. But Hyderabad, so there are two agri PV systems are there. I will show you. Hyderabad. All of you see here. I am taking first this one. That is I think this the seed research technology. So these are institute where so the farming as well as agri PV by using agri PV systems they are generating the power. This power is utilized for their own purpose, and so the crop is also growing. Now these are Hyderabad one university. Next in Hyderabad one more is there, Jayasankar University. Jayasankar University. Let me show you that diagram also. This is Nagpur, Telangana. Yes, Telangana. And let me click this. me show you diagram. Now these are 1 megawatt agrivoltaics. They are generating the power as well as cropping also. Next, coming to Kerala state completed, Telangana state completed. We're looking for India. Kerala completed. Next, Bangalore. We can see Bangalore. The Bangalore one location agri PV system is there. Let me quickly calculate. So now these are 3 kilowatt agri PV system. Now let me play the video. There you can observe many things.
Right? The second part of the video of the agro-photovoltaic space. And agro-photovoltaic system or APV system is a practice of harvesting energy and information at the same space. That is, you use the same real estate space of the top space for both installing solar panels as well as doing some irrigation. In one of the previous videos, we have shown how cauliflower was grown.
So here the type of crop is cauliflower. Okay, so if you see here agrivoltaics in the not only we placed in the home also. So these are the size of capacity is very small. Now you can see here cauliflower.
The rows of the solar panels. In this video, we will show some of the other crops which have grown in this APV setup. You can see here, this is tomatoes. Okay, these are grown right below the solar panels. You can see these are fresh tomatoes harvested right now. This will go for tonight's tomato soup. So this is it's called the pattern, and this is called irrigant. So this is a creeper. We have used support the pipe and the gutter to spread this creeper. You can see the many buds and flowers of it's called coming up here. You can see some fresh buds.
All of you observe the structures of agri PV systems.
Precursor. So this is substitute support in Canada. In Indian unit is called bill. This is proven also right below the solar panels. You will see some fresh substitute support here. You can see some leaves here. So you can see lettuce coming up here. This is the basil. This is the nice basil leaves. This is one more Richmond plant. We have supported this with the rafter. This is also coming up very nicely. So these are some more plants here. You can see basil, ladies fingers coming up. Rosemary. This is Varga, Ghana. We call this Mushroom support. We have got some bamboo as well. Got this nice tomato, tulsi. Geranium is coming up here. Basil again. So now, below the solar panels here, they have made this small cooling on both sides. Even we have put this coriander coming up here. These are the nice palette. And on these pots, we have got again tomato coming up here. This fungus up here. And so we've got basil. Here you can see lettuce coming up here. This is a nice rose.
state, whatever the students develop will go will come first. Again, from the suppose this rosemary, the crockeries are coming up here. Manga, we've got beans coming up. You can see nice flowers of the beans. We will be able to harvest this in about weeks time.
So all of you observe the different types of crops.
Again, you got again this is the beans now. This is also now flowering now. We should be able to get good beans in about 8 to 10 days. Now this some tomatoes coming up here. So there are some flower plants here. So you can see the nice roses.
So the flowers also growing under the PV systems. So that is a thing we have to know down.
This is the classic one. You can see these are very fragrant and very beautiful plants. There's also a creeper. This can the supports of the solar panels, the rafters can be used to spread this paper. And there's one more extra plant you can see. See how nicely this is spread the screen of solar panels. In about 10 days, you should be able to get harvest from this as well. This is geranium. This is a very useful plant here. This will help to keep the pests away. So this is the upper part of the structure. Here the sunlight is little less. So we have put some areca palm plants here. Areca palm doesn't require much sunlight.
Yes, the shading effect is very important. Okay, so based on the shading effect, you are going to select the crops. That point is also very important. So the where you can do lot of research work, you can produce a more number of fibers, optimal the tilting angle optimization, genetic algorithm. You can find there is a TLDO like that. So that is the shading. Shading is also very important.
Yeah. So this makes a very nice plant for the sit-out. The actual table here is can be used like an office in the evening.
Okay, now we will move to the next state. We'll move to next state. The Kerala completed, Bangalore completed, map completed. Let me open. All of you see now the map of India, maximize. Okay, from bottom I'm clicking everything. That is Kerala state completed, Bangalore completed. Now this is Telangana two agri PV systems completed. So next we will move to Maharashtra state. We discussed the one article discussion also in the Maharashtra state. Now you can see, you can click. So this one that is a Maharashtra state. Okay, click this one. So now this agri voltaic. Now this 1.4 megawatt. The capacity is more as compared to the previous one. So this plant is located in Maharashtra state. So here the beauty of this one is under the PV panels, it is the tractors are moving. All of you see the image. So these are PV system under the PV systems. So now this tractor is moving. Okay, under the PV systems the crops are going. So therefore so the farming, so the different machines are required. So this tractor is one machinery. Now you can see this image under the PV systems. Now the crops will the structure. Okay, what I am trying to point is here the structure is important. Structure. Now this another image under location. Now see the view of a agri PV systems in Maharashtra state. So now see here, once these are interspacing. So panel is placed here, another panel also see the structures. These are flowers. Under the PV systems of flowers are glowing. At the end, you can see that these are 1.4 megawatt agri PV systems installed in India. Then you will see the I'm clicking the video. All of you see.
The rapid development of large-scale solar projects has become one of the major societal successes of our time. However, future adoption could be limited by shortage of suitable land as solar generation starts to compete with food production. To help resolve this conflict, Sunseed and Canova Energy, in partnership with German Development Cooperation, and in collaboration with local farmers, have set up an agrivoltaics facility where solar generation is co-located with crop cultivation on the same piece of land. This 1.4 megawatts agrivoltaics farm on 5 acres of land is part of a bigger solar project located in the Marathwada region of Maharashtra in western India.
Not 5 acres land is required here. They installed the agriculture system in the 5 acres.
The highlight of the project is the 1.5 acre, 4 meters elevated system integrated with a shade net house growing trellising vegetables, capsicum, cherry tomatoes, cucumbers, and beetle leaves, and shade-loving flowers, roses, hibiscus, chrysanthemums, and tuberose. All these crops are also being grown in an open area as a controlled environment. The innovative mounting structure uses Sunseed's tension cable systems having the same.
So the beauty of this project is this is made in all the structures and all the equipment is available in India only. We are not purchasing any equipment from the other countries. So that is the beauty of this project.
Design concepts as in suspension bridges. An easy to install and lightweight system is about 25% less expensive than conventional structures. The structures also incorporate several features that enable advanced agriculture, mechanisms for retractable shade nets, trellises for crop support, and bollers for temperature control. The shade nets can be retracted in just a few minutes based on the radiation intensity and temperature profile, which are monitored via weather stations to provide the optimal growing environment. In addition to the shade house, systems with lower elevations of 1.25 meters and 1.75 meters have also been installed, which incur only marginally higher capital costs than conventional solar projects. These sections will be growing turmeric, marigolds, melons, leafy greens, and innervated herbs. Initially, the land at the site was hard, clayey, lumpy, and full of weeds, making it tough to prepare the land below the panels. Many tractors with different farm implements were.
So all of you see here under the PV panels, tractors are moving. In the table we discussed at that point. Okay, so you can see here in the Maharashtra state the structures are placed like this. So under the PV systems the tractors are running.
Prepare the soil and create granular beds ready for cultivation. Apart from helping enhance crop yields, the shade house is designed to increase power generation as well. The higher albedo of the system, due to the highly reflective shade nets and mulches, along with the higher elevation and greater distance between rows of panels, is expected to double the bifacial gain. Separately, the cooling of the panels due to the evapotranspiration is expected to increase panel efficiency during the dry months. In a water-stressed region, it was imperative to have an efficient irrigation strategy. Water is being pumped from a well via a solar pump that connects to a drip irrigation network, which is triggered based on soil moisture sensors installed in each crop section.
So the see here you can monitor the moisture content everything by using the sensors. That is you see here in the video.
Evapotranspiration of the shade is expected to result in additional savings of 30 to 40%.
Sometimes the water is not required, then so automatically it is possible to stop the water. Okay, that kind of the sensors also available. So that kind of sensors also we can use in the agri systems.
Rainwater will be harvested via a drainage network aided by trenches below panel edges and gradation of the land, such that the water flows to the natural drains in the periphery where it gets stored via a check dam. The solar panels are being cleaned via automatic cleaning robots, which are shifted from one row to another via an elevated walkway and supplemented by occasional water cleaning. The project is set up with IoT-based instrumentation to enable extensive R&D. This includes developing elevated walkway and supplemented walkway. The solar panel walkway and supplement. The project
Yes,
is.
see here, all of you see here, how they are cleaning the solar panel with the help of a this solar panel, so that they are spraying the water by using the water, so that it is possible to clean the solar panel. Okay, so that is another point we have to know.
The project is set up with IoT-based instrumentation to enable extensive R&D. This includes development of photosynthesis response curves and measurement of temperature.
Because this new technology, so the lot of research work is going on. Many agriculture universities, especially in the Telugu states only, Telangana, Jayasankar University, they installed the small agri systems. They are testing, the testing stage only. In AP and Andhra Pradesh, there is no agri voltaic systems.
For simulating crops yields and accurate bifacial gain analysis using spectrum radiometers and albedometers. The research will help develop crop-specific technology.
So the different types of equipments are used, okay, to measure the different quantities. The temperature you can measure, so the wind speed you can measure, so the like that to optimize the to optimization you can get the data. Okay, that kind of data is collected from using the different
Commercially viable and bankable projects. Agrivoltaics can have a profound impact, creating integrated, sustainable, and climate-resilient food water energy systems. Agrivoltaics can increase crop and energy yields while reducing the use of land and water, helping form a win-win partnership between solar developers and farmers. Come, join us in this journey as we discover new facets of the fascinating world of agrivoltaics.
So actually, the India is joining with German cooperation. German cooperation. This project is also we have cooperated. We are doing the work along with Germany. Okay, so the next we move to next state. Maharashtra state is completed. The Maharashtra state is completed. So the next one more, all of you are trying to see the all the projects. Okay, just click, then you get the information. So the now this Nasik, you can click Nasik. So the filter Nasik. So there you can get the lot of information. Means that the agri PV systems, this company under the developed funding. This is a funding agency. They got the funding from the agency. So that kind of information is also available. Next we see. Let me click the next project. Yes. So the next one is Google. So these are a total 7 megawatt agrivoltaic systems. Grow Solar is a company, so it is a very good company. So they installed the 1 megawatt agrivoltaic systems. Just click it, so that then it is an image. So under the PV systems, see animals are so the running. This project capacity is 1 megawatt. Next you can see here Rajpur, yes, this one. So now these are Junagadh University, Junagadh. So the installed capacity is 7.2 kilowatt. The power they are generating the power, that power capacity is 7.2 kilowatt. So now let me click, so you can see the agrivoltaic systems.
A little bit more to the development of agrivoltaics in India. Small country with no issues with water. Clusters of around 18 solar panels are being put together in this design. You see, they have.
So this is located in Amrol. Amrol agri PV system is very popular. So you can observe in the research papers also. Amrol is very popular in the field of agrivoltaic systems.
Panel spacing.
This capacity of Amrol is 1 megawatt.
Here.
If you see from the top, this look a very beautiful figure you can see. That is Amrol.
You can just see from this aerial view with the different shadows, and you see that you see the pipes here from the drip irrigation system being implemented. There's another view. You see the height is up to 3 meters. They are varying with the heights.
So these also tell me, so what type of agrivoltaic system it is? Just observe and tell me. So the in between here the two rows are there in between. So the crop is growing. You tell me. So what kind of agri system it is? Interspace or overhead? What type of agri system it is?
Interspace.
Yes, sir. Yes, it is correct.
And yeah, as you can see here in the next photo, they have a manual tilting. So what you can see here in horizontal.
So the see here how they are placing the tilting angle. Okay, so normally in the research persons, the Dr. V. Sandeep Garu explained. So the 45 degrees to 60 degrees like that. So but if you see here the placement of PV systems.
It might be difficult to get below with the tractor, so then it becomes interspace farming. They have done several tests just to get an.
So these are testing agriculture university.
Yeah, to get an idea, even the realistic models have been produced in advance to check for shading effects. In SketchUp Pro, they did shading analysis. And yes, but at the end of the tractor, for example, here, the escape doesn't fit below the solar and horizontal node, then this area might not be useful or not be able to be worked on, at least with the heavy machines manually. And again, cleaning an issue in India, it is required. I think an apple each 10 days they're cleaning the solar panels with water. So if you put the structure too high, then cleaning of the panels becomes an issue. So this is why they choose a design where the panels are not that high. But again, if you
here the more height is there, then it is very difficult to clean the solar panel. So that is a point you have drawn. If the height is less, then it is easy to clean the PV systems.
that high, then heavy machinery might not be able to pass through. Another plant here in Basta, that's an exact copy, not too far away from the other plant I showed you, also 1 megawatt plant implemented by the local utility. You see that even though there's no agriculture being practiced, but yeah, wonderful agriculture is happening here also since 2016. And as long as you do manual harvesting or manual working of the soil, then definitely there is no issue. But yes, in other places they decided, okay, let's make it higher. We really want to go through with heavy machinery, so they decided to bring the height up to more than 3 meters here in Anantanaru, in Gujarat. Drip irrigation being implemented. As you can see, panels are now at a height where the tractor really can pass through. But yeah, if we are talking about manual tilting, these segments, I think here it's 20 solar panels.
So see here, there is a manual tilting. Actually, in the literature, many motors are motors are used to tilt the angle. So these they are doing manually. Okay, all of you observe here, many persons are there to shift the angle of a PV system. That is another.
Quite heavy. And you need up to 10 persons to actually, or even here it's, I think,
see here, the first one is some angle. So the next one is, if you see here, they are changing the angle. So see the difference here. Okay, this panel and this panel, see the difference. So they are moving the panel angle manually.
To do the tilting of the solar panels. And yeah, that involves quite some labor, and there might be a challenge. Another challenge experienced at Sika plant was that the cleaning water running and dripping down was actually hurting the plants. And the farmer was also complaining that the cleaning people which use the stand here, for example, were parking his plants. So in this plant, which I'm showing you here, Sika, unfortunately right now, agriculture is not being practiced anymore. But yeah, we're looking forward to GSECL to actually revive this plant and come up with agriculture again. But yes, cleaning big issue. Currently, the Indian government-owned research institute made a different.
So this 105 kilowatt which is located in the Jodhpur.
Approach. They said, okay, let's check what's possible with interspacing and what's possible with the load mounting height. So
the all of you see the observe here now this on the top of the panel. So the here the lot of dust is accumulated here. So the here they are cleaning. So the see the difference. Okay, this is see the difference here. These are cleaned one. These are uncleaned one.
the pilots have been installed, and they just said, okay, let's vary with the spacing. I think Dr. Sandra is also here.
So this kind of analysis you can do with the softwares.
Jay, you'll be able to get in touch with you in the breakout sessions, and also Dr. Punya the afternoon or the evening will have a presentation to give some more research insights into this plant installed in 2017. And what we could really prove is that even with the low ground mounted agriculture was successful.
Now this Rajasthan Jodhpur, we discussed one article paper in the Rajasthan, Maharashtra. We discussed the article discussion also. Okay, so these are the practical agri PV systems. All we observe. So the rather than seeing the studying the theoretical, if you see the practical one, then you can get the points easily. So that's why I have taken this topic, the status of agri PV systems in India.
Practice below. So you see with the drip irrigation, plants are growing below here, elevator, and with the higher structures, even with so much shade, it was possible to really do agriculture below. But yes, at the end, it's the farmer who has to accept to do the agriculture below.
So the see here the how the panel size, angle, everything. Okay, so the previous structure, the different structures are used based on based on the type of soil, based on the type of crop growing. Okay, based on that you can select it, because the location, based on the location also we can adjust our the PV panels.
You can see, is it possible? Counseling has proven yes, it is possible. Is it practical? Maybe not. At least with this mounting structure. So the question is, to which extent actually the farmer is being involved with really willing to do agriculture below. Here is another example. So plants are growing, but for the farmer it might not be the most convenient to work below. What they really came up with is a quite innovation which we have not seen before in other countries, was because cleaning is such a big issue, rainwater harvesting and cleaning water harvesting with the rain gutter. They installed 100 cubic meter 10 water storage tank. Beautiful idea, which water then can be reused for irrigation.
Yes, in the table we discussed now. So that's the main beauty of this project is a solar panel rain water harvesting tank. So they constructed because under the panel, suppose not under the panel, crop is growing. So when rain comes, they have collected the water. So that is easy for harvesting, rain harvesting. So that is the beauty of this project.
Other approach here with one of
so that water is accumulated, water is used for cleaning the panels.
Builders agrivoltaic plants, at least, let's say interspace farming is being practiced here by Atal Clean Energy, I think since 2012 already. It's a larger commercial plant, but they decided to use the space in between for agriculture, and they're just using the cleaning water to water the plants below. Usually what we see in India, the interspace farming is being practiced, that the plants are being put.
So the see here under the PV panels, the farming is going on. See here.
On the higher side of the solar panels, because the water falling down from the lower side, the drips might hurt the plants, especially if the mounting is higher. But then in Kochi Airport, I think now we have over 20 megawatt installed. There we brought it to another level. Kochi
12 megawatt airport in Kerala, Cochin airport. They are also we discussed at the point that so they are growing the vegetables and those things are given to the employees.
They started. And you also see agriculture being practiced in the space and we know the higher side of the solar panel. Really impressive here. This airport is net zero already with so much solar installed. And you see there's almost any square meter left except for landing space and the place where the airplanes are stationed. And this is the part here where agriculture is being practiced on this 12 megawatt. But cleaning is also an issue there. Again, cleaning has been done with water, and again, the agriculture is being practiced on the larger part, on the higher part of the site, and on the lower side, walking bins are being installed. Another pilot here in Delhi, the capital of India, they small plant.
So this plant is near to the New Delhi, that is a Haryana state, where the flowers are
With
growing.
flowers, also special potato varieties, mainly in the space. If we go back to
so these are also interspace in between farm and forest place.
might be familiar, J irrigation, multi-national conglomerate, $1 billion annual sales, mainly in drip irrigation systems, listed at the Indian Stock Exchange. They experimented already way back in 2012 and then 2014, and they said,
this is located in the Maharashtra state.
okay, let's
Jain irrigation system located in the Maharashtra state.
And here, for example, cotton and lady fingers or an Indian program is being grown. I think last year, 2019, yeah, not 2019, it was no, 2020, so last year.
This plant is located in the Uttar Pradesh, Agra.
This plant has been commissioned by the agriculture.
The capacity of this plant is agri power system is 200 kilowatt.
JAYABABU, close to Agra. So whenever you come to India to visit the Taj Mahal, it's really just a few meters from there. You might be just pass by and have a look at this concept. What's interesting, they're experimenting with glass bifacial modules combined with monofacial modules. Different panel patterns are being experimented with. I think Professor Ricky Jane is also here with us today. Interesting.
This Amity University, that is 10 kilowatt.
So where they really say all the cabling has to stay below, has to stay above the agricultural activity, but also installed.
So if you want to do any kind of analysis for an educational institution, you will require the space requirements. So the Samiti University, they are providing a lot of funds to do the research work.
To actually automatically clean the system. Not sure to which extent draining is an issue, but yeah, they're collecting the water with the rainwater also. A lot of research has been produced. I think this plant was installed already in 2017. Here the manual piping system for water for cleaning the solar panels. Getting back to Jane irrigation, impressive research being done here from this plant.
So now this banana under the PV systems, banana is growing. See here.
14 kilowatt banana pilot. They have also experienced with the corn tracking system here being installed. As you can see behind, you see here interesting pilots where they experiment with low methane and low CO2 emitting lights.
So observe here, we discussed the motor. Okay, so the motor is used for the different purpose in agriculture. So all of you see here.
Rice growing is a challenge in terms of climate change, and we are also experimenting with different panels. So here you see they change the panels and put a higher cell spacing with some transparency to actually get more sun.
These also Jain irrigation private research. All of you see
they have
here,
the largest greenhouses installed in India. Now with the bifacial glass module,
these are bifacial PV systems.
beautiful to see these kind of developments by chain irrigation. Going back to research, one could really say that the Junagadh Agricultural University.
Junagadh University, we discussed the article research paper. Okay, that paper we discussed the details, the nameplate, the details of PV systems and what is the size. So there we discussed the efficiency, key parameters are discussed, PR ratio, efficiency. Okay, like that we discussed the paper. This is the actual thing. Now we are practical plan.
Produced, yeah, maybe most of the scientific papers available in the international community. They have also they make good experience with tomato. They have also they tested plant growing availability. Besides, so I think Dr. Professor Chauhan is also here with us today, and he would be glad to actually exchange his experiences with you with this wonderful tomatoes being grown here at Africa. Latest plan I'm going to show to you is this one, just commissioned a couple of days ago in 2021. In which one? This is one.
So now this 110 kilowatt agri PV systems which is located in the New Delhi.
110 kilowatt agri pilot, and what's beautiful to see is that they have installed and actually combined all the learnings from the other plants, mistakes that have been made, they have been put. So they start with the, let's say, pilot Y structure. They have installed the rain gutter system. They have installed drip irrigation. They have
so the see here under the two
larger spaces in between the rows.
So this structure is useful for so the when water is going, so the here there is a chances of decreasing the mechanical strength. So therefore you have to select so the material in such a way that so the mechanical strength should be more. That is style.
Beautiful to see, and we're looking forward to
This one.
how
Now I
they
am placing
actually
this one.
deal with the plane
If the water is flowing like this, so it will be corroded. Okay, to avoid the corrosion, so now normally we are going to plant the production. Okay, the production.
Checking here, 400 kilowatt peak total plant size is about, I think, 5 megawatt.
Mahindra, this 400 kilowatt P Mahindra, which is located in the Telangana state.
On 400 kilowatt part, they are doing growing lemongrass, beautiful to see. And that actually leads us to the last slide, which I'm going to show you. We really believe that cleaning is one of the biggest issues, and we are really hopeful that with new cleaning technologies like robotic cleaning, in this case, here by Ethiopia, combined with the
okay, now we'll move to next one. I will show you. We'll move to next one. Here now this is India map. Now let me click Gwalior. Near to the Gwalior, one more agri PV system is there. Around New Delhi, all of you see here, observe this. Now these are 1, 2, 3, 4, 5. 5 agri PV systems are available. Rajasthan state, we completed that one. Jalandhar, let me click in Himachal Pradesh. Let me click the Himachal Pradesh. So see the details here. See the details here. Now these are see the solar power plant. Now these are 250 kilowatt agri PV system in the Himachal Pradesh. So I can click and you can get the information. So the here the capacity is mentioned. Then we'll get some locations. We will see the pictures. Some location we can see that they will upload the videos. So the only limited number of agri voltage systems are there in the India. So the all of you see here figures. Now these are okay under the let me see the Jaipur. Okay, from bottom to top, we are coming. Now is Himachal Pradesh. Is ending. This one last one. Himachal Pradesh is the last one. Okay, so this is the top. Let me click this. Let me click. Now you can see the details. Now you can see the details. So that is a 250 kilowatt. Okay, so I think that is completed. Okay, now you can see in near to these are Gujarat state. Okay, let me click this. Let me click this. Now this Arsha 1 megawatt power plant. Sorry, 1 megawatt power plant.
A little bit more through the and yes, we have the exact copy, too far away from the other plant that I showed you. That's a 1 megawatt plant implemented by the local utility, practice below, plants below. Hugely
So the they have because they have placed the same video because so the 4 5 agri positions are made in the
as if
video.
last year,
So that's why
2019,
we are seeing the same
2019,
thing.
it was 2020. So last year, this plant has been commissioned.
Okay. So the next we will see. So this map is completed. The map is completed. Then whenever you have a free time, then you just see the. I will send you the link. I will send you the link. Then see the all the about them. So it is not possible to complete all the things. So I completed there's a few agri PV systems. So now these are agri PV systems. So now this site gives a lot of information related to research work also. Okay, I will show you what kind of research papers are available. So now these are you see here. Now these are important the important publications. Okay, if you click, you can get the more information. Okay, publications. So this let me read some of the research publications. Now these are agri-voltaics in
Sir, one doubt, sir. Is there any online courses on that agri-voltaic cell, sir?
So that actually NPTEL there is no course which offers the on agri PV systems. Okay. In Udemy, okay, in the Udemy, one course is there. I will show you. Udemy, one online course, the fundamentals of agri PV systems. Agri PV systems. So here, not fundamental, introduction to agri voltaics. So the click here, I completed the course on this course, introduction to agri voltaic systems. So the actually it is not a free, you have to register. So at that time, that is they have charged the 500 rupees. Now this course, now we are getting the 399 rupees. Okay, so everything it is very nice course. I am standing here because of this course only. I learned many things from this course. So I completed this course. That is an introduction to agrivoltaics. They have given the classification of agrivoltaic systems, the types of agrivoltaic systems, history of agrivoltaic systems. So like that they organized everything in a sequential. So if you want to see the overview of this course, some videos are free. Let me click. I will show you. The see here. Now these are course details.
In this session, we're going to be talk about agrivoltaics. What exactly the agrivoltaics word that means and how the system will going to be developed and recorded. Agrivoltaics are also known as the agri-photovoltaics or a solar farming that we can say. General farming and general solar panel installation that we see on the ground surface, this is a different kind of phenomenon that we can observe. On a one land, there is a solar power plant has been installed in the ground mounted project, and only the power plant will be there. There is nothing of farming.
So this course is very useful. They organized each and everything in order. So the lot of information is available. But the main thing is here they are not providing any so the PDFs. Okay, so the you can learn from videos only. So it is PDFs are not available, notes is not available. Okay, from the video you can learn.
And as we know that in the world, how much amount of the land is available, which is under the cultivable land or under the agricultural land that we can see. We'll find that many developing countries are depending upon the agricultural sector only, and that is why if we integrate the solar photovoltaic power generation with the agriculture itself, it can able to save the land also, and that can also impact some amount of power generation and reduce.
Okay, so the like that you can learn easily. So the let me move to this completes the wait. So this completes the yes. Okay, these projects, all of you go through the all the table. Okay, so almost we have completed all the projects mentioned here. Jamnagar, Gujarat. What is the type of agrivoltaics? So here the physically you can see. Okay, we are in the by clicking the India map. So that you can select the location. If you click that, you can get the information. So if you don't know the what kind of structure, so that just see here this table and that video. So then you can get the what is the actual the picture of interspace and boundary like that. Okay, this type of information. So that all of you so that take this table as well as the videos. So that from that you can get the practical knowledge. Okay, so these are things. So next coming to the next one is. So the next we'll see the what is the future perspectives of agri PV systems. The overcoming the multi challenges in implementing the agrivoltaics requires the coordination approach from all stakeholders, which can be best facilitated by union government through the creation of a joint working groups with the state officials, the knowledge and institutions, private developers, and farmers representative. So that in that way you can overcome the challenges, the coordination of all the stakeholders. So next point is Indian government can support the collaboration. Already some other countries, we have in the PPT have shown there are 4 countries. So you have to collaborate it with other advanced countries. Then you can implement the agrivoltaic PV systems. So the next one is in India. Main problem is there is no standards. So still now, so the standards are not developed. So the standard definitions are not defined in the context of India. So that is that should be done. So next one is some pilot projects. Already we have seen the small amount so that the size. So it's not a commercialized so far. So the next one is you have to build the business models. So the business models can so they help the farmers to increase the revenue. So that is the thing. Next one is the partnership. So the states needs to forego the partnership with several stakeholders, including private developers, farmers, financial agencies, and knowledge institutions to integrate their purpose into the policies and regulations. So the next one is incentive. So the government should initiate. So like electrical vehicles, they are giving incentive. So like that, the PV systems also they are providing from the solar point of view, solar panels panels they are giving the subsidy. So that's why they have given the Gujarat state they developed the more than 4 agrivoltaic PV systems. That we need to do. The next one is you have to establish the centers of excellence. So the state government can support the establishment of centers at universities and technical colleges to facilitate the capacity building through the training programs like this. So for farmers and private developers. So with this My the presentation is completed. Let me conclude. If you have any doubts, so you can ask me. After that, I will summarize the today's all the sessions. If you have any doubts, feel free to ask. Okay. So now today we had three wonderful sessions. The two sessions taken by Dr. T. Ramesh Garu, NIT AP. He explained the many concepts related to agri PV systems and how to write the paper, how to write the funded projects. So the sir explained the excellent way. So the last session, I had explained the agri-voltaic PV systems in the Indian context. So I explained the India map. So by using the interactive way. So this about the today's FDP schedule. Next, coming to the tomorrow session. Tomorrow, Dr. T. Vinay Kumar Garu, NIT AP, he will take the two sessions. 12 to 1 and 4 to 5. So we have article summary. All of you we have already sent the PDFs. So PDFs to the in the group, and also we have given the hard copies also. Both the soft copy and hard copy is given. So all of you try to study those things. Then we have to summary, article summary, 2 hours. Tomorrow we have 2 hours on. You have to work on article summary. You have to complete. That work should be completed. So the all the theoretical sessions will be completed. After that, so the 3rd December, 4th December, 5th and 6th. These 4 days we have to visit the industries. That is with this today's session concluded.